Day 3 of ERC2020, dear all. Quite like you saw on the screen a second ago. Łukasz Wilczyński is with me in the studio, representing the organizers of this event, the main organizer. Welcome. Hi, good morning. The third day. Well, we feel a bit sad because this is the last day, but at the same time it's the greatest day because today we're going to learn about the final results. Tell us what happened on day 1 and 2 and what might we expect of day 3. Well, sad or not, because today is the last day of this ERC and tomorrow is the first day of the next ERC, because then that's when we start working on the next edition. Yeah, maybe next year we can show you on the screen what stage we're at. Right, going back to day 2, to yesterday, a lot happened on many sections. A lot of new rovers, new tech and others, so ever more rovers per square meter. Of course, they are not covered by the restrictions regarding the number of people per square meter, so they're free to roam around. We had a very interesting situation yesterday on the robotic arm competition. The Scottish team did a great job. They completed 3 tasks in a row with no stop, no pause at all. That's how I imagine Scots. They were the only team who carried out 3 tasks in a row. We are all very amazed by that, by their feat. Very interesting lectures yesterday. The first one about the risks connected with space travel, and I thought that through afterwards. I looked into what was said. I think that was very interesting, but I still think that it was just the tip of the iceberg of the whole topic. But I'm sure we could have a whole day of the conference about that topic. Also, we had an interesting lecture on Polaris. About the protection of dark sky. We started looking into the stars with the bare eye in the past. Then we used all kinds of equipment, telescopes, and now there's talk about Starlink satellites orbiting around Earth. And as far as I understood, there was an appeal for keeping some spare room, as long as we want to observe other planets, to have some dark sky protected, spared for the observation of the space, and I definitely support that. It would be great to have such places, such spots in Bieszczady, for example, because there's no more beautiful thing than, lying on the grass and staring at the Milky Way. That's absolutely stunning. It's something you have to experience once in a lifetime, at least. I recently saw the Milky Way from in front of my house, which I was amazed by. This proves how small we are in the whole universe, how humble we should be towards the universe instead of installing tons of garbage in the sky. Of course, new installations are going to appear because it's a natural consequence of our development and going forward, so you can't go around that. But I'm happy that there are all kinds of solutions darkening the satellites so that they do not impact our observation of this space to such a big extent. Romulan, I don't know if they want to help us in terms of those solutions, but maybe we can borrow something. Like in Scandinavia. It was, you didn't have to ask, you just took somebody owned by somebody else because, it was natural that you would give it back. Today we're having also the other competitions until noon, I think, until 11:30. Exactly. Still competition taking place on the Mars Yard. Even after that, there are events taking place on the Mars Yard. I think that after the competition we can let those big student rovers on the Mars Yard so that they can level the ground. Yes, we'll let them have some fun on the Mars yard, because they've been preparing for that since yesterday. I think we can have that. We'll see. We have nice equipment. The rovers are definitely competing still today. Remember that we are moving on with the presentations, lectures. We're holding some discussions. There are a few prizes to be awarded still. Of course, the main three first places today in the afternoon. But we've already had the first results in the science category, and we are getting prepared for the closing gala. Regards to our viewers and the viewers in front of the Technical University watching us on the big screen, if you are in the area, please join us. Remember about the restrictions. And yes, let me pick up on that. We had a situation yesterday. There was a person who didn't want to put on a mask, and it was rather a difficult situation. The person did not want to put a mask on, and they wanted to enter the premises. I understand freedoms, etc., but you know, of course, this is an open event, but we have to follow certain rules that have to be observed. There are certain stipulations we have to follow, and we want to protect people who decided to be in the zone. I see no problem with taking temperature measurements, body temperature measurements. There's, you know, it's no interference with your freedoms. It's just following basic restrictions, basic rules. I fill out the form every single morning, and my body temperature is measured because I'm part of the team, and I have to go through the exit there and back dozens of times per day. But no, we agreed on certain rules. This is a social agreement. The ministry is here, the epidemiological services are here. We have to follow some rules. We agreed, okay, you can come in, but you have to put a mask on. And well, the gentleman didn't want to put it on. We said, okay, please come in, you don't have to put the mask on, but please keep social distance. It's not about the coronavirus, you know. Somebody might have a common cold or the flu, you know. We don't want to spread these illnesses in a time of coronavirus risk, even if it's about a seasonal flu, you know. We don't want to pass the virus on, you know. It's just personal ethics, you know, that's all. Well, in all this fuss around this new virus being discovered, the upside, you know, the positive consequences that people have started washing their hands, something we've been you know, told by our grandmas, you know, for many, many years. Suddenly people realized that they have to do it. It suddenly became obvious that you have to wash your hands for slightly a different reason, but still, that's a positive result. Yes, we are keeping the social distance, we are following the restrictions, we are looking at the number of people in the zone so that we're not too crowded. I know that there's a lot of talk on internet forums. Okay, it's a great thing you're doing it here, but still we're passing the virus on in big stores, supermarkets. Okay, but that's something we agreed on. If you don't want to partake live, you can watch us online. You know, this was a condition for this event taking place at all this year, so this was a basic condition. It's perfectly protected, everything, the zone, it's safe. If you want to join us, feel free. You can see everything live. The show zone, there's Karol Wójcicki in the show zone, so if you're his fans, you can go and see him. We will join that part of the event with our camera, so you can have high fives, and I'm sure we're safe. If you are in the area, join us at the campus of the Kielce Technical University at the Mars Yard. Right, talking about Mars Yard, yes, let's have a look at the Mars Yard. There it goes. And this is the Mars Yard. It's covered in shade, in the shade, because, you know, it's early morning. Maybe we can have a different view from another camera. Can you talk to us about the Mars yard, what the layers are, how it was built? It was built by a group of geologists, students, and by Anna Waszak, PhD, who also designed the LEO platform. Right, there are many layers. There's lighter, thicker powder. There are different layers of sand, quartz sand. There is a rock bed. There's stones, bigger, smaller stones, pieces of rock. Yes, indeed, it was designed by Anna Waszak, PhD, and her students and geologists who made sure that this was realistic. You know, a special committee of experts worked on this. It was really hard work. It's really handmade, you know. The Mars Society with Robert Mobański, who is responsible for the preparation of this track. Robert and his team have been preparing the Mars yard every single year, and every next year it's even more perfect than the previous one. The Mars yard was built twice actually this year. It stays here after every event. You know, each year we have to get rid of the plants that take the space on the Mars yard after the event, although the basic structure remains there, and then we have to build the superstructure. And this year we had to do it twice because we did it for tests in the first part of the competition, and then we had to do it anew so that the teams do not know the actual end formations, rock formations, and the terrain, so that it's a surprise for them at the competition. Well, we had a situation when the rover was on the rim of the crater and it almost fell over, but the team at the last moment they realized that there was suddenly the team realized that they were seeing the sky, so something was wrong. So they understood that the rover was falling over. Really, they were on the brink. They almost fell over. And that's fascinating in this kind of competition. That is, they don't see what we see sitting comfortably in an armchair in front of the screen. They have a different view from the rover. And today, let's show you. Yesterday we talked about the flying saucer, the Kielce saucer, the flower, well, you know, those simple things. And the teams not only sent us photos, but also we have a whole bag of quotations about how they interpreted what they saw. It's really worth reading, because their initiative, their imagination, that's proof of great imagination of the teams. Right, a lot of tasks for the teams. As far as I understand, most teams have already completed their tasks on the Mars yard and in terms of maintenance. Well, it's still going on because we didn't want to have them too tired so that it doesn't last till late evening. Last year, I remember we continued late in the evening with artificial light. This year it's slightly shorter. And what's the team's reaction to these changes? They're not using their own rovers designed by them, and if I understand correctly, it's not the whole team that takes place in the competition. The programmers and others are not there, no? No, that's not how it works. The whole team is there because, you know, in programming and developing, and you know, a lot depends on mechanics, on the suspension. So the science people are there, you know, to understand the behavior of the rover. You need the whole team. We saw that some of the team members did great scientific work. There are geologists on some teams, and we want to publish some of the data we gathered at ERC. We are planning on a scientific article. Definitely on each team there's a head of team who are in control of the whole situation. Remember that things might happen, like for example somebody might lose internet connection. Everything is possible, so you need to replace one another within the team, so you need B plans, so it's not just the programming person in front of the screen. Even if a team decided they were not going to use the algorithm because they are less, they know ROS, Robot Operating System, they don't know it so well, they use different solutions. Sometimes these are not only the same team compositions as last year, sometimes they're even bigger with additional people joining them this year. It's really interesting, and there's this additional scientific component because this has become one of the main tasks, main competitions at this event, this year's event. Right, great people working at this, and this has been done by great people, passionate people. You asked about the reaction of the teams. There are a few jury members who receive feedback from the teams, and the teams have been thanking us and asking us to keep this kind of format because this format is valuable for them. And remember, this format that we've been following this year means that we went level up. We've become an event like Mr. Walas of Gdańsk Technical University said yesterday. We talked about this and he said, well, what we're doing here is what is done at the most professional and NASA competitions, events. This is the NASA event at ERC this year because remote controlling is what is done at DARPA competitions. So we are at a world level, you know. Wow, congratulations. We have seen and have been following this event development for a number of years in a row, and we all did a lot of work and invested a lot of effort to have ERC organized this year normally. This is what I wanted to ask for. This is the view from the rover. This is the view that the teams get from the rover's front camera. This is a measurement, that is the distance is measured from the rover to the navigation point that was part of the task, and the closer the rover is to that point, the less penalty points the rover gets. It's not penalty points, it's just how it works. And the measurement has been taken, and the rover is going to the next point, so they are now defining the trajectory to the next point. They have markers on the track, different rock formations, and this is what is going on. This is the Turkish team currently on the track. So these are not the team members you can see in the background. No, there are no representatives of the teams here in the field. No, the Turkish team is connected with us. Greetings to Turkey. All the best. The Turkish team is now connecting to Freedom Robotics platform that we saw a few minutes ago. The signal goes to our main server operated by the Poznań Supercomputer Center. From there it goes to Kielce Technical University, and here we have a special team managing that signal. It is sent to the track directly to the control tent, and through our mast it goes to the rover itself. I wonder what the pandemic might give us in terms of positive results. I don't want to talk about the downsides, but talking about the upsides, you know, telecommunication, call-ins, remote conferences. I'm sure that even if we have the vaccine, things in place, solutions, medications, I'm sure some things will stick around because this is just more practical, and that's it. You know, just take how fast the internet here is. Remember the interview we had here yesterday? 6-7 gigabytes of data, almost an hour long. Do you remember how long that it would take to download, a few years ago? I probably would go to sleep in the meantime. I said, okay, dear operator, let's send Łukasz's film, the video, and before I turned around, it was already on the main disk. This is a very fast internet. This technical university has the fastest internet in the region. The infrastructure is really amazing here. And many thanks for the technical university in Kielce for helping us with their internet, for making available the internet connection and connecting with the track. This was a challenge. Talking about the pandemic, if you think we might have steering control manipulation of the rovers from own satellite next year, I don't think so. Let's wait a few more years. In a few minutes we're going to have the feed from the conference hall, but remember that you can join us in the conference hall here live. You can ask questions. There are questions asked by the audience at the conference. You can even talk informally between the events, with the participants. Not everybody is following online. We have people here in the field, in our premises, because some people wanted to be live here. I remember the informal conversations after the events yesterday. They lasted very long after the official part of the event. I remember the discussion that went on about space travel after the official panel. It was a discussion that really went towards transhumanism, so the topic changed a little bit. I think that's Kamil's favorite topic alongside space law, but an interesting discussion, one that we're going back to still today. Fantastic guests, great experts, passionate about the topic. We're going to talk to Pete Warden today. Really, brace yourselves. Please follow the discussion, the interview with Artemis. Artemis is a person who has had with her team the Senate, American Senate, convinced to increase NASA's budget. She is really charismatic. Indeed, she's very charismatic. With Artemis, you can either agree or just agree. That's how I'd put things. Let's have her here and see what she might tell us today. You know that the moon program was called after her name. Many thanks for being with us, Artemis. So many conferences with her participation are conferences where we get so many knowledge, and remember that her network is absolutely amazing. She's exceptional. She's passionately engaged in Mars issues, and it's a great honor to have her here. And she has become an ambassador for ERC really along the years. I met her 2 years ago during the first interview, and since then she's been here. Well, this year it's exceptional, but she's usually with us. But we have another interesting conversation with Pete Warden at 3:30. He's a general of the US Army, former head of DARPA. A 3-star general, it's not like a 3-star hotel. It's a very high rank, because 4 stars are only given to the main staff at wartime, So the operation generals are 3-star generals. And Pete Warden was head of DARPA for many years. That is the Agency of Advanced Technologies for the US Army. Then he moved to NASA Ames. That is a scientific unit of NASA. That's where he got his PhD. Then he moved to the Breakthrough Foundation, which he co-founded. That is, it was co-founded by Steve Hawkins. And what's going on there in this foundation and their vision goes really beyond our imagination. I think, at least mine, definitely. What they're doing is absolutely amazing. It's really worth following that interview. Let's talk about their plans for the future, because breakthrough initiatives, there are a few initiatives under this organization. Breakthrough Prize, for example, headed by Mr. Warden, a prize awarded to the most interesting startups or companies, innovative companies who introduce new solutions, and an expansion of the SETI program, that is a program for looking for signal from intelligent creatures from the space or artifacts that might have been generated as a result of other civilizations' activities. And the third program is a planned journey to the closest extrasolar star. Thank you very much for this conversation. We have to get down to work. We are about to start our panel. Please follow us. Let's now thank our sponsors and all the institutions that made this event even possible at all.
Świętokrzyskie na czuli.
Pathfinder rover, then twin rovers Spirit and Opportunity and Curiosity, and his older brother is heading towards him. It's not a twin brother, but they are very much
Perseverance.
alike.
I o tym
Perseverance,
robocie, a w zasadzie o tych robotach, bo o
about
Perseverance i
these
o
rovers,
Curiosity
about
będzie opowiadał nam
curiosity and
Rafał Grabiński.
perseverance, will be the topic of our next presentation delivered by Rafał. Rafał, nice to see you. I have one joke, which seems funny to me. I have asked you, have you seen Killer, famous Polish film? Not yet. So it will be to you. What Perseverance has in common with Lieutenant Fish, Ryba? And they have a hidden helicopter. Yes, Perseverance has a hidden helicopter in it, like this Polish song goes, coming from this famous film Killer. This joke is as dry as Mars surface. So, what are the differences between Curiosity and Perseverance, and what they have in common? That will be the topic of our conversation. And Rafał Grabiński, the floor is yours. Welcome. As Karol said, I represent Urania, the astronomical publishing house. I specialize in cosmos, in the space. I'm glad to perform after Anna Łosiak because she has presented the geological profile of Mars, and now I will tell how the surface of Mars is being discovered by Curiosity, and it will be discovered soon by Perseverance, the rover, which is very much alike Curiosity, but also some differences that I'm going to describe to you. So a lot's going on Mars. Now we have 6 active orbiters there, 2 missions on its surface, 2 active missions, 1 performed by Curiosity and 1 by InSight lander, geological lander. At present, we have 3 missions launched to Mars. One of the United Arab Emirates, Amal, which means hope. Chinese interplanetary mission. The Chinese were quite successful in launching rockets to shuttles to moon, and it's Yamui 1. Composed of lander and orbiter, and the 3rd mission will take place, the American. This will be the mission of Perseverance rover. Why Mars is so popular among researchers? First and foremost, if you saw the previous presentation, you've heard that in the geological past 4 million years ago, Mars was very much similar to Earth. If we had some observer outside of the solar system who would record the evolution of the 2 planets, they would classify Mars and Earth as similar planets with the same potential for life there. So that's why researchers ask themselves, is it possible that life existed on Mars? Now we can confirm that we had conditions favorable for living organisms on Mars in the past. Now we can ask other questions. Did we have this life in fact on Mars in the past? And Perseverance may help us in answering this question or give some hints. Mars has a great geological past. When carrying out research on Mars, we can get more knowledge about our planet and the rocks here. A short historical background about Mars exploration with unmanned missions. The first probe sent to Mars was Mariner 4 in 1965. that was at the time of the Cold War between Soviet Union and the US. So artificial satellites being sent to the space and manned missions to the moon. When it comes to Venus, they were quite successful, but they were very unsuccessful with Mars. 8 missions to Mars failed. The Americans managed better with Mars because the Russians failed. Not all were successful, but here we can see in the picture we can see one of the first images sent by Mariner 4, which just did a flyby above the surface of the Mars. 1% of the planet mapped by Mariner was so old in geological terms that it showed the image of a planet full of craters and unattractive in geological terms. At that time, dreams about Mars as a perfect place to live and place full of more complex structures were failed, and researchers were disappointed by that. Then we had other flybys by upgraded Mariner 6 and Mariner 7 and the first orbiter Mariner 9. What's interesting, you can see an analog picture created in Jet Propulsion Laboratory, the only unit sending probes to Mars. It is painted by analog researchers who received data from Mariner 4. Computers of the size of a wardrobe processed such image and every signal whole day. So the researchers made that picture on their own manually. And here a comparison of images from Mariner 4 and the satellite picture taken by Ranger satellites. So a lot of useful information for researchers. And here another picture made during a flyby by another Mariner, and here we could see the southern ice peak. When it comes to the Soviet missions, they were not programmable. Probes were sent by, for example, when Weiner 3 got to the orbit of Mars, it had landers, but there was a dust storm on Mars. At the time, nobody knew how long it would take. So Mars 2 and Mars 3 probes made pictures of the planet covered with dust, so no geological formation were visible. At the same time, Mariner 9, which became the first Mars orbiter, could be reprogrammed so it could send information whether the dust storm is over or not. So that was a problem at the time. When it comes to Mars 2 and Mars 3 probes, they sent their landers. A probe of Mars 2 crashed against the surface of Mars, but Mars 3 was the first flying unit which landed. Unfortunately, after 14 seconds, it stopped operating and sent a black picture which didn't give any information. This is a picture taken by Mariner 9 presenting disk volcanoes. This is something that researchers expected to be there. You can see Olympus Mons, the highest mountain in the solar system, 20 kilometers high from its foot. First successful landing, missions Viking 1 and Viking 2, great missions, highly informative. Many pictures were taken at the time. We can find these pictures in encyclopedia up to now. And the first rover, American rover, of the Pathfinder mission, not large, but carried out some important research on 15 rocks, which was a success. Then the 80s came and all missions were parked. The Americans lost a lot of money for Apollo, then to construct space shuttles. That's why Mars was put aside, and in the 90s, faster, better, cheaper strategy was defined. This was a NASA strategy to launch some missions, to dispatch some missions, but for shorter periods. Unfortunately, this strategy didn't pay off because we had 3 spectacular losses of probes. Mars Climate Orbiter, during its flyby near Mars, it was supposed to find its place on its orbit to do some research on climate. Unfortunately, 2 companies preparing subsystems to that one, the units, the difference of units, the metric units and imperial units were different. That's why the probe was burned in the atmosphere of Mars. Then another American probe was sent, Mars Polar Lander. It was a lander that was supposed to land in the southern part of Mars. Unfortunately, it got lost. We know nothing about what happened with that. The engineers thought that it will not communicate with Earth during landing because they were afraid of interference between communication antennas and other instruments. Today they don't do that because of that no traces of it were found, and we have no idea what happened to that lander. It didn't communicate with Earth up to now. Better, faster, cheaper was finished in NASA. JPL engineers were laughing that pick 2, you should add pick 2, better, faster, cheaper, pick 2, because you cannot have all at once. This is the first picture taken by Voyager lander, the first really sharp image from the surface of Mars. And this is a picture taken by Viking 2 before the sunset during the mission. Let's continue. Another Pathfinder picture. We are in the 21st century. Mars Odyssey, American Odyssey, fully functional up to now. It's been there for 20 years up to now. Soon the reaction wheel of this orbiter failed, so soon it will lose its capability to maneuver, but it sends us data from Curiosity lander. The second one was Mars Express, dispatched in 2003. It is carrying out research on the atmosphere of Mars and on its surface. There's a heated debate between researchers whether there is a liquid, fluid, water below the surface, and thanks to Mars Express we know it because it is equipped with a special radar. And Mars Express probe, the landing failed after 20 years after landing. One probe found this lander. The landing was successful, but it didn't deploy its solar panels and blocked its antenna that was supposed to communicate with Earth. So the lander landed successfully, but unfortunately it didn't give any sign of life. Another probe, Mars Reconnaissance Orbiter, an American mission, which gives us the sharpest images of the red planet. It is equipped with the best camera, taking really good pictures, used for scientific missions, but also to plan other missions, to plan where Curiosity should go, and it will be for sure used for Perseverance. Then we had nothing, and in another launch window nothing was dispatched. And then we had a Curiosity mission. I will say a bit more about it, so I will skip it now. The first Indian mission, Mars Orbiter mission, the Indians sent a mission, being the first nation ever which did a interplanetary mission at the first attempt. It was a demonstration of technology. Maybe the scientific result was not so significant. However, the mission was successful. Maven, American probe, to check the interaction between upper layer of atmosphere with solar wind, and to answer the question, Mars don't have its atmosphere anymore. Another European mission that we had to wait for a long, it's ExoMars Trace Gas Orbiter. It's a mission consisting of an orbiter and lander. Orbiter produced by the Italians, the lander by different European consortia, and Cosmos also added something to that. It is still looking for trace gases in the Mars atmosphere. They want to respond to the questions how much of methane is still there, whether it's a local phenomenon or global, and why is it escaping so fast. The lander that was supposed to land on the surface of Mars and demonstrate something before the next mission crashed, and this is also a very sad story because it crashed because during this landing the lander deployed the parachute to brake, but by 1 second one reaction wheel, one gyroscope should maximum rotation, and this software of lander interpreted that it is on a negative altitude, and unfortunately there was no protection to prevent such a situation, and the probe thought that the lander is already on the surface, and they switched on thrusters. They were supposed to work for 30 seconds, not 3 seconds, and the lander crashed from the altitude of 4 kilometers, and it's the only thing that rested. It was a small crater. InSight mission with a Polish accent, the first interplanetary mission aiming at the research of the inside of the planet. 3 scientific instruments. The first is a seismometer, the first one sent to the surface of Mars, which registered several hundreds of signals, and geological penetrator, heat probe instrument supposed to check how heat is conducted in the underground layers of surface, and Astronica, a Polish company, realized and constructed the penetrator which was supposed to enable that. However, this lander landed in a very unsuccessful place, in a troublesome place where the surface didn't meet the specification requirements. That is why this piece of instrument couldn't be applied there, but we don't give up, and hopefully we will succeed, and we will have another 3 missions. So what do we know about Mars? I will not talk much about it because the previous presentation was devoted to the geology of Mars. We know that this is the 4th planet from Mars. This is the encyclopedic knowledge. This is smaller from Earth, made of CO2, mostly atmosphere, rather thin, temperatures from minus 133 degrees centigrade to plus 27 degrees centigrade, and great dust storms. And about curiosities, we know that for 4 billion of years it has no global magnetosphere. We know that it had used to have liquid fluid water, We know that billions of years ago there was a chemical environment with the access to warm water and good temperature favoring life. We don't know what changed Mars in a dry desert as it is today. Now let's move over to Mars Science Laboratory, which is Mars Curiosity. It was the first name was Mobile Science Laboratory, so the idea was made up after the failures in the 90s. NASA decided to set the major goal and base the whole Mars exploration on its major goal, so looking for traces of life or conditions favoring life on Mars. They decided to dispatch 4 missions, 2 missions of orbiters which would act as scouts and support land missions, and 2 rover missions. The first one was Mars Exploration Laboratory, which were 2 twin rovers supposed to deliver some scientific data, and if the conditions are favorable, they planned to send Mobile Science Laboratory in 2007, the first mobile interplanetary laboratory which would be capable of collecting and sending samples to Earth. Of course, we haven't done it yet, but the idea was to have a laboratory on Mars and carry out all kinds of laboratory research in situ. What were the expectations, the requirements of Mars Science Laboratory? So the conditions, the requirements for engineers were quite high. The rover was supposed to land in a very precise spot. Rover, so these requirements were very strict, so the ellipses would be 3 to 5 kilometers, so precisely on in a given spot, and to be able to drive to any place required, as it was supposed to have lab on deck. It would be very heavy, and that caused additional challenge for engineers. It was supposed to stay there for 2 Earth years, so 2 Mars years. What is the difficulty in development of such systems? First and foremost, we don't know how to land something large on Mars. Curiosity is the largest thing that landed softly on the surface of Mars. It is 900 kilometers. It required years of hard work to work out a system enabling something like that. Mars is a very tricky planet when it comes to landing, because if we send any probes and they go back, they re-enter, the atmosphere is very thick, so the majority of velocity is transformed into thermal energy, so the only thing you have to do is to give it a capsule that will burn during the re-entry, and then use parachutes. The moon seems simple as well. There is no atmosphere, so the only thing you have to use, these are rocket engines. And Mars is something between the moon and Earth, so it has some atmosphere that you cannot ignore, because otherwise the probe would burn. But parachutes are not enough. That is why we have to combine the parachutes and rocket techniques. Parachutes have to deal with very high velocities. These have to be hypersonic parachutes, sounding rockets, simulating opening of such parachutes on Earth. These rockets send it to the altitude of 60-70 kilometers, and when the speed is correct, this is a simulation of the Mars pressure. The parachutes gets open, and the researchers verify whether everything is symmetrical, whether everything is fine. So that was something that killed the European mission that was supposed to be dispatched together with Perseverance this year, because parachutes were the main project. The problem, the competence the exclusive competence to construct parachutes was with JPL in the US. So that's why Mars is so tricky to land on. You will see an animation presenting how Curiosity, a probe, landed on the surface of Mars. So there was a conception of Mars Smart Lander, so how to land softly with the use of these techniques. Very soon it was concluded that in order to land such a mission, they would have to use radio isotopic generator and thermal generators. Such generators used to be sent with American missions, but it required reprogramming because the current conditions don't require big powers, and the generator has to be lighter. So the Department of Energy of the US was expected to design the new generation of radioisotopic RRNTG generators, which would support Mars atmosphere. They would generate less power, but would be lighter, would weigh less, and could be applied in a rover. The advantage of such thermoelectronic radioisotopic generator is that we don't depend on the sun, so the energy is supplied all day long, and we have a constant stable source of energy, not like with Opportunity, when during the dust storm the rover lost electricity because of the only source of energy were the solar panels. And what is the artistic vision of this mission? In 2003, this was the design, the artistic vision of the rover, 2006 as well, and 2011. So the actual rover that was launched. You can even see the difference in rendering, in computer rendering, and that answers the questions why we send outdated technology on with rovers, because you can see that even the computing power needed for rendering changes so fast, and it is not possible to change them in the meantime. So these are the most expensive interplanetary missions, costing billions of dollars, and unfortunately there is one disadvantage of them, that they have to use technologies developed from the previous decade. And now let's continue with Start Atlas V. Curiosity was launched with this rocket on the
for 900 kilograms. And the most typical features are 6 wheels, aluminum box that constitutes the core, the body of the rover, including the laboratory inside and the power system inside as well. On the upper body there is a mast carrying the cameras and one scientific instrument, and also on the body is a robotic arm with scientific instruments on its extremity. There's not much free room, as you can see inside. Now let's move to the instruments that the rover is equipped with. The first one allows for powering MMRTG, that is the electrical generator, that is an isotope that when it is fissured, it emits energy, which is thermoelectrically used with two types of connections. One of these is on the inside, the other on the outside, and there's a difference of temperatures generating electrical power. It's not very efficient because the heat energy that it generates around 2000 watts of heat energy, out of which the thermal generator generates around 100 watts of electrical energy. Part of the heat is used for heating up the systems of the rover, but as you can see, the efficiency is not very high. Between 45 and 80 watts are used in the waking system, and if it moves around, it uses up to 500 watts. So it's easy to conclude that the rover requires a battery. So a good Martian rover only spends around 6 hours waking, because the rest of the time it's resting and charging the battery. And the scientific goals, the scientific activity of the rover unfortunately is limited by how much energy the rover has and can generate, because also the tests, unfortunately, it uses energy. They use energy. It has 6 wheels, 10 motors, separate one for every wheel, plus the front and back wheels are controllable, so it can turn around. It can go through obstacles that are 1.5 as high, as tall as the wheels of the rover, so it's quite efficient. The maximum speed is around 4 centimeters per second. The wheels are built from aluminum, and each was built from a separate piece of aluminum. Also, it contains titanium spokes. They are important because there are 2 systems in the driving system. On the one hand, it has to allow for stability and security of movement, but at the same time, the rover uses them as a landing system. That's why we need the spokes. They absorb part of the impact against a hard surface of Mars. Of course, it's relatively hard landing, but it never is zero speed. PowerPC is the architecture of the system, the computer board computer. If you compare it to our computer systems, it does not have a great specification, because it's around 200 megahertz system, 256 mega of RAM. So hard to play a game, computer game, using this, but there's one feature that makes it 100 times more expensive. That is, it's space radiation resistant, which means that the radiation will not impact the readouts from the research systems. Curiosity carries 2 board computers. We almost lost the mission in 2013 because on one day some problems started on the computer A. It went into suspension, and engineers were terrified because the process that was responsible for noticing that kind of suspension also got suspended. So that was really scary and caused some panic. We got some additional time on DNS telescopes that are used for communication with interplanetary probes. They are always used for NASA missions, and they were all used for communication with the rover at that time. A simulation on the Earth was done with the same kind of electronic equipment, and it was found out that what would happen after waking of the rover, there would be automatic suspension of the mast if the situation continued. So in the last hours, the power was switched to computer B. and it so continues until this day. Apparently, there was a failure of the microchip in computer A, and now computer A is works as an additional supporting computer. It has never since been used as the main computer. For communication, there are three antennas. One UHF that is used for communication by orbiters. They play an important role because 2 megabits per second is the communication volume of communication with the rover, making readouts. Also, there's a hexagon-based communication system with an X stream. Every morning, the rover receives commands for every new master sequence. That is what the rover has to do in a particular day on the surface of Mars. There is a number of things that have to be made sure about. That is, for example, the mast cannot cover the antenna, so that so that communication is uninterrupted. 15 bits per second is the third antenna. It's used for the safe mode and the emergency mode. If the rover does not know its location, it's used for emergency commands. This is the electrical arm with the drilling system. This is the most complex piece of equipment sent to the Mars. There's a drill, pneumatic drill. The 1.6 centimeters diameter is the width of the drill. There's a GIMRA, a mechanism for separating the probes used later on in the rover's lab. There's also a special Machli camera for zooming in on pieces of rock and stones and other pieces of equipment, and also for engineering issues, selfie photos of the rover. An X-ray spectrometer that requires a close zoom to a rock, so it was also placed on the electric arm on its extremity. Now let's move to scientific equipment. One of these is mast cam, that is a couple of cameras on the mast. They are different. Each of these is different. That is, they were planned on to have a zoom, and this is one of the first differences. That is, Perseverance has active zoom, but well, there were financial cuts, budget cuts, so we have two cameras with a different solution instead of that powerful zoom. Other pieces of equipment, one more interesting thing, that is, these cameras are equipped with Bayer filters, exactly the same as in digital cameras. So it makes the picture very similar to the human eye. It simulates human eye kind of vision. This was the Medley instrument on the capsule that provided information about pressure, and other sensors that provided data for future missions to the engineers. Another camera on the rover is Marley camera that was used during the landing to provide the best possible photos of the surface, and in order to have context about what's underneath the rover when it's moving around. Another Machli camera, it's a zoom-in camera with a magnifying glass for rocks to inspect them before or after drilling, to document the pieces and samples, and to take selfie photos like you can see on the screen. If you see a Curiosity selfie photo, that's the camera that takes them. Another piece of equipment is radiation assessment detector. It inspects the impact of radiation. It was sponsored by Exploration Missions Directorate of the NASA, and it's used for planning future manned missions to the Mars. And this is a capsule that recognizes about the minerals, but we can learn about the chemical composition and draw conclusions about the minerals. There are two instruments inside. The first of these is the mineralogic instruments. It inspects the minerals. That is, the sample is introduced inside, and based on that, we can learn about what minerals are contained in those samples. The most complex piece of equipment is the SAM instrument. This is a great technological achievement because in 20 years it has been miniaturized in terms of the gas chromatographer. And normally in labs they are the size of a fridge, and it's been miniaturized for the needs of this probe. You introduce the sample, you heat it up to around 1000 degrees Celsius, a gas is produced, and you draw conclusions about the minerals. These are the scientific instruments of the Curiosity probe. Since time is running out, let's go through the photos very quickly in terms of the images that saw. This is the way traveled along the years between 2012 until today practically. You saw the destroyed, worn down wheels of the probe. These are the dunes, very interesting places traveled by the Rover. It traveled a dozen kilometers, around 20 at this point in time, I think. And what are the features of Perseverance? Now let me tell you, to wrap up, it's very similar to Curiosity in many terms. It has the same drive, the same computers, many similar cameras, but one of the differences is this. These are the scientific instruments. For example, it includes an oxygen generating system based on CO2. This is another step in preparation to sending humans to Mars. We are trying to check whether we can generate oxygen from CO2 for the benefit of a future man-based crew of a spaceship, and in order to create a propellant fuel. If you were to use liquid hydrogen or liquid oxygen, that's the first step. Another instrument is a helicopter that will not provide scientific data as such, but it will be a test whether this kind of means of transportation is efficient in the conditions on Mars. Instead of a laboratory on board, there is a special system for garnering samples. They will be prepared for a different rover, for a different probe to gather them, that comes with Europa under a different mission, and then these samples will be brought back to Earth and they will be looked into in a detailed manner in a proper Earth-based laboratory. We hope they can get back to Earth. We didn't have the time to talk about the landing spot for Perseverance, but if you're interested, please visit our portal where you'll get information about Perseverance and many more Martian missions. Many thanks for your attention as of now. This is the troublesome moment when the host does not know whether he's online or not, but I can hear some voices in my ear telling me that we're live. Thank you very much for this presentation. It's a pity tell you about walking robots and their application in underground inspections. I'm going to talk to you about the goals and scope of inspections, factors to be checked in underground inspections, their scope, what we're interested in this kind of processes. Then let me move to problems that might occur when we go underground, what we might meet, what the obstacles might be. And the next topic, technologies for inspection robots. I'll tell you what kind of robots are currently used, what the down and upsides are, and their limitations. Then let me tell you about walking robots, solutions applied, and where they are used, and what the future holds for the industry. Now, in terms of the goals and scope of inspections, every underground network is a technical system that requires inspection from time to time, because there might be some failures, and in order to avoid such failures, you need to carry out regular controls on such networks. Since these networks are located underground, mobile robot solutions need to be used. Since these places cannot be inspected by humans due to thermal conditions, narrow tunnels, there are a lot of restrictions and limitations. In terms of inspections, in terms of such processes. Later on, let me move to potential problems that might occur when we enter an underground tunnel. What the obstacles might be. Another topic being the types of technologies for inspection robots. What solutions are being used currently, what their up and downsides might be, as well as their limitations. Then let me move to walking robots for inspections, what solutions are available, where they are applied, and what the future holds for the industry. Let's start with the scope and goals of inspections. Every underground network is a technical system that is being operated, which means that there is some wear down and possible failures. In order to avoid such failures, regular checks are necessary on every such network. Due to the fact that these networks are located underground, solutions in the form of mobile robots have to be used. That's because humans cannot be introduced into such networks due to thermal conditions, narrow tunnels, and many other limitations. Under such inspections, we carry out visual checks of the tunnels, of their condition, and we're interested in such aspects as cracks in the ceilings of the tunnels, the condition of the insulation, possible corrosion, leakages, anything that might be wrong with the underground pipe. It is very important because ongoing maintenance allows for the avoidance of possible failures. The problem with failures is that they're usually unexpected, and they might impact the situation in a big part of the city. For example, cutting off heating in the midst of the winter, and cutting off access to hot water, which is never a good thing. Within such an inspection, all such aspects can be looked into. anything that might require maintenance, and this allows for timely reactions, either through groundwork, using heavy equipment, accessing a particular section that is in a bad technical condition, and necessary repairs. Also, repairs from the inside are possible in the case of small problems that can be mended with simple means. Sometimes you need to cut out a piece of tree root, for example. Let me give you a couple of photos. This is an example of inspection equipment for water and sewage systems. You can see an armored car equipped with a mechanical arm and a robot. Like you can see on the photo, the robot is introduced with a wire and the extremity of a wire into the network system, and the operator sees everything the robot sees through the lens of a camera. After the introduction, as you can see, the robot is already inside and ready for the exercise. On the right hand side you can see the robot after the carry out of the checks. It has to be rinsed, cleaned. The construction is waterproof, so you do this with a pressure water arm cleaner. Now, possible issues during an underground inspection. We might expect all kinds of obstacles, curves, and others, meaning that some places cannot be reached with the robots using wheels or caterpillars. We just saw a robot that weighs several dozen kilograms, and if there's an obstacle, such a robot cannot go in. Such a robot is connected to a long and heavy wire, which means that sometimes you can just go one curve and you'll be blocked at the other turn after it, which means that the distance that such a robot can travel is very much limited. On top of that, a lot depends on the operator. Whether the operator is quite sure that the robot can travel the way back or not. In some situations, there might be a situation when the robot is blocked and at a section of the network, and that requires groundwork to get the robot out. This means that not every operator will have the same manner of inspecting the network depending on what their assessment of the situation is. This is a heating network, a section on the photo. Two pipes of a large diameter with a tunnel between them. This is a difficult point for a regular robot because this is a very big obstacle. Also, the temperature inside is high, and there is high risk that the robot might be blocked. And now a short break in this robot video, but let's stick to the topic. Maurycy Menke of Mapworks is with me, and they have their stand at the show zone at ERC. What do you do?
I will start from Mapworks company. This is a producer of two flagship engineering products, MATLAB and Simulink, and these two programs, I don't want to lie, but you have to do anything. Oh, we like such programs. The day before yesterday, in an interview, I was asked why we support ERC, and I gave one example. One day, with the same software, we operate our Mars probe, and the same program tells us what will be the weather on Earth. So sociologists also like it. This is an invigilator. We have a large population of many people, and it finds out correlations between. And now we know that, for example, people wearing red socks tend to snore, and so you can do such things with this piece of equipment. And what have you prepared here? Because we will visit your stand in the show zone to see what you prepared. So please tell me what they are doing, and we will see what they have there. Okay, so I will describe my field of expertise as this tool is so comprehensive. There is a high stance that a regular user doesn't know that some new functionalities were added, or something is possible, or there was some bug that made them mad, and we got rid of that. And I'm a kind of educator and helping hand and intelligent Google for universities, for students and people planning to go on a university. So living Google, it's me, so I support them. First and foremost, I inform that this tool exists at all, and then I explain how to use it efficiently. I'm concentrated on the educational part. We have also a separate commercial part. And when it comes to my achievements, I think that all technical universities have our campus version of our software and access to all possible tools. And sometimes, as they don't know what does it mean everything, I explain that. Yes, so they call me and tell, I would like to do this and that, and I say, okay, that's possible, just push here and here. So they offer us a huge base of ready-made project. We can download them, Control-C and Control-V them, and totally copy them one-to-one. That is how we created the large package for our competitors was Creator. They thought, okay, but in order to complete this task, we'll need this and that. We have the complete instruction with all tutorials. The only condition is that they have to inform that they used MathWorks, and we win ERC. That sounds good. Could you give some example, because this is so vast? But what, in your opinion, is so spectacular about this software? We have our Leo Rover robots. Let's assume, in the most simplified words, because I explained from simple to complex. Now we have many users who just start their adventure with MATLAB. So let's start with a simple example. We have our Leo Rover, and it is made of, let's say, 5 systems: Q, suspension, battery, antenna, and all of them have to be fully functional, and they are controlled with some kind of software. If everything is done in the same project, in the same program, we have a guarantee that it will work. So we go from top to down. We haven't we are constructing our probe, and we start from general systems and go to given subsystems. We simulate it and simulate the functioning of it on all stages, and if it proves efficient, that would save us a lot of money during construction. For example, we can concentrate on the driving capacities. We have 2 engines on the caterpillars and a control plate. Can we show the stand? we're trying to connect with your stand because it would be easier to understand everything if you could see it. Where is my colleague who should operate it? Just in short, I have constructed the interface, so from the level of your laptop you can control it, but ultimately I would like to offer a robot which will have a camera and will be controlled by your mobile. And what is the difference in terms of the workload, whether we do it as a mobile app or as a computer software? Or is it just a question of several switches? It's another curiosity of this trade because that works as Lego bricks. So I combine different elements and then I control all these elements. Laptop is quite big and not very handy. That's why our program gives opportunity to develop software as an online application, as a mobile application. And sometimes I inform about it our students and they say, oh my god, is it really true? That's great, it's possible. So now they are thinking of controlling with a mobile. I've got an information that our camera has some problems with the transmission, with the broadcast, so maybe we will go back to that and we will visit your stand once again, but just tell us, what do you have there? Okay, so to me, I started from the assumption that the driver is the brain of it, and it gives instruction to right and left caterpillars. It may go forward, backward, it may take turns. We have to think whether caterpillars will be better than wheels or not, what should be the power of engine. I simulate more powerful engine, less powerful, high mass, low mass, caterpillars, wheels, and I jump up to conclusions, which is it has to be light and the engine has to be powerful. We also have an interesting module. We added it this year. It is a runner and it serves for autonomous vehicles. So we can simulate a traffic jam and find out how the vehicle will react to that. That would be difficult without this tool. So we add a hole in the path or a hen, and this piece of software knows perfectly what is the weight of the hen and what is the size of it. Of course, you can add any animal, you can create your own car, any vehicle, and it helps to save a lot of time because you don't make up something which already has been taken. It's just adding Lego bricks. You add a brick and check whether it works or not. If not, you replace it and you have a lot of freedom and high chances that the final project will be successful. Robotics at some level seems to be more and more simple. Maybe don't you think that it will become available to men from the street, that anyone will have this capacity of creating their own robots made of bricks and elements? So what will be your future job, a job of the people who are there to construct it, if we have such digital combines, digital tools which are supposed to replace you? No, but it's because somebody has to construct and design all these tools. Somebody has to help this technology. The intelligence of machines is quite primitive. They have a large computing power, but they have no consciousness, they have no intuition. Somebody, for example, painted a white circle around the vehicle, and its sensors weren't able to react to that, and it got stuck. So we need this human touch. Machines don't know everything, cannot everything. Of course, they limit time of computing, of calculations, but okay. But let's. I will ask another questions. Yesterday, I was talking to Kamil Muzyka about sending people, manned and unmanned missions to the space. And what do you think? Should we send astronauts? Should we send robots, or both? Maybe I will refer to Stanisław Lem's, because I loved his books when I was a kid. There was one story, Terminus story. There was a whole crew made of robots, but there was one Terminus which survived the catastrophe of this, the disaster of this spacecraft, and he remembered that crash, and that disturbed his functioning. And Cosmic Odyssey, what did Hulk? They killed the crew because somebody gave the instruction which seemed logical, but the computer interpreted it in a wrong manner. But at the end, there is always a human being behind all these robots. Thank you very much that you joined us to talk about your job. Now let's go back to Mars Yard and let's see what's going on there. And at 12 o'clock, our special interview with Artemis about future missions to Mars and reasons behind it. And now back to the Mars Yard.
Is the audio okay? Hello? Hello? Can you hear me?
We can see the maintenance task to be completed, and once again the Leo rover in a few minutes only we will connect with Artemis Westenberg and we'll talk about future Mars missions and why we should go there at all. So please stay with us and once again have a look at the Leo platform. I will tell you in a minute which team is there. Argo Team Poland. I think they have just completed their task because the rover is standing there. But by 4 p.m. we will learn. At 4 p.m. we will learn who is the winner of ERC 2020. So stay with us.
And now we will talk with Artemis Westenberg, CEO of Explore Mars Europe. Artemis, how far are you now? It's outstanding score. A lot of miles you traveled. Do you hear us, Artemis?
Hello.
Hello. Look at your score. It's outstanding.
Hello.
Yes. 614 miles or kilometers. It's a lot. You participated in a lot of missions. Your name is here, and it's a frequent flyer club. Do you hear me, Artemis?
Hello.
Hello. Do you hear me, Artemis, right now?
Yes, I do.
Yes, a lot of miles or kilometers. You should tell us more. You have traveled. It's 614 million miles, 15 even, and a lot of missions. Yeah, frequent
Yes.
flyer club.
Yeah, the thing is, though, that like a lot of these frequent flyer programs with local, with national, like the Royal Dutch Airlines and other flight companies, apparently they expire if you don't fly enough within 24 months. Because I've not been a Martian since 2014. You all understand that I have been flying when NASA would give me that opportunity to send my name to Mars from the very first time. And I think I do believe that I also flew on the Spirit and Opportunity rovers in 2004. I'm not sure you could fly on the Mars Odyssey in 2001, but if it could have been done, I would have done it. So, and all the intermitting missions, of course, I flew as well. But like I said, like with normal airplane companies, they take your flight miles, your frequent flyer miles. Too bad. Anyway, I recommend anyone, children and adults, for the next mission, and there will be a next mission, believe me. If you can fly your name there, why not do it? It's fun. It gives this idea that you're really part of it. You'll get a sheet, which you can then, save on your computer. I have a large bunch of them, and I know a lot of people who have the same. And it will tell us that it's more like we will truly be part of this whole endeavor, which we should be. Because, it's not America that goes to Mars. It's not, Europe that goes to Mars. It's not the Russians that go to Mars. It's all of us. Nearly 8 billion people are making the effort to go to Mars. And we should be proud of that and be part of that, because spaceflight is always about the best we can do. A lot of technology we use on Earth is a spin-off of what we've been trying to do in space, not just to Mars, but in general, also at the International Space Station and any other mission, the mission to a comet, the Rosetta mission to Pluto. It doesn't matter. All these missions, they teach us things about high technology. And being part of that as a country is a good idea, and not just for Poland, not just for the Netherlands where I live, but for all of us. And what you see is that countries more and more have that feeling. The United Arab Emirates this year sent a mission to Mars. They called it Hope Al-Amal. There will be in 4 years' time, there will be a second Indian mission. India sent its Mars orbiter about 2014, and in 2024, so 10 years later, they will send their second mission. It is part of who we are as technological countries. And, and also what I see is that there's a lot of cooperation, which of course is good. It's really good for not just for space, but in general. Let our countries work together instead of, being enemies or, being angry at each other. Cooperate and make a better society for us all, because high technology can do that. It can help us solve problems like not enough clean water or recycling or all these other, problems we have here on Earth. They can be helped by doing things on Mars.
I could not agree more, Artemis. And let's talk a little bit about future Mars missions, robotic ones and human ones. And I know you are very, very, very pro human flight to Mars and our settling down there on this red, beautiful planet.
Well, the thing is, it's not that I am in pro of it. Every robotic mission that flies at the moment is actually researching parameters like atmosphere or temperature, or is there, what are the exact chemical proposition of everything in preparation for humans to Mars. It's not that I am wanting to do this. It's actually what the assignment is, official assignment by the Senate and by Congress to NASA. It's one of the reasons why they get a lot more money every year to make it happen. And also, going back to the moon is about testing stuff to go to Mars. Not in the sense that we go to the moon and we don't want to do anything worthwhile there, because yes, we do want to do things there as well, research and other things, but we will all use this to the moment is used to test.
We have some slight connection problems. Could you repeat the last sentence, please?
Well, if the International Space Station is used to test and train humans for long duration flight to Mars. The International Space Station was supposed to be closed, no longer used. Latest 2024. It will now be extended at least to 2028, because it is a platform that we have built, a lot of countries together, a very good example of cooperation in space, and to test and train for Mars. So why would we throw it away? That seems like, waste. And also the gateway, we can test and train at the gateway, but of course the gateway is nowhere near, and it's nowhere near going to be as big as the International Space Station. Also at the moment it is unclear whether it will be manned for every day of the year. At the moment, the whole idea was that it would only be manned for 45 days per year instead of, all year long. And that's not the best we can do. So that's why the International Space Station is a very important asset. Not just, flying around our heads, 400 kilometers above our heads, 90 minutes, a circle around Earth every 90 minutes, but also to see into the future.
Okay, we have a photo, so we can just show it right now. Our next steps we should take to get to Mars and to get people on Mars. And we have this female astronaut in the lower right corner. And why we even should go to Mars? There are questions, people are asking questions, why to bother? We have a lot of problems here on Earth and we should try and solve them first, and later on we can think about going to Mars. And I do not agree, personally. I think we should go. And please tell us, why do you think we should go there and we must go there?
What many people don't know, but I'm a historian. So if we're talking about first solve every problem of on Earth and then do exploration, because that's basically what you're saying in that case, it means that you're actually saying Columbus should never have, traveled, nor Vasco da Gama or all the others. And, there are other reasons why the tour of Columbus to America wasn't really very good, especially not for the indigenous American people. But as such, exploration is what we do, and having to wait until every problem is solved would mean that we would stay in Poland, we would stay in the Netherlands, probably, venture really far out of village, because, first solve all the problems in the village or the town that you live. And this is, of course, not the way to tackle our life on Earth. Also, every time we do space, we learn things that we actually use here on Earth. Medical things. I mean, if you need a new valve for your heart, we actually use the valve from the space shuttle to help you stay alive. So without the space shuttle, this technology wouldn't be there, because the thing is, it never is that you put, smart people, male and females, in a room and then you say, start inventing now, please. It's, it's you give them hard problems, and space exploration, whether it's by a robot, whether it's a lander, a rover, a satellite, whether it's around Earth, like I said, whether it goes to Pluto or to Mars or to Mercury, it's all very difficult. So what it means is that we have to get really smart to solve it, and to do it well. And also, please, all of us realize that our little phones, which are actually computers that I can easily handheld, wouldn't be done this small if we hadn't used computers for the Apollo missions. And then they were as big as a room. And from there on, we had to bring them on partly. They were, primitive computers. Let's be clear about that. On the Apollo missions, but they had to be smaller because obviously as big as a room couldn't fly. And so because of this thing that was needed to do space, we then started to, shrink the computers to a size that first they were possible for you and me in our house. This was in the 80s, in the 90s. And then, in the internet came, and all these things had to do with science, with cooperation, with working together, and not with practical solutions. There was no one who sat down and said, let's invent the internet just for fun, and now I can talk to my aunt in Australia. I can, and it's wonderful, also to my uncle in New Zealand and to relatives in Canada, but that's not the reason why it was invented. It wasn't, it's invented because science needed a way to cooperate and communicate more easily. And this was more easily than sending letters, or even, taking a phone call, because if you have a phone call, you're not really sending all the data, the science data that you want your colleague somewhere far away on the planet Earth to have. And so space bringing us a lot of stuff, and people don't realize it, but it makes our life easier and healthier also.
I like to put it that way, that we can't say that first we have to solve all the problems here, because science doesn't work like that. It's like putting some jigsaw puzzle together. You have to start here, a little bit here, a little bit here, and eventually you get it all done. If you start from the lower bottom, and the right lower part, and try to put it together like that, it won't work. It doesn't work like that.
No, true.
Okay, so let's move to Mars, because we already stated that we need to go to Mars, and we will go to Mars someday, let's hope. What are the milestones that we have to reach first if we want to talk about human space travel to this red planet?
Well, truth be told, and I recommend everyone downloads it from the internet, the Humans to Mars report of 2020, which is published by Explore Mars Incorporated. It is giving you an insight of what's already happening. And even when I read it, I'm working on this, but even when I read the technical things about how far we are in thinking of how we're going to land, how we're going to go into space, Earth rendezvous, Mars rendezvous near the moon, how are we going to do this? We're actually this far ahead already that I always say 2033, is going to be probably the first year that we will land on Mars, and it's still looking good, because the contracts that have been granted by NASA to various companies, Aerojet Rocketdyne, separate from Lockheed Martin, separate from Boeing, separate from SpaceX, these four companies are figuring it out, and they have their own solutions, and they will be, accrued, and then the best solutions will be picked, and that will be the way we do it. But that's how we are doing the Artemis missions to the moon, and the Artemis mission, which will bring us to Mars. So it's not a far away thing. It's no longer, 2 decades from now. it's just over a decade from now. And actually, somewhere in October 2033, and this has to do with orbital mechanics that I'm naming October 2033. It's the moment that probably humans will step on Mars.
All right. So, what missions do you think are the most important for us, considering this human flight in the future? The missions that are ongoing, the missions that will go there. I mean, robotics, of course, for now.
Well, one of the important missions, and Europe really is working on that now together with NASA. It's no longer a long-term dream. It's reality now. Is the Mars Sample Return mission. And the Mars Sample Return mission is something that needs to fly not just to pick up the samples that the Perseverance rover will find on Mars and then will leave to be picked up by this Mars Sample Return mission, but also because we want to demonstrate we can go to Mars and we can bring something back from Mars. And even if at first that is only a robot that we bring back, it is something we need to test to be absolutely sure that if we send astronauts there, we will bring them back, just like we brought, Neil Armstrong and Buzz Aldrin back that first time we went to the moon. So that's an important one. But actually every mission, whether they're from JAXA or from the United Arab Emirates, every one of them is gathering data that are important to humans, because a robot doesn't care what the temperature is on Mars. A robot doesn't really care what the chemical composition is of the atmosphere. This is all for humans. Is the soil toxic to robots? Well, they don't care. They will not die. A robot won't die because it's toxic and it's driving over the toxic soil, but a human might. And so all these missions, and regardless which one it is, whether it's India, whether it's America, whether it's Europe, they all come together to find us more data so that we can go to Mars. Now, the Artemis missions to the moon are about finding out, is our new launch system with the new rockets, do they work? Will it be the Dragon capsule, the big one then, to Mars? Will it be the SLS? Will it be both? We don't know yet for sure. Having two options is, of course, always a good idea. Redundancy is always a good idea if you do something that's this hard. And also, going to the moon, we try to test in situ resource utilization. A difficult word to just say, if there's water there, water ice, we would like to use it as water or as a source of oxygen. And that's the same with the Perseverance rover, who is going to try to harvest oxygen from the Martian atmosphere. The instrument is called MOXIE, which I think is a very funny word because you have MOXIE, then you know your stuff and you get things done. It's of course an acronym for the oxygen in situ resource utilization experiment on Mars. Obviously, the M in MOXIE is Mars. But it's these things are in the works. As we all know, Perseverance is already en route. Although, please all remember that Perseverance, like its sister Curiosity, 8 years ago, will have to go through these 7 minutes of terror. This whole idea of this big rover, which is actually even heavier than the last one. The last one was 890 kilograms. This one is 1,026 kilograms because, instruments are heavier. There are some other stuff that is bigger and heavier. And it's like a very big car. It's bigger than my MPV car because my car is only, I think, 180 centimeters high, something like that, perhaps even lower, but it's certainly not 2.2 meters high. It's not 2.7 meters wide. I wouldn't be able to park anywhere if it were. And it's 3 meters long, the rover. So it's a really, really big machine that we're sending there. And it has to land with this sky crane And what very few of us realize, because NASA is talking about the 7 minutes of terror, well, the last 58 seconds are crucial. The last 58 seconds, the parachute, the shell, the heat shield, everything will have disappeared. The parachutes are, taken away, and then the retro rockets have to kick in at exactly the right moment to keep this machine floating right, and it has been using its retro rockets before that to keep it going straight down. Then, like I said, no more parachute. Now it has to land. And what it does, this sky crane, in this 58 seconds, it has to lower on these cables. And the moment these wheels touch the soil, then the computer has to say, okay, it's there. Now I pyrotechnically cut the lines so that they don't get, mushed around the wheels, and there's a problem there. It all needs to come together at the exact second for it to work. So for me, it's actually the last minute of terror. The rest, getting into the atmosphere and doing that, we've been doing that quite a while now, and we apparently have, kind of figured that out. But the very last bit, that will be really, really terrifying as far as I'm concerned.
I just felt like I was there. Great speech. And speaking of these challenges, this is a challenge for this rover, but what will be the greatest challenges for people when we already go there and will try to settle down?
Well, for me personally, if I would land on Mars, I wouldn't be able to open the hatch, even, cycling through the airlock for I don't know how many minutes, like an hour perhaps, and then going into the outside and on Mars again. You have to do a lot of checks before you're allowed to do that. That would be, if you traveled for 6-7 months to Mars, you landed safely, no crash, you're there, and now you still have to wait before you can go outside. That would be aggravating for me. But for the rest, of course, Mars is a very dangerous place to be. If your spacesuit breaks, and that's no different than doing a spacewalk at the International Space Station. But if something breaks down, you'll probably die. So you have to be really careful, and you have to be cognizant of the dangers all the time. And what I also believe is that they will have a program of doing research on Mars that's so completely crowded with tasks, probably akin to what's happening at the International Space Station, where the astronauts are working long hours. Because we on Earth, we see these pictures of this astronaut, lounging around in the cupola, looking at Earth, and you get this feeling like it's a super luxe holiday with a lot of free time. That's actually not true. I mean, when you see these pictures, often those are hours that the astronaut is supposed to sleep, because they have free time, but it's not that much, because there's always too much experiments, too much research to be done. And I think the same thing will happen on Mars, and that coupled with the fact that it will be much, the International Space Station is a pretty big house, so to speak. But on Mars, it will not be as big to start with. So I think that will be a problem if you live there. And like I said, the program will be probably very, very harsh for your idea of free time. And of course, going to Mars, I mean, there is a difference in gravity. It's 38% of what's here on Earth, which is, as far as doctors can think, can surmise, because we haven't been there yet, so we don't know, and we've only been on the moon for 12 days, so that's not really a lot of data either. We think it will be easier for our heart to pump around, but still, if you're outside, your suit will be really heavy, so it's it would be so heavy that it would be difficult to walk around with here on Earth, but because the gravity is less there, it would be easier. It's all these, it will be a very difficult life. It will not be going into America in the 1600s, and the surroundings are dangerous because there are dangerous animals there, and there are not a lot of people there to help you. That will also be not the animals, but being a fact that you're only a small group of you there, that might be a problem. The other problem is, of course, if you have a problem on Mars and you ask for help at NASA, Johnson Space Center, or the European Space Agency, or whatever, there will be a time delay before we hear you, before we get your request, the data that you're sending, and it will be the same amount of time before you hear back from us, which means that you will have to be very self-reliant. And at the moment, the International Space Station is not in that sense self-reliant, because 400 kilometers over our heads, you simply can have a telephone conversation, and it will not be a strange conversation with long, silences in between. Because even if you were, sitting on the moon and interviewing me now, it only would be 1.25 second delay in before I heard what you were asking me, which is not so bad. I mean, it would be a bit different from now, but it's not really bad. But being on Mars, this, of course, also you can't phone home to talk with your loved ones. So that will be hard compared to what we do right now. And so we'll have to learn. And of course, the people that we send will be vetted, and they will be selected from thousands of people that would like to go, from hundreds of astronauts that would like to go. So already, experienced astronauts, but still, we're sending humans, which means you take yourself there with your quirks, with your personality, with your psychological makeup. So that will be an experiment. It will be very different from anything else we've done. On the other hand, it will be easier than going to being a civil servant from the Netherlands being sent to Indonesia 100 years ago, because then you wouldn't have the possibility to let your folks know instantaneously that you're okay. And even with a time delay, and if both planets are on opposite sides of the sun in their orbit, it would still, it would be 22 minutes before you would hear me speak. But that's 22 minutes. When you used to go as a civil servant to Indonesia, when there was still a colonial part of the Netherlands, it would take 6 months probably for your folks to know that your ship hadn't, drowned you, and that you were actually at Indonesia. So it's hard, but it's not really much harder than the things that we've already done as humans. So I do believe that we can do it. I mean, we didn't suddenly all turn out to be, very soft-shelled, spineless people. I do believe we can do this.
Bold moves in one way. And what do you think about Elon Musk, SpaceX Starship vessel in this whole puzzle jigsaw of going to Mars with human missions?
Well, what I like about Elon is he had an idea and he ran with it. And everyone thought in 2002 that he was crazy. I mean, what did he know about building rockets? Absolutely zilch. But he had the capability of hiring the right people. I mean, Gwynne Shotwell, who has been running SpaceX, was, according to her own words, his 7th employee, which means she had been there all those years.
So, do you think they will manage to provide this Starship? When you look at
I think so.
Yeah, when you look at this...
well, and not with hundreds of people in it, of course. I mean, he will be able to go to Mars, probably. I mean, let's face it, he has done all these things already in between, and so far it's been successful. He hired the right engineers, the rocket people, and everyone. So, and of course he does get money from government to make this happen. So saying that, he'll run out of money very soon is not very true either, besides the fact that sending satellites into orbit for others, for you and me, for a university, for a company, means that he's making money Sending goods to the ISS means he's making money because someone is paying him to do that. So as such, he has a good chance. And realize that it's hard what he's doing. It's as hard for him as it is for Boeing, Lockheed Martin, and Aerojet Rocketdyne. And those are far more experienced aerospace companies in the sense they've been around for a lot longer than SpaceX. But still, I think, it might not come about as soon as he's telling us. But he's going there. He wants to go there. He's young enough to stay alive for a while yet. And so I believe that it might happen indeed. And what it means, if SLS works out as well, that we have redundancy. We will have two opportunities. And of course, his dream of putting, 100,000 of people on Mars, I think people don't understand that if he's talking about that, it's his vision for the future. It's not something he's going to do in 15 years. It's something that he believes SpaceX will be doing in the future. And that future might be 20, 30, 40, 50, or even 70 years away. But he's building it. And if you believe in it and you set up your organization to do it, then you might do it. It's what other companies have done that gave us telephone lines, from the 1870s till now. I mean, they had a vision and they started it, and then, it came about. And no, we didn't have, lines, telephone lines on the sea bottom, in the first 10 or 20 years. But they came about, and we're now all connected. So if he says, I want to do this, and I'm putting my money and my capabilities where my mouth is, then I do believe that we might be seeing this. And like I said, the fact that he exists also means that he's pushing governments, because it's like, if you're not going, I am going. And so, and then they want to have a part of this. They want partly to control it, which they can only do if they keep working with him. So, yes, I do believe that SpaceX is a contributor to the fact that we're actually going, instead of just dreaming in the next 20 years or 30 years. We're actually doing it now. And SpaceX definitely helped that.
Mm-hmm. And what about other countries? Chinese want to go to Mars. Russians are saying something about going to Mars eventually. They are not working together. They're trying to do it by themselves. And will it help because we have a competition? Or rather, they should just bring it all together and make this, effort to do it together? Or is it simple fairy tale that they will go there?
Yeah, the thing is, if we're talking China, we're talking 1.4 billion people, an economy that's strong enough to have the money to do it, besides the fact that it's a dictatorship and not a democracy. So, if the leaders say we do this, it simply happens. There's no vote. No one will be able to stop it. And of course, they want to do this because they want to show that they're technologically speaking are as advanced as everyone in the West. And so, they will go there. And I'm not sure it's a bad thing that they do it on their own, in the sense that it's not a bad thing that if I want an internet provider here in the Netherlands, there are about 6 or 7 companies that I can choose from. Mm-hmm. And I do believe that space, in that sense, if it wants to mature into something that's not just a competition between governments, then having more governments, even small ones, contributing to this whole effort and doing their own thing. I mean, the United Arab Emirates have this vision that, by 2117, so, nearly 100 years from now, they will have about 1,000 of their people, their Emirati, live on Mars. Will this come about? I don't know, but they're working on it. And, if you have a vision and you're willing to put the effort in, you might succeed. And that's the same with all the other countries. And the fact that we have new space countries where at the moment, of course, they're mostly aimed at sending satellites around Earth. But that's how India started. It had all these satellite launches around Earth. Then it did something, a launch to the moon, and then it did Mars. So it's steps. It's like you don't start. If you're a child, you start to learn to crawl, and then you start to learn to walk, and after that you run and you learn to dance. It's not you learn to dance first. And I think it's the same with space countries. They start, crawling, walking, and then we'll see what gets from there. But I believe that in the end, in the next 50 years, many countries will be part of this, and they will start doing their own thing, and cooperation will come. I do believe that too.
It's a truly wonderful vision, and we live in a truly wonderful time. I'd like to compare it somehow on some levels to the times when Christopher Columbus and all these people that were discovering the world for the rest of us were starting their journeys. And this is our journey. This is the start of us being multiplanetary species, I think. So thank you very much, Artemis. It was a truly fine thing to speak with you. And now we will proceed with our show. So goodbye.
Goodbye. See you.
And we're back to our studio with Agnieszka Lewartowska, a volunteer during ERC 2020. Welcome, but of course you volunteered during this event, but you also participated in analog space missions, and this is something I would like to talk about with you, because that's very interesting that there are such missions. There are two types of astronauts. Part of them go to the space and part of them stay here on Earth and generate data. And okay, so as a warm-up question, what is your task here during this event? I'm a volunteer, so I offer my support near the show zone. So where we have our demonstration area, as you can remember, and I volunteer there. But when it comes to analog missions, so what kind of mission was that? I want to know everything. There were 3 analog missions, in fact, all in Poland. So you are an experienced analog astronaut, we may say. Yes, exactly. I participated in missions in 2018, 2019 and 2020, so not long ago. 2 missions were 2-week missions and 1 one-week missions. What was the objective of that? What did it consist in? Generally, depending on the mission, the main objective was to have a lockdown. We were locked for a week or for 2 weeks. We have no contact with the external world, with anyone else than the mission command center. It's like a big brother. You couldn't communicate, you didn't have an access to any information. Yes, but fortunately we're not recorded and broadcast on TV. But generally we were locked. And as astronauts at the ESS, we carried out experiments, and of course we monitored on a daily basis, 2 or 3 times a day, or even 5 times a day. We had to monitor our temperature, pressure, and other medical conditions. Of course, on top of that, we had to collect data, how much water we drank, how much water we used, and also record data with regard to the waste generated. We were scanned accurately just before the mission. We had to got special license for pilots, so they checked our eyesight and our ears. Of course, you can't have some eyesight deficiency, but you have to, people with some major conditions have to be eliminated, because that could disturb the measurements made. So they checked how you perform under the conditions of a lockdown. The selection of team members is also highly important, because very often missions fail because of the human factor, so the crew, because there is somebody who doesn't like to cooperate during the mission, but so the girl says, no, I will do nothing, I will not do that. Yes, it happened. Fortunately, maybe not during my missions, but I witnessed such a mission that the guy said, no, I don't like it, I won't cooperate, leave me alone. Okay, so you should throw him away next to the next satellite or asteroid. But generally in Polish habitats it is quite easy to take part in the mission, and then it appears that somebody got enrolled for a mission and comes to thinking, well, I don't like it. No, I've changed my mind. I don't like isolation. I don't want to work from 7 to 10 p.m. I don't want to work because everything is, the schedule is very strict and has to be rigorously followed. We have special time for meals, for performing all tasks, so you have no freedom and no flexibility. However, during last mission we had to have our meals on precisely on a scheduled time. It was related to one experiment related to light, so we had to have regular meals, but it was the dependency between the light and eating habits. What was that? No, these were experiments. Sometimes we cannot disclose it in details. We had to sign NDA contracts because that might be a part of some scientific publication, and we cannot talk about this. But sometimes it happens that people don't like the place, for example, and then they say, "Oh, oops." It happened that a mission was stopped or finished a day before because they couldn't get on with one person who was really troublesome. Okay, so it was not possible to get rid of one person because that would disturb the experiment. Yes, sometimes it happens that some person gets eliminated, but it concerns some extreme things. For example, some life events. So it's not worth finishing the whole mission. So one person is eliminated. In Poland, it's very important to eliminate any contact with daylight. That's very important. And sometimes after 1 week, it is really hard to support it in terms of psychology. People miss fresh air. There are no windows in habitats, or you cannot open the windows in the habitats. So the conditions are quite harsh. And what was the most difficult for you during these missions? All missions that you completed? To be honest, I'm a student and an IT student, so I'm a kind of a nerd stuck in my basement. So isolation in the very same place for 2 weeks, it's perfect for me. I like it a lot. If you know the diet, because we get information, so I knew I was what I can expect, so that was quite simple. But one time I had a crew with highly ambitious people. There was a Mars mission, there was a lot of money, but the commander said, but we have a Martian mission, so maybe we will limit the portions, and we were hungry. We had some meals, but we got hungry after 2 hours, and sometimes it's really hard to get on with some people, or other way round. People were not ambitious at all, and the mission started to be just an isolation, because generally mission should be isolation plus all rules to follow, all regulations, all plans, experiments, following schedules. But if a crew is reluctant, is lazy, they just want to entertain themselves, it is just isolation, and you should do it at home, so the objectives of the missions are not met. So it's very interesting, and you do a lot of interesting things. As I know, you have your blog and you broadcast that. What is your address? This is Dark Horse Projects on Facebook with dots. So, and I have my Instagram. This is Space Dark Horse. Do we have some time to add something? Maybe something short, just to finish? Okay, no, if we don't have time, maybe next time. Thank you very much, because we have to continue with our program. Thank you for your presence. It's great experience that you share these analog missions. We have our habitat near the city of Piła, now two of them in fact. The first one was in Piła, and that's true, but it is so complex that it's outside. We could talk about this for hours. So thank you very much for this interview. Let's go back to the Mars yard. Let's see what's going on then, and then we continue with our film that we recorded during our visit to the Cologne Space Astronaut Center. We will see how astronauts get trained before they go to the space. And now the Mars yard. Okay, so rovers were operated by different teams. Now they are in demonstration zone, in show zone. You can always join us here in Kielce at the campus of the Kielce University of Technology. You can come to our conference hall and ask questions. I know that some people watch us on the screen outside near the Mars yard. So Kielce, warm regards to all of you. Still 3 hours ahead of us until we will learn who is the winner of ERC2020. But let's remember that all participants are already the winners because they got qualified for this outstanding competition. This is as like in a marathon. If you complete it, you're the winner already. Okay, let's continue with our film.
A drastic mouse.
Kiedy 50 lat temu
When
człowiek po
50
raz
years
pierwszy
ago a
postawił
man
stopę na
put
Księżycu,
his
było to
foot on the
najdonioślejsze
moon,
i
that
najodważniejsze
was the
wydarzenie w
most
historii
outstanding
naszego
and the most bold event at the times of humanity, in the history of humanity. 12 courageous men put their feet on the silver satellite and could observe Earth from the distance. That had to be marvelous view, and this awareness that they are so special and they are so far from everything they love and they know, from families and friends, but also taxes and enemies. Never before or after, no one went farther from Earth than Apollo astronauts. Up to now. Humanity is ready to go back to the moon, but for longer or maybe forever. In all big space agencies, there are concepts made up how to go back to our natural satellites. There are procedures being defined for all space missions. They select contractors who will deliver space shuttles and landers, and concepts of habitats which should be the foundation for base. It's the same with European Space Agency thinking how to send European astronauts back to the moon. In order to know what they're doing, we decided to pack our bags and go somewhere where astronauts feel the best in Europe, to the European astronaut centers in Cologne in Germany. Okay, we're going there. First, we would like to go to the hotel to refresh ourselves. We will make about 1,000 kilometers in total. We are heading towards our destination, and we have a problem because there is no internet. We had everything on, all options and functions, and there is no connection. And it's not about that we cannot check our Instagram or post our pictures from the journey, but if there is no internet in the hotel, hopefully we will have it. We will not contact anyone from the European Astronaut Center, which is our destination. We had over 1,000 kilometers one way to go there. The astronaut center is seated in Cologne, in DLR base. This is a complex of institutions which implement space technologies. Nothing weird that European Astronaut Center has its office there. The center itself was founded in 1998 in order to be the center of all activities related to manned missions. Frank De Vine is the head of it, the former astronaut and former commander of the ISS. Experiments and modules installed in Columbus are tested here. What we could see there, it was a large swimming pool, the swimming laboratory where astronauts train before their missions held on the ISS. In order to understand what this place looked like, we talked about it with artist Evena, the head of it, who said about it. In Europe, we don't have a space suit for EVA. Such training is made in Houston in the swimming laboratory in full EVA suit. Here, astronauts of ESA learn how to perform tasks in this large
jak to
pool.
działa?
How it works? Behind
Za mną
me
widzicie te
you
makiety w pełnej
can
skali,
see
odwzorowujące moduł
mock-ups
Międzynarodowej Stacji Kosmicznej
reflecting the
Columbus.
Columbus module of the ISS. And
Zanurzamy te makiety w basenie i ćwiczymy z astronautami
they
kosmiczne
are
spacery.
immersed in the pool and we train
Jeśli miałeś styczność z
spacewalks
nurkowaniem,
with
to możesz
astronauts.
wiedzieć, że
If you
jeśli
had
twój
to
ciężar
do
jest
with
dobrze
diving, you
zbalansowany
know
w
that if
wodzie,
your weight is
będziesz
well
się w niej
balanced
unosił
in the
dokładnie
water,
tak samo, jak unosisz
you
się w
will
przestrzeni kosmicznej.
do the same
I dokładnie
movements
tego
as
szukają
in the
pracownicy
space.
tego
And this is
laboratorium, próbując
sought
symulować
by
warunki stanu
workers
nieważkości,
of
jakie
the
panują na
center.
zewnątrz
They
stacji
try
kosmicznej.
to
Jednak
simulate
w tym celu
zero
potrzeba nie
gravity
tylko basenu i
conditions,
makiet,
but in
ale
order
również
to do so,
wyposażenia i narzędzi.
they need mock-ups, but also tools and equipment.
Tutaj wyposażamy
Here
astronautów w
we
sprzęt, który
equip
symuluje
our
skafander
astronauts
kosmiczny.
with instruments and
Jednym z
equipment
ważniejszych
simulating
elementów jest ta maska
spacesuits.
do
One of the most
nurkowania,
important elements is
umożliwiająca
this
również
diving mask,
komunikację między
which
astronautami
make it
i z
possible to
instruktorem w pokoju
communicate with
kontrolnym.
the instructor
Maska ta ogranicza
and other
również
astronauts.
widoczność, podobnie jak
The
hełm
mask
skafandra.
limits the
Astronauci zakładają
vision
także
as
specjalną kamizelkę, która ma ich
spacesuits.
zbalansować
They
pod
also
wodą.
wear a
Dodatkowo
special
stelaż symulujący
vest
plecak w skafandrze
to
kosmicznym.
balance
Ma
their
takie
body
same
weight.
wymiary oraz umiejscowiony jest dokładnie w tym samym
It,
miejscu.
we
W skafandrze schowane
had
są w nim
in the
m.in.
the
systemy
suit
podtrzymywania życia.
has
Tu
all
mamy do czynienia tylko z
life
pustą skorupą.
suspension
Dodatkowo podczas treningów używa
systems.
się butów
Here
z
we have
podeszwą
only
podobną do tej w
the
prawdziwych
shell of
skafandrach
it.
kosmicznych.
They also
Jest ona
have
skonstruowana
boots
tak, aby
simulating the
astronauta mógł się
real
nią
space
zaczepić o elementy
boots.
powłoki stacji i mieć
They are
wolne dwie ręce do
constructed
pracy.
in a way so as the astronaut could
Ten sprzęt zakładany jest na
dock
tors
to
astronauty,
the
a
ISS.
do niego przyczepiane są
So they
wszelkiego
have
rodzaju
all
linki,
this
łączniki
equipment
i
on
narzędzia, którymi
themselves,
posługuje się astronauta.
and we put
Jako,
all
że
wires
astronauci
and
mają
links
bardzo
on
ograniczone pole
that.
widzenia,
Their
jeśli chodzi o sprzęt na
vision
skafandrze,
is
to
highly
muszą oni
limited.
dokładnie
They
zapamiętać
have
jego
to
umiejscowienie.
remember the positioning of
Centrum
different
Szkolenia Astronautów
attachment and
konsultowało swój
instruments.
trening z
The
NASA, tak aby
center
astronauci
consulted
mogli
the
kontynuować
training
ćwiczenia
in
już
NASA
bezpośrednio
so
w
as the
Houston.
astronauts could
Komisja
continue
złożona
the
z trenerów
training
i specjalistów
directly
od
in
kosmicznych
Houston.
spacerów pozytywnie zaopiniowała cykl
Experts
treningowy
gave
stworzony
their
przez ESA.
positive opinion and
Dzięki temu
approval
europejscy
of this
astronauci
type
mogli
of
być
training.
również
Thanks to
wybierani
that,
do
European
kosmicznych
astronauts
spacerów,
were
ponieważ nie
selected for
odstawali już
spacewalks
umiejętnościami
because
od swoich
they had the
amerykańskich
same
kolegów.
skills and capabilities as their American colleagues.
Przed zaimplementowaniem tego
Before
treningu
implementing of this
europejskim
training, the
astronautom było
European
dużo ciężej
astronauts
zakwalifikować
found
się
it
do
really
kosmicznych
hard to
spacerów.
qualify for spacewalks.
Amerykańscy astronauci mogli
American
ćwiczyć na miejscu w
astronauts
Houston
could
dużo więcej niż
train
europejscy,
in
przez co
Houston
lepiej wykonywali wszystkie
and
ćwiczenia.
were better in all tasks performed.
Spacery kosmiczne to ważna i
Spacewalks
właściwie
were
nieodłączna część
are
misji
an
na
important
Międzynarodowej
and
Stacji
indispensable
Kosmicznej.
part of
Bez nich nie byłoby
mission
możliwe
on
uruchomienie
the
stacji.
ISS. Without them,
Astronauci
it
musieli
wouldn't be
wielokrotnie
possible
wychodzić na
to
zewnątrz, aby połączyć
set
ze
up
sobą
station
elementy,
and to
które nie
start it.
mogły być
They have
połączone ze
to
sobą w prosty sposób, jak na
combine
przykład
elements
dokujące do
which
siebie
are not
moduły.
easy to combine,
Dziś,
for
kiedy stacja
example,
od lat
docking
jest już właściwie
modules.
skończona,
Now, when the
nadal potrzeba
installation is
kolejnych
already
spacerów kosmicznych
completed,
do
we need
nieustannego
other
utrzymywania jej w
spacewalks
pełni
in order to
sprawności.
maintain
Sprzęt ma to do siebie, że psuje się i trzeba go
the,
naprawiać lub
the
wymieniać.
ISS.
Czasami trzeba zamontować
It
nowe urządzenia,
requires
które
some
w całości lub w
replacement or
części muszą
some
znaleźć się na zewnątrz.
addition, and they
Astronauci
have to
wkładają więc
perform
kosmiczne
all these
skafandry
tasks
i
outside of
zabierają
the
się do
ISS.
roboty.
That's why they
To
have to
byłoby
wear the
niemożliwe bez wcześniejszego
EVCs
treningu w
and
laboratoriach pływalności.
do so, and that wouldn't be possible
Oprócz
without the use
astronautów w
of
basenie, jak widać,
the
kręci się
suits
sporo
and
nurków.
that type of
To
training. We
specjalnie
can see
wyszkoleni
many
specjaliści,
divers
którzy
there. These are
pomagają astronautom
highly
w trakcie treningu.
skilled specialists who
Realizują oni
support
zaplanowane
astronauts
zadania,
during the
wspierają
training.
astronautów,
They
zabezpieczają ich
give
pracę.
their helping
Generalnie
hand
bez
and
tych ludzi
protect
przeprowadzenie
them.
szkolenia
Without them,
nie
it
byłoby
wouldn't be
możliwe.
possible to carry out
Współpracuje
the
z nimi
training.
Katrin Nowak, która
They
pracuje właśnie
cooperate
przy
with
ćwiczeniach
Katrin
w
Nowak,
basenie. Dba o
who
harmonogramy ćwiczeń oraz o to, by
supervises
nurkowie posiadali
over
odpowiednie
training
umiejętności
in
do
swimming
wykonywanych
pool,
zadań.
and she defines the
Mamy
skills
grupę nurków, którzy
for them. We
zabezpieczają
have a
szkolenia
group
jako
of
dodatkowi
divers
ratunkowi.
who are
także ekipę,
safeguards
która
during
przygotowuje
the
całe
training,
podwodne
and the
środowisko
team
treningowe.
preparing the whole underwater
Przeprowadzamy
training
różne podwodne
environment.
działania.
We have
Mamy
to perform
trening
different
astronautów w
underwater
nurkowaniu,
tasks.
następnie
We have
szkolenia
diving
symulujące spacery
training,
kosmiczne.
then tasks
Przed tymi
simulating
wszystkimi
real
ćwiczeniami
spacewalk.
odbywamy
Before all
nurkowania
these trainings
przygotowawcze,
and tasks, we
także
have some
treningi zespołowe,
preparation
ponieważ
diving
nurkowie,
and
którzy z
team
nami
diving,
współpracują,
because
muszą być
divers
przeszkoleni,
cooperating with
jak
us
mają
have
zachowywać się
to
pod wodą i jak
also have
wspierać
to
astronautów
complete training how to support
Muszą poznać też
astronauts and
narzędzia,
how
których
to
astronauci
behave
używają
under
podczas
the water.
szkolenia.
They have to know the equipment used by the astronauts because they have to they are docked to this aircraft, and they have to know how to rescue them. So they prepare the whole scenario of trainings and the environment. Everyone has to follow the rules. They have to know what they should do. There are also camera operators under the water, and they get very strict instructions what to do and to follow the astronauts during the training. We need an insight into the tasks being performed after each training with the astronauts, and after each test we have to clean the underwater infrastructure. Let's move to a totally different place, 400 kilometers above, on the lower Earth orbit. There is the International Space Station, a real monument of human achievement and the fruit of cooperation. It's made of 16 modules. It used to be a home for 236 persons. It is powered by large solar panels, and it's a very bright point on our sky. It's hard to count all experiments being carried out in zero-gravity conditions, contributing to development of new technologies and new drives, and also to give us better know-how. It is functioning well thanks to women and men astronauts who risk their lives in order to work in the space. The European Astronauts Center trains astronauts, but not only. It also makes it available to test any kind of equipment that is going to be installed on the ISS. For example, the Columbus module. They do that thanks to the mock-ups of equipment. For example, here we have the mock-up of Columbus module, where they can train how to use instruments which are going to be installed in the module. There is also a demonstration mock-up for PR purposes. We could enter that and feel as a real astronaut inside and to simulate some experiments. When I found myself there, I found out that the space is the internal space, because there is 1 meter of free space at each side with all instruments which are very highly advanced. Outside they have totally different shape, and inside they are rectangular, but you have to go there in order to feel it. There is the whole team involved in testing and preparing the payload, and Stephen Ennis is one of them, the head of the unit. He's responsible for this is the team responsible for experiments and instruments delivered to the Columbus module. We've been working on about 30 to 40 experiments. Each experiment going to ISS has to be well proven, and documentation has to be attached to that. Here in the AC we have a lot of experiments, and we design them for Columbus module. My team is involved in all these tasks. We are involved in experiments themselves. The on-Earth segment is very complex. If you want to control something on Earth, you need a lot of infrastructure to communicate and to manage other coordination units. For example, storage of data. Of course, it may be troublesome, especially if you have the limited possibilities.
Makiety modułów kosmicznych WEAC używane
The
są do
mock-ups
celów
of
treningowych,
the
ale też do celów
module are
testowania
used for
integracji z
training sessions and
Spodziewałem
for
się skomplikowanej
integrating
części
equipment.
projektowania eksperymentów mających lecieć
This is
na
the
ISS.
most complex
Jeśli
part
producent
of
chce przetestować
testing the
systemy tu na
material,
Ziemi,
the
to może
systems on
skorzystać
the
właśnie
Earth
z
that go
zdalnie
to
obserwowanej
ISS.
makiety
And if the
Columbusa,
producer
tutaj w
wants to
Europejskim
test
Centrum
equipment on the
Astronautów,
Earth, they
która
can use
odwzorowuje wiele systemów
this
Robiąc
training
to, przygotowują się dobrze
station
do eksperymentu i
on
zwiększają
the Earth.
powodzenie zadziałania sprzętu.
Carrying out
Jeśli
these
chcielibyście umieścić
tests,
jakieś
they
urządzenie w module
increase
Columbus, to czeka
the
was
reliability
długa
of the
droga od jego
equipment later
zaprojektowania
on.
do
If you
wysłania
want to
na
have your
pokład
equipment on
Międzynarodowej Stacji
Columbus,
Kosmicznej.
then there's a long way to go before it ends up on ISS. Let's say you want a full-scale rack for equipment. You have to go through vacuum tests, ballistic tests.
Dzięki makietom WEAC można odpowiedzieć na
Thanks
dwa
to
ważne
these
pytania.
mock-ups,
Jak
you can
załoga
answer
będzie
two
używała
questions:
eksperymentu i jak
how
przygotować ich
the
do jego używania.
team are going to use
Można
the
też
equipment
sprawdzić
and
wszystkie
how to
połączenia i
get
sposób, w jaki
prepared
eksperyment
for
ma zostać zamontowany,
using
a
it,
następnie przygotować
operating it.
załogę, która będzie ćwiczyła razem z
You
zespołem
can go
szkoleniowym
through
i specjalistami od
checks
producenta
about how
eksperymentu,
to install
a
the
także obsługą
equipment, go
naziemną,
through
tak aby wycisnąć z
test
eksperymentu wszystko,
operation,
co tylko się da.
and find ways to use the full capacities of the equipment. As we understood in the field, the equipment is valueless if there is no well-trained team that can use it. Romeo Charles is part of the team, and he hands two big groups of people that assist the astronauts.
Pierwszą grupą jest ekipa
The
wsparcia,
first team
której
is
zadaniem jest
the crew
ułatwianie
support
codziennego
team.
życia astronautom,
They make
tak,
daily
aby
life
skupić się na
easier
misji.
for the astronauts so that they can
Począwszy od
focus
jedzenia,
on the
aż po
mission,
organizację
starting from
komunikacji z
food
ich rodzinami.
through communication with the families. The other one is
Wsparcia,
ESA
będąca
Eurocom.
jednocześnie głosem astronauty.
It's a support group that are at the same time
Pilnują oni,
a
aby
voice for
informacje
the
od
astronaut.
kontroli
They
lotu
make
docierały
sure
do
that the
astronautów
information
oraz aby
from flight
informacje
control
zwrotne były
reach
przedstawione
the
całej
astronauts
ekipie.
and that feedback is heard by the whole team.
Ekipa wsparcia podzielona jest na mniejsze części, a
The
każda z
support
nich
team is
odpowiedzialna
broken
jest
down
za
into
inne
smaller
elementy wspierania
parts
astronautów
and
tu na
each
Ziemi.
responsible for a
Jednym z
different
takich
element
oddziałów
of support
jest ten
here on Earth.
odpowiedzialny za jedzenie.
One of such divisions is the food team. Astronauts eat regular food prepared by NASA plus additional bonus food, which plays rather a psychological role rather than nutrition. And there's a special team under EADS for that. Support for the team covers also communication, for example, holding video conferences with their loved ones. Also, activities before the flight are
Gdy
important.
astronauta leci w kosmos, przez
When the
2 tygodnie
astronaut
poddawany
goes
jest
into the
kwarantannie,
space,
a
he
po
goes
jej koniec
through,
mamy
they
do
go
czynienia
through
z
quarantine
kampanią
for 2
przedstartową.
weeks. And then there's the
Jesteśmy tu z
pre-launch
astronautami i
campaign.
ich rodzinami, dbając o drobne
We
rzeczy,
spend
żeby
time with
wszystko
the
poszło
astronauts
bez
and their
problemu.
families, looking into small things and
Dzięki
making
temu
sure that
astronauta może
everything
skupić
goes
się na
smoothly,
misji, wiedząc, że ktoś,
so that
kto
the
jest
astronaut
kompetentny,
can
zadba o
focus
jego
on the
rodzinę.
mission knowing that somebody, a competent person, is taking care
Dodatkowo
of their
zapewniamy
family.
astronautom pliki takie
Also,
jak filmy, czy
We
wiadomości z Ziemi.
ensure news from the Earth,
Jako, że nie mają tam
movies
dostępu do
to
internetu,
watch,
więc podrzucamy im to, o co
since they do
prosili
not
przed
have
misją
access
i
for
otwieramy
to
małe
internet,
okienko na to, co dzieje się na Ziemi.
we provide what they asked for before their start, and we are their window to the Earth. To keep fit their special equipment on the ISS, while the team takes care of the science part, somebody else has to take care of their bodies. How does that happen? I asked one of the MDs that take care of the astronauts working with astronauts, what do you do? Well, generally it's about supporting the astronauts before, during and right after the mission. Currently, there's a European astronaut, Luca Parmitano, at the ISS, and I am his prime flight surgeon. The doctors that take care of particular doctors are also always, they have individual access and direct communication with them. They have to be on call 24 hours a day. Medical support already starts before the mission. When ESA astronauts work out, they work in MBL, that is huge swimming pools used for spacewalks.
Trening jest uznawany za niebezpieczny, ponieważ astronauci
This
narażeni są
training
na
is
różnego rodzaju
dangerous
warunki
because
zewnętrzne,
there's all
mocne
kinds of
przeciążenia w
external
wirusach, też dłuższe
conditions
przebywanie pod
like
wodą w
huge
akwarium.
loads
Lekarze wspierają
and
astronautów
long
podczas
time
wszystkich tych
spent
czynności,
underwater.
czuwając nad załogą w
The
razie
MDs
jakiegokolwiek wypadku czy
take
problemów
care
medycznych.
of the astronauts during all these activities.
Przede wszystkim jednak dbamy o to,
Above all, we have to make sure that the astronauts go into the outer space as healthy and in as good a condition as possible. They undergo all kinds of medical tests before they are sent to the space. We want to make sure that they have no medical conditions. We are limited in this space when it comes to medical equipment, and not always is there a medical support astronaut at the ISS. Some astronauts are trained physicians, but not all of them, so we have to provide detailed screening before the launch. Then everything speeds up. There is the 2-week quarantine, there's the medical doctor that joins them so that the astronaut is in the best possible shape. The team is with the astronauts also when the astronauts are in the space. Once a week there are private conferences through Skype or other communicators, during which the health condition is gone through with the astronauts. The astronauts report any possible issues, and the astronauts can call their doctors at any given moment, so if there is any kind of issue, they can inform the medical team so that they are provided the right kind of assistance or information.
Nie pracuję sama. Pracujemy jako duży zespół w naszym biurze medycyny
I'm not on my own. We are a big team in the Space Medical Center. We collaborate with Eurocom and a biomedical team. Eurocom is responsible for the health of the astronauts during the tasks and their carry out, but they also support us in terms of preparation, for example, of video calls with the astronauts. They also make sure about time agendas for the agendas to make sure that the astronauts are not overworked. Then landing is important. They land in a capsule in Kazakhstan. The team that greets them will involve an ESA physician. Very often the astronauts are not prepared for the conditions on Earth. For example, they might suffer from the sudden gravity on Earth, so they need medical assistance. Then they are assisted on their journey back to Europe, and they are assisted by a physician. After they're back, they need to undergo an intense training program with our assistance. The astronauts are supported before, during, and after the space mission. The astronauts are taken care of by physiotherapists that help them go back to a good physical condition, back to shape, and bring back their feeling of balance, which they've lost during the mission. A significant risk is calculated into the astronauts' work. Also, there might be conditions that were not identified on the Earth and might materialize in terms of illnesses during the mission. Another risk is space radiation. It is present inside the ISS, although there are special protections. ESA has to make sure that they are safe although the radiation is always there. This is the specialist for radiation, Anna Fortman. Her task is to prepare a strategy for assessing health risk for astronauts in a mission to the moon. Today, at the ISS, at the low Earth orbit, we use the so-called dose limits for space radiation, doses that reach humans and their vital organs. Through a calculation of the level of radiation inside the ISS, we calculate how much radiation has reached the astronauts' bodies, and we make sure that the dose is not exceeded. Both acute and stochastic effects of radiation are possible, and they might occur in terms of symptoms after some time after the mission. Acute symptoms are the so-called acute radiation symptom, shows symptoms straight away after radiation, for example, also observed in Hiroshima and Nagasaki right after the explosions. There might be strong doses reaching the astronauts after solar events that carry a lot of ionizing radiation. During long missions beyond the low orbit, we are also afraid of long-term stochastic effects, including cancer, but not only. Other results, other effects of radiation might cause tissue degeneration, including brain tissue and muscle tissue degeneration, including the heart muscle degeneration. Scientific research is focused on the effect of degeneration, which is relatively unknown because it relates to long-term effects of small doses. We know little about this phenomenon. We scientists are working on looking into the effect to see what the consequences might be. In terms of the current missions to the ISS, currently the only protection against negative effects of space radiation is prevention. That is, we monitor the doses that reach our astronauts during the missions, and we make sure that the exposure is not too high and not high enough to endanger human health and life. Additionally, we apply shields on the ISS, and during solar events, we make sure that the astronauts are located in further locations inside the ISS, so they are further from the sun. This whole mass of preparation for a future mission to the moon is really overwhelming, because this time it's not about demonstrating a country's power, it's about staying on the moon for a longer time. This is why it's not enough to repeat the success of the Apollo missions.
Because Apollo missions in terms of preparation and wouldn't be possible under nowadays regulations. That's why scientists want to find a safe and justified way to go to the space, but this work has to be done not in a decade, now, if you want to conquer the moon soon. The moon for our species was a source of inspiration since the beginning. In ancient times they saw that it was a source of magic, and it was reflected in their art. At the times, individuals understood that the moon is just an object in the solar system.
Trzech
We
śmiałków
have
zostaje w niej
a lot of
wystrzelonych w kierunku
stories
srebrnego
about
globu w
the
wielkim
moon
pocisku armatnym.
in the literature, for
Docierają do
example,
celu podróży,
Julius
a wszystko
Verne,
to opisane zostało w
where
roku
whose heroes
1865.
go to the moon, and all
103 lata
that
później
was
podobna misja
written in
odbywa się naprawdę. A
1865.
astronauci
More than
Apollo 8
100,
odlatują Księżyc.
about 100 years
Nadchodząca dekada
later,
przyniesie
this
powrót człowieka
mission
na
became
Księżyc.
a fact.
Aby to osiągnąć, nasz
Maybe the
gatunek musiał
future,
przebyć długo.
in the future we'll go
Od
back
apoteozy naszego
to
satelity po
to
stworzenie
that
technologii, aby móc go
We
zdobyć.
needed
Droga tak samo
technology
długa
in
jak
order
ta
to
faktyczna
go back
odległość
there.
z
It
Ziemi
is a
na Księżyc.
distance that we have to go in technological terms.
Obecnie zarówno ESA, jak i
Now,
EAC prowadzą
ESA
działania dotyczące
and
załogowych lotów
EAC
wyłącznie na
carry out,
Międzynarodową Stację Kosmiczną.
research with view
Jednak już teraz wraz z
to
partnerami z różnych
landing on the
krajów prowadzone
ISS,
są
but
rozmowy i
with
działania,
partners
które na
with
celu mają
many
przygotowanie
countries,
się do nadchodzącej
they
ery
are
powrotu człowieka na
engaged in
Księżyc
talks in
i
order
ustanowienia tam stałego
to
przyczółku.
send the man back
Na
to the
orbicie
moon
cisłunarnej,
and to
specjalnie
settle
wydłużonej
there
orbicie
in
okołoksiężycowej, zostanie umieszczona przygotowywana
in
wspólnie
this
przez kilka
orbit,
krajów stacja kosmiczna
there
Gateway,
will be a
będąca swego rodzaju
gateway
centrum dowodzenia, dookoła którego
station
wybudowana
on
zostanie w przyszłości
cislunar
infrastruktura księżycowa.
where the lunar
Orbita, na której się
infrastructure
znajdzie,
will be
została dobrana w
constructed.
taki
The
sposób, aby
orbit
z
where
jednej
it's
strony
going to be
ułatwić lądowanie na
installed has
powierzchni
been
Księżyca, a z
selected
drugiej
to
strony, aby
make
Gateway
landing
mogła
on the
służyć jako
moon
punkt startowy
easy,
dla
but
misji w
also to
odleglejsze
make
rejony Układu Słonecznego,
Gateway a
jak
starting
Mars,
point
system
for
Jowisza
the
i dalej.
conquer
Punkt
of
na jej orbicie
Mars
najbliższy powierzchni
and
Księżyca znajdzie się na
Jupiter.
wysokości 1500
It
km.
will be on the
Natomiast
altitude
najbardziej
of
oddali się na odległość aż
1,500
70 000
kilometers.
km.
And it
Stacja będzie
will
budowana przy
be
współpracy
possible to
Stanów
go
Zjednoczonych,
with
Europy,
it to the
Rosji,
distance of
Kanady i
70,000
Japonii.
kilometers.
ESA
It
dostarczy
will
moduł
be
Esprit,
made by
odwiedziony
Japan,
z modułu
US
zaopatrzenia
and
w energię,
Canada.
posłuży do komunikacji z Ziemią oraz ze
It
statkami
will
kosmicznymi, które będą
communicate with
kursować do
Earth and
stacji.
other
Będzie również
spaceships
współodpowiedzialny
that
za
will
zasilanie
shuttle
całej
between
stacji
Earth
Gateway.
and Gateway.
Zgodnie z harmonogramem ma zostać
According to the
przyłączony do całości w roku
schedule,
2024.
another module will
Rok
be
lub 2 lata później do stacji dołączony zostanie również międzynarodowy
added
moduł
in
mieszkalny, który także
2024.
zbuduje ESA.
After
Tym
that, the
razem we współpracy z
habitation
japońską
module will
agencją
be added.
kosmiczną.
It is
Stacja ma
developed
zostać ukończona do
currently by
2027
Japan
roku
and
i stać
ESA.
się
The
centrum
station
operacji
is to be
księżycowych,
completed
które
until
ostatecznie doprowadzić
2027
mają
and
do
will
założenia
become the
stałych baz
center
na
of
powierzchni
lunar
srebrnego globu.
operations
Europejska
and
Agencja
become
Kosmiczna
a
również widzi w tym
fixed
pole dla
base.
realizacji swoich
ESA
celów, czyli
also sees
partnerstwa
some
w początkowych
potential
etapach
in
podboju
that.
Księżyca
They want
oraz
to
uczestnictwie
engage
europejskich
in
astronautów w
partnership
misjach do
and
stacji
send
Gateway i na
European
powierzchnię naszego
astronauts
satelity.
to
Kolejnym
the
elementem
moon.
miałyby być
Another
robotyczne
element
misje na Księżyc,
would be
które
robotic
przygotowałyby
missions to
przedpole
the
do stworzenia w przyszłości
moon,
prawdziwej
which would
księżycowej wioski.
prepare
Żeby móc
ourselves
to
for
osiągnąć,
its
pracę trzeba było
construction
zacząć
of a
już w
real
tej dekadzie.
lunar
Dlatego też ESA,
village.
EAC i
But we have to
międzynarodowi
start
partnerzy starają się
preparation
wypracować
as soon
różnego
as
rodzaju
possible.
procedury,
That's why
stworzyć technologie
international
i ocenić
partners try
potrzeby
to
i wyzwania,
create the
jakie
right
staną przed
technologies
realizatorami
in
tego
order
planu.
to meet the
Wiele z
challenges
tych elementów zostało już
encountered
opracowanych,
by
jednak mnóstwo niewiadomych
by the
wciąż stoi przed
scientists. But
Europejską
there are a
Agencją
lot of
Kosmiczną.
questions ahead
Dlatego
of
też do życia została
ESA,
powołana
and
inicjatywa
ESA has
Spaceship
to answer
EAC,
them. That's
której
why
zadaniem jest
Spaceship
zgromadzenie
EAC
wokół wspólnego
initiative was
tematu
founded
powrotu na
in
Księżyc
order
ludzi
to talk
zajmujących się
about
różnymi
going back to
dziedzinami
the
nauki,
moon,
które będą niezbędne do
that
wdrożenia w życie planów
gathers people
księżycowych.
from many sectors.
Spaceship EAC łączy m.in. studentów
Spaceship
ze specjalistami
EAC
ESA oraz partnerów
gathers
zewnętrznych, tworząc
experts,
olbrzymi think tank,
university
w którym
students and
rodzą się nowe
external
koncepcje
partners. This is
rozwiązywania
a large
problemów stojących
think
przed ESA.
tank
Ale to nie
developing
wszystko.
new
Dzięki
solutions
tak szerokiemu
in
spektrum
response to
specjalistów
questions
dużo
asked
łatwiej
by
jest
ESA.
namierzyć problemy, o
Thanks
których
to
wcześniej nie
the
miało się nawet
cooperation
pojęcia
of many
i nie brało się ich
specialists
pod
from many
uwagę.
fields,
Misje księżycowe
new
będą
questions
diametralnie różniły się
emerged.
od misji na
These
ISS.
moon
Mimo olbrzymiego doświadczenia, jakie
missions will
zebraliśmy
differ
podczas programu
from
Apollo,
ISS
trzeba
missions.
będzie rozwiązać wiele
We
problemów, które
will
staną przed
have
astronautami
to
mającymi
use
pozostać
the
na
experience
Księżycu
of
na
Apollo
dłużej.
mission, but
Chociażby
answered a lot
grawitacja,
of
która wynosi
new
1/6
questions.
tego, co na
The
Ziemi.
gravity
Niby
there is
ułatwienie w porównaniu do stałej ważkości na
1/6 of the
ISS,
Earth one.
ale potrzeba nowych
So it is
technologii i
similar
nowych
to
rozwiązań, aby
ISS,
skutecznie i
however we
efektywnie
need
działać
new
w zastanych
solutions
warunkach.
in order
Trzeba będzie
to
zupełnie nowych skafander,
operate in
które
such
z jednej
solutions.
strony
We will
ochronią
need
astronautów
new
przed wrogim
EVA
środowiskiem,
suits
a z
to
drugiej strony
protect
będą jak najmniej
astronauts from
krępować ich ruchy.
dangerous conditions
Kolejną
and
przeszkodą będą
will
księżycowe
enable
temperatury, które
them
w oświetlonych
moving.
częściach mogą sięgać prawie 100 stopni
There
Celsjusza,
will be
a w
high
zacienionych spadać do
temperatures,
ponad minus
100
170.
degrees
Tym
centigrade.
wszystkim wyzwaniom trzeba będzie sprostać. sprostać.
to
I właśnie
minus
takie zadanie
70
stoi przed
degrees
inicjatywą
centigrade.
Spaceship
And
Earth.
this is
Praca w
the
interdyscyplinarnych
challenge
zespołach pozwala na
that we
spojrzenie
have
na
to
dany
mean.
problem z
So
wielu różnych
teamwork
perspektyw.
allows to
Dzięki czemu
perceive all
grupy
these
zaangażowane w
problems from many
inicjatywę są jeszcze
perspectives,
bardziej
thanks to
skuteczne
that
i są w stanie
groups engaged
opracowywać
in this
dużo lepsze
initiative and
rozwiązania.
even more
Dlatego też,
effective
kiedy inżynierowie
in
pracujący
finding
nad
solutions.
tworzeniem
That's why
technologii, takich jak
engineers
zasilanie baz,
developing all
misje
these solutions
robotyczne,
like power
produkcja żywności
supply
czy
or robotic
przekształcanie
missions or food
księżycowego
production
regolitu
or
i dróg 3D na
transformation of
powierzchni
regolith
srebrnego globu
and
napotkają
3D
na konkretne
printing
problemy.
on the moon.
Będą mogli
They will
skorzystać z
encounter
bogatej bazy wiedzy wypracowanej
problems,
przez
but
inicjatywę
they will
Space
have
Ship
a great database
Jednym z bardzo ważnych
developed
elementów
by
całej
these
układanki
experts.
jest
One
kosmiczny
important element
sprzęt,
of the
którego
jigsaw is the
lunonauci będą
cosmic
używać na powierzchni Księżyca.
instruments and
Misje
equipment
programu Apollo
used by
przyniosły ze sobą
astronauts.
w tej
Apollo
materii sporo
missions
wiedzy i konkretnych
brought
rozwiązań,
some
ale też wiele
knowledge in
problemów
that
nie zostało wtedy
respect, but
rozwiązanych.
many problems were
Dzisiejsi
not
inżynierowie pracują nad nową
resolved
rodziną
at that
kosmicznych
time.
narzędzi,
Now
których być może
experts
będą
work
używać
on
przyszli
a set of
lunonauci.
tools that
Jedną z
probably
takich
will
osób
be
jest
used by
Dorota Budzyn,
future
która wraz
astronauts.
pracuje w
Dorota
laboratorium
Budzyn is
pływalności,
one
a
of such
jednocześnie jest również
scientists. She
konstruktorką.
works for
Dorota
swimming
opracowała specjalny
laboratory.
wózek do
Dorota has
przewozu
developed a
narzędzi i
special
gromadzenia
carriage
próbek.
to carry samples and tools. So this is a piece of equipment that they brought to Nemo Visions NASA astronauts to lady astronauts tested all kinds of tools that we try to prepare for next lunar missions. This is a special piece of equipment which we can reconfigure to carry tools, and you have to bend it and drag it, but in this vertical position it serves for using tools easily if you are in your spacesuit. And this is a piece of equipment, this is a tool to mark samples, so we can adjust it. We have markers which can be applied to mark a sample. They are a bit higher in order to prevent lunar dust from covering them, so this is a post showing where we left our sample. If we imagine that we have a sample there, this is a replica of a tool used during Apollo mission, and an astronaut can grab the sample and then put it in the special bag for samples and
Urządzenie to ma
then
pomóc
to
astronautom
special
w przeprowadzaniu
container.
różnego
This
rodzaju
tool will
eksperymentów
help
geologicznych na
astronauts
powierzchni
in
Księżyca.
conducting all
Dorota
kinds
wraz
of
z zespołem starała się opracować je w
experiments
taki
on the
sposób,
surface
aby
of the moon.
astronauta miał tam pod ręką wszystko, co będzie mu potrzebne w trakcie
in a
misji.
way so as the
Ma po
astronaut
prostu
has
wziąć sprzęt i na przykład pobrać
everything
próbkę. Dlatego też zespół pracuje również nad
The
ergonomią
team
całego
is
urządzenia i
working on
narzędzi.
the ergonomics
Trzeba
of the
zwrócić
whole
uwagę na takie aspekty
tool.
jak na przykład
We
umiejscowienie
have
czy
to,
wielkość elementów, za które będzie chwytał astronauta i
we have to
zastanowić
take
się, w
into
jaki
account
jeszcze
the
sposób można
size and
ułatwić im
shape
pracę,
of
kiedy już polecą na Księżyc.
the samples and think how to make their life easier. This piece of equipment was tested under the water in the ocean near the habitat held by the Florida University and NASA. It is called Aquarius, and they organized 2-week missions during which astronauts and scientists test different exploration solutions. And our piece of equipment was ESA contribution to this mission. It was tested by Samantha Stiforetti and Jessica Watkins, NASA Lady
Dodatkowo olbrzymim
Candidate
wyzwaniem jest
astronaut.
księżycowy pył, co
Another
pokazały już
challenge is
doświadczenia z
lunar
programu
dust
Apollo.
that
Dlatego
we
nowe
know
rozwiązania
from
muszą być
Apollo
zaprojektowane
mission.
w ten
So
sposób,
new
aby
solutions
miał on na
have to be
nie jak
designed
najmniejszy
in a way
wpływ.
so to
Narzędzia muszą
eliminate
być
the
poręczne, ale i
effect
niezawodne.
of
No i
lunar
oczywiście
dust.
zaprojektowane tak,
Equipment
aby
has to be
odpowiadać na żywotne problemy
the
astronautów
best in its
przebywających na
class
powierzchni Księżyca.
in
Takim
order
urządzeniem jest na
to
przykład specjalny
collect as many
trójnóg do
samples as
podnoszenia
possible. Here we
astronauty,
have,
który
for example,
przewrócił się w
a
skafandrze.
tripod
Stanie o własnych siłach
to
byłoby ekstremalnie trudne, o ile
put
w ogóle
the
możliwe,
astronaut
i
back
naraziłoby
on
astronautę na
his
uszkodzenie
feet if
skafandra,
he
a w
falls
konsekwencji
down, for example.
obrażenia ciała
If he
lub
falls
nawet
down,
śmierć. Podniesienie go
that
przez drugiego
prevents
astronautę też nie
him
należałoby
from
do
death
najprostszych
or
operacji,
danger.
nawet pomimo obniżonej grawitacji.
Despite
Dlatego
the
też
low
w ERC opracowano
gravity
taki właśnie system, który bez
conditions, it
problemu
will
może być
work
dostarczony w
otherwise.
pobliże leżącego astronauty
So
i
it
użyty do
is
postawienia go z
easily
powrotem na nogi.
movable.
I
You
dlatego
can
też
always
astronauci będą
move
musieli
it,
trenować nie tylko
so
obsługę
as to
sprzętu,
help
ale i
the
odpowiednie
astronaut in
poruszanie się po
danger.
srebrnym globie. A
Of
tego typu
course,
ćwiczenia
also the
projektowane są już
movements
dziś.
that are going to be made on Loon
Treningi,
also
które tu
have to be
przeprowadzane z
designed. The
astronautami
trainings that we
dotyczą
had
działań
with astronauts
mikrograwitacji na stacji
concern
kosmicznej. Jeśli chodzi o przyszłe
microgravity
misje, podczas
conditions
których
on the
astronauci polecą na
ISS in
Księżyc,
terms of future
w chwili
missions
obecnej
and
nie
going
mamy
back to
jeszcze
the moon,
programu
at
szkoleniowego,
present we
ale
don't
wykonujemy
have a
testy,
special
które symulować mają
training
obniżoną grawitację.
scheme, but we the
Na
low
Księżycu wynosi ona
gravity
1/6 tego, co na Ziemi.
conditions
Możemy
are
zasymulować to pod
being
wodą,
tested.
obciążając
The
dodatkowo
gravity
wszystkich
on the moon is
astronautów.
1/6 of
Dzięki
the
temu
Earth
mogą oni
gravity.
skakać pod nie basenu i
That's
symulować
why
poruszanie się po
we test
Księżycu.
this environment in the swimming pool. The astronauts make all
również
kinds of
narzędzia i
movements and
sprzęt,
jumps
aby
to
sprawdzić,
simulate
jak
these
zachowa się w
movements. We
obniżonej
apply different
grawitacji,
types of
ponieważ to
equipment
zupełnie
and
inne
tools
warunki niż
to
panujące tu na
test this
Ziemi.
low gravity condition, because these conditions are
Na przykład,
completely
jeśli
different
chcesz
than
coś
the one
wbić
on
w
Earth.
księżycowy grunt,
If you want
będziesz
to
musiał użyć tam
dig in
większej siły,
the
ponieważ
surface
przy
of the
niższej
moon you will
grawitacji
have to
zwyczajnie
use
będzie to
more
ważyło mniej.
force, because it would weight less
W Centrum
on the moon.
Astronautów obecnie
In the
prowadzone są
astronaut
3 duże
center,
projekty
there
dotyczące
are
kolejnych
three
po ISS
large
misji.
projects being
Nazywamy je
developed
Future
now.
Exploration Projects.
These are future
Skupiają się głównie
exploration
na powierzchni
projects. They
Księżyca
focus
i jej
on the
eksploracji.
surface of the moon and its
Nazywają się kolejno
exploration.
Luna,
They are
Flex
called
Hub
Luna,
i
Flex
Energy.
Hub and
Luna
Energy.
jest niejako bazą,
Luna
swoistym
is the
hubem, który
base,
łączy
the
wszystkie
hub,
pozostałe projekty
merging
dotyczące
all
eksploracji
other
Srebrnego Globu.
projects related to the exploration of the
Flex Hub to
silver
rozkładany
globe.
i giętki moduł mieszkalny.
To
To będzie replika habitatu, jaki miejmy nadzieję będzie
living
mógł
module,
pojawić się w
replica
przyszłości na
of
powierzchni
habitat,
Księżyca.
probably the place where we will
Stanie
live
tu w
in
hali
on the
ćwiczebnej
moon.
w Centrum Szkolenia
It is
Astronautów.
in our training
Ostatnim
hall
z elementów
in
jest
the
Energy.
European Astronaut
Jest to dość
Center. The
skomplikowany
last
projekt,
module is
składający
energy.
się
It's
z
quite
wielu
complex
elementów.
project consisting of
Jeśli
many
chcemy produkować
elements. If
energię
you
na
want
powierzchni
to
Księżyca, to
generate
mamy nie lada
energy on
zadanie
the
przed
surface
sobą.
of the moon, it is a
Mamy
great
kombinację
challenge
wodorowych
ahead of
ogniw
us. We have a
paliwowych,
combination
ogniw
of
fotowoltaicznych, systemy
photovoltaic
odzyskiwania gazu
and
i wiele
hydrogen
innych skomplikowanych elementów.
fibers and many other
Dzięki tym trzem
different
projektom
elements.
EAC stanie
Thanks
się
to
w
all
pewnym
these
sensie
three
poligonem do
projects,
testowania rozwiązań
EEC will
księżycowych.
become a
Sam
polygon
projekt Luna
for
można określić,
space
jak stwierdził Steven,
solutions.
jako
As
wielką
Steven
piaskownicę.
said, this is a
Ma być
big,
obiektem wypełnionym ponad 500 tonami materiału
sandbox
symulującego
which will be
księżycowe
filled
regonit.
in with material,
Ten
filled
materiał
in
został
with,
dobrany tak, żeby
lunar,
przypominać jak najbardziej powierzchnię
like
Księżyca,
material.
ale z paroma
We
dodatkami.
want to
Jak
resemble
na przykład to, że
the
nie
surface
niszczy
of the
tak
moon
szybko
with
sprzętu jak
some exceptions, for
będzie to
example, the
bardzo
one
wiarygodne
that
odwzorowanie
this
tego,
dust will
co tam
not
zostaną.
destroy our
Oznacza to, że
equipment
można
as
będzie
fast
testować
as
skafandry, łaziki
the
i
lunar
cały
one.
sprzęt, który w
They
przyszłości
will
miałby
have an
lecieć na
opportunity
powierzchnię
to
naszego
test all
satelity.
rovers and
Jednak
all
sprzęt to nie
equipment that
wszystko.
will be
Potrzeba
dispatched
tam
to
też
the
ludzi,
moon,
którzy
but
to wszystko
equipment
obsłużą.
is not
I tak samo jak
everything,
w
because
przypadku
we need
astronautów
people, and
przebywających na
just as
pokładzie
with the
Międzynarodowej Stacji
astronauts
Kosmicznej, tak i też na
on
Księżycu
the
będzie trzeba
ISS
zadbać o
on
ich
the
stan
moon,
zdrowia.
we will
Nie
have
jest
to
to
take
jednak
care
tak
of
łatwe jak w
their
przypadku
body
ISS.
condition. It is not so easy as on the ISS.
Lecimy dalej.
We
Lecimy
go
poza
farther,
niską
we
orbitę
go
okołoziemską.
outside of the
Oznacza to
low
kilka rzeczy. Po pierwsze,
Earth
będą
orbit.
dalej
It
od
means
ewentualnej
several
pomocy,
things,
a po drugie,
that they
będą
will
mogli
be
zabrać ze
farther
sobą
and it
jeszcze
will be
mniej
harder to
zapasów.
give them support, and
Na
that the
ISS
level
mamy
of
całkiem
supplies
spore
will be
zestawy
lower
medyczne,
on
sprzęt
the
i
ISS.
środki
We have
zaradcze. Lecąc na
quite
Księżyc,
good
wszystko znajdzie się
storage
w mniejszym
of
module.
and inventory of
Musimy więc przygotować bardziej
resources,
kompaktowe
of
zestawy
supplies,
i upewnić się,
and for the
że mają
moon
podstawowe
we
zapasy
will have
ze
to
sobą.
prepare compact sets
W tym momencie
and
tworzymy
limit
procedury dotyczące minimum,
supplies.
jakie astronauci muszą
Now we
zabrać ze sobą na
define
misję
procedures
księżycową.
with regard to the minimum payload
Problematyczne
they
staną
will
się
have
też
to
opóźnienia
take
w
with them.
komunikacji.
What is also
W przypadku
problematic,
Księżyca
these
będą
all
na tyle
are
niewielkie, że
delays in
właściwie pomijalne,
communication.
ale już w trakcie podróży na Marsa mogą
When
wynieść
you
nawet
go to
kilkadziesiąt
Mars,
minut.
it is,
Również znajdując
it
się
can
po
be
drugiej stronie
dozen-
Księżyca,
several
astronauci
dozen of
będą
minutes.
pozbawieni kontaktu z Ziemią. Dlatego też poskutkuje to
Astronauts
dużo bardziej
will
szczegółowym szkoleniem
not be in
medycznym.
contact
Astronauci będą
with
musieli umieć poradzić sobie w
Earth,
sytuacji
all
braku
the
wsparcia ze
time,
strony
so
lekarza
they will
znajdującego
have
się
to
na Ziemi.
get training
To, co będzie różniło
for
misje księżycowe od tych, które
possible,
przeprowadzane są na pokładzie ISS, to na pewno obecność księżycowego pyłu.
procedures.
Wiemy z misji
What is
Apollo, że
very
nawet pomimo starania, by
important, we
utrzymać
have to
wnętrze
remember
lądownika w
about this
czystości, pył przedostawał się
lunar
wszędzie.
dust.
Jest bardzo
It is highly
elektrostatyczny i przykleja
problematic
się do
because it's
wszystkiego
highly
jak kurz, a
electrostatic
jednocześnie
and
jest bardzo ostry i potrafi niszczyć zarówno
sticks to
powłoki
everything.
skafandra,
It is
sprzęt,
very
jak i niestety drogi oddechowe i błony
harsh,
śluzowe
and
astronautów.
it can destroy
Z medycznego
equipment
punktu
as well
widzenia
as
należy zadbać o
breathing
to, żeby
duct
wystawiać
of
astronautów
astronauts.
na jak najmniejszy kontakt z pyłem
So
oraz
they
opracować
cannot be
procedury i
i
in
terapię na
contact with
wypadek,
that
gdyby jednak
dust,
ten
and
przedostawał
some
się do ich
procedures
organizmu.
and therapy has to be defined in
Kolejnym
order to
problemem
deal
jest
with that.
promieniowanie.
Another important thing is radiation, because we will go outside the Earth's magnetosphere.
To również coś, czym się
That
zajmujemy.
is something that is at
Poza
the
tym,
heart of our
jeśli chcemy myśleć
attention.
o lotach na
Apart
Marsa,
from
czy
that, when we
jeszcze
think
bardziej
about
odległe
going to
zakątki
Mars
Układu
or
Słonecznego,
farther
to jest to
corners
jedno z
of the
głównych
solar
wyzwań do
system, this is
pokonania.
one of the main challenge to be overtaken.
Today
Today we know that the tools that we have on LEO will not be applicable outside of it, because this radiation below LEO is totally different than outside of it, for example.
Lecąc na Księżyc lub w dalszej perspektywie na Marsa, astronauci
on the
będą mieli
ISS.
do czynienia z większymi dawkami promieniowania
When
kosmicznego niż
the
na
farther
niskich
they
orbitach
go, the
okołoziemskich,
more
ze względu na
radiation
brak
they
ochrony pod
get.
postacią ziemskiej magnetosfery. Jest to
Because
magnetyczny płaszcz
Earth
tworzący
is
się
protected
najprawdopodobniej dzięki
by
ruchowi
its
zewnętrznego
natural
jądra Ziemi
coat, which is
dookoła jądra
magnetosphere.
wewnętrznego. Płaszcz ten odbija
This
cząstki wiatru
coat
słonecznego, dzięki czemu do
reflects the
astronautów na pokładzie
particles of
ISS dociera ich
sun's-
znacznie mniej
sun
niż w otwartej
wind
przestrzeni kosmicznej.
and protects. But when it comes to missions outside of LEO, we are just developing strategies, and this is one of the objectives of my work. That is why we try to establish the strategy how to deal with radiation if it's gets higher, through configuration of the payload on the station and through the application of more rigorous models which predict health risk, and all that will be related to limited time of mission and exposure. This is our strategy for now that we will apply during our mission to the moon. Of course, a lot has to be done in terms of shields. There are works underway. This technology is based on hydrogen, and there are also works on personal shields and personal protection, that is vests that could be worn by the astronauts in the conditions of higher radiation.
Póki co nie istnieją żadne
For
farmakologiczne
now,
środki,
there are
które
no
mogłyby skutecznie chronić astronautów.
pharmacy,
Natomiast zespół Anny prowadzi badania nad poszukiwaniem środków w pewnym sensie biologicznym. Zespół poszukuje sposobu, jak zmienić profil misji i codzienne życie astronauty na pokładzie statku kosmicznego, tak żeby jego oporność na promieniowanie wzrosła. Na przykład poprzez stosowanie odpowiedniej diety. Człowiek w kosmosie to olbrzymie wyzwanie dla wszystkich zespołów pracujących przy misjach załogowych. A człowiek poza niską orbitą okołoziemską to wyzwanie podwójne.
Oczekujemy już kolejnych misji księżycowych.
W
W tym momencie pracujemy przy programie księżycowej stacji orbitalnej Lunar Gateway, która pozwoli astronautom zbliżyć się do Księżyca, a ostatecznie lądować na nim. Od strony ekipy wsparcia widzimy, że to, co udało się wypracować dla astronautów na ISS, będziemy próbowali kontynuować i rozwijać też w przypadku misji księżycowych. Przykładem będzie na pewno jedzenie. Wiemy, jak dostarczać jedzenie na ISS, ale wymaga to ciągłego transportu. Jeśli polecimy na Księżyc albo i dalej, astronauci będą musieli hodować własne jedzenie. Mamy więc teraz sporo eksperymentów, które badają, jak to zrobić, jak wytworzyć wymagane przez astronautów ilości jedzenia.
Astronauci, którzy polecą na Księżyc, będą mieszkać na stacji Gateway, czy w przyszłości w księżycowej wiosce. Będą więc podobnie jak astronauci na ISS odseparowani od bliskich i naszej planety. Takie odosobnienie również ma wpływ na zdrowie i samopoczucie astronautów. Roman zna to z doświadczenia. Był członkiem programu Mars 500, w ramach którego 6 osób zostało zamkniętych na 520 dni w odosobnieniu w celach symulowania pełnego lotu na Marsa.
Mars 500 było unikalnym doświadczeniem i nauczyłem się tam wielu rzeczy. Właściwie to praca, którą wykonuję, czyli inżynier zespołu wsparcia załogi, tu w ESA, jest z tym związana. Kształciłem się z inżynierii mechanicznej, więc zajmowanie się wsparciem załogi nie jest zajęciem, które wynika wprost z wykształcenia, ale ponieważ spędziłem 1,5 roku w modułach Mars 500, doświadczyłem niemal fizycznie, jakie są konsekwencje i trudności życia z dala od rodziny i w zamknięciu. Kiedy szukali kogoś do ESA, moje doświadczenie pomogło mi dostać tę pracę. I zauważyłem w pewnym momencie, że mogłem wręcz poczuć, dlaczego astronauci reagowali w konkretny sposób. Ponieważ sam przechodziłem przez podobne sytuacje. Na przykład podczas Mars 500 miałem takie momenty, które były cięższe i nie miałem siły, by wykonywać dodatkowe zadania.
I właśnie podobne momenty Romain potrafi zauważyć u astronautów. Objawia się to na przykład tym, że stają się mniej rozmowni. Jego doświadczenie zdobyte podczas Mars 500 pozwala mu wykryć takie momenty i udzielić astronaucie odpowiedniego wsparcia. Pomóc rozładować stres, rozwiać ewentualne wątpliwości czy udzielić dodatkowych potrzebnych mu informacji. Dlatego też rola wsparcia załogi jest bardziej osobista niż tylko kwestie kwatermistrzowskie. Astronauta wie, że ekipa nie tylko zadba o wszystkie kwestie logistyczne, ale będzie też wsparciem w tych trudniejszych momentach. Nie sposób pokazać w pełni ogromu pracy, jaki złoży się na powrót człowieka na powierzchnię Księżyca. Ilość ludzi, zadań i problemów do rozwiązania jest przepastna. A żeby to wszystko pokazać, ten film musiałby trwać pewnie tydzień. Chociaż i tak nie ma pewności, czy nie pominąłby jakichś ważnych aspektów. Zarówno inicjatywa Spaceship Earth, jak i wszystkie inne podejmowane w innych placówkach nie mogłyby się udać, gdyby nie współpraca między ludźmi z całego świata. Specjalistami w swoich wąskich dziedzinach, którzy dzięki możliwości dzielenia się swoim doświadczeniem i wspólnej pracy nad tak olbrzymim projektem będą w stanie doprowadzić ten plan do finiszu. Kiedy Amerykanie wylądowali na Księżycu, było to wielkie zwycięstwo ponad 500 tysięcy ludzi zaangażowanych w pracę nad programem Apollo. Było to też wielkie zwycięstwo całej ludzkości, która po raz kolejny przekroczyła granice swoich możliwości. Ten wyczyn miał jednak jeszcze jeden ważny wymiar, o którym często zapomina się, wracając pamięcią do tamtych wydarzeń. Inspiracja. Program Apollo zainspirował rzesze młodych ludzi, którzy w konsekwencji związali swoje życie z nauką, inżynierią i dziedzinami ścisłymi. Wiele z dzisiejszych odkryć, wynalazków ułatwiających nam życie czy naukowych przełomów ma swój początek właśnie w tamtych wydarzeniach. To o tym mówił Neil Armstrong, stawiając stopę na powierzchni Srebrnego Globu. Mały krok jednego człowieka, ale jakże wielki skok dla całej ludzkości. Tego typu inspiracją będzie również powrót człowieka na Księżyc, a następnie pierwszy załogowy lot na Marsa. Jednak wiele jest do zrobienia też lokalnie i na nieco mniejszą skalę. Wiele naukowych wydarzeń jest w stanie zapalić w młodych ludziach ogień, który będzie napędzał ich do dokonywania kolejnych odkryć, przekraczania kolejnych granic, konstruowania jeszcze lepszych i bardziej użytecznych mechanizmów. Jednym z takich wydarzeń są na przykład europejskie zawody łazików marsjańskich, które oprócz wymiaru inżynieryjnego i współzawodnictwa niosą również inspiracje dla przyszłych pokoleń naukowców i inżynierów.
New generations of engineers. Such projects are inscribed in the broader picture, because inspiration is part of them. We have to, this competition is about facing up challenges, scientific and exploration of a new celestial bodies. What we do in ERC is related, and that inspires towards the robotics, because next generation of rovers will cooperate with astronauts. This new generation of scientists who work for space industry, these are not people who work for space industry. They come with some potential and with experience. We have people who took part in some robotic tasks. They had some were engaged in some university projects. So these people who will get involved in the lunar projects, they
participate
Powrót na
very often in
Księżyc i
projects like
zbudowanie tam
ERC.
stałej bazy
Going
jest
back to the
jednym z
moon and
najważniejszych zadań, które
settling
stoją
there
obecnie przed
is one
ludzkością.
of the
Można
main
zastanawiać się,
challenges
jaki jest
ahead
sens tego
of our
wszystkiego, skoro
humanity.
na naszej planecie
We may
wciąż jest
think, what is
mnóstwo
the
problemów do
sense of that?
rozwiązania.
Because we have so
A
many problems to
kolejne
solve
pojawiają się
here on
właściwie
Earth,
każdego dnia.
and we meet other ones
Eksploracja
any
kosmosu,
day,
a w
every day.
konsekwencji
Exploration
zdobywanie i
of the
kolonizacja Układu
space and
Słonecznego
colonization
są
of the
nie
solar
dość, że
systems
niezbędne do tego,
are
aby nasza
indispensable
cywilizacja mogła
for
przetrwać
our
i dalej rozwijać się.
civilization to
To wręcz
thrive and
wpisane
to
w naszą naturę.
develop. It
Kiedyś
is
jaskinia,
inscribed
w
in
której
our
mieszkał człowiek,
danger,
stała się zbyt
in
ciasna.
our
Wyruszył
nature.
więc w podróż.
Before we lived
Podróż,
in
która
caves,
zaowocowała
but
opanowaniem
people
planety,
set off
rozwojem
on
i
a
doprowadziła do
journey,
miejsca, w którym
and that
znajdujemy się
journey
obecnie.
led us to the place
Za
where
jakiś
we
czas
are
Ziemia,
today.
nasz dom,
Soon
podobnie
Earth,
jak
our
kiedyś jaskinia,
home
również stanie
as
się zbyt ciasna.
cave in the
Dlatego już
past
dziś
will
musimy
become
zacząć
too little
przygotowywać się
for
do
us. That's
najważniejszej
why we
podróży.
have to prepare for
Podróży,
the
która
most
pisana nam była
for
od
the
początku.
most important journey in our lives, which was our destiny from the beginning. Dear old Martian that we can see, and that was our film from the European Astronaut Center of the in Cologne in Germany. And now on the Mars yard, the competition is over. It was not a fierce competition, it was just a challenge, and the attempts to meet this challenge organized within ERC2020, but we still have some attractions to you before we will start the gala part, the announcement of result, and before we will get to know the winners. A lot of interesting things ahead of us, so hopefully within a decade we will land on Mars. That would be something incredible. I hope that it will be possible during my lifetime, and I will have this outstanding opportunity to see that, to watch that, and maybe to comment that on my channel Astrofaza. We will see whether Astrofaza will be still there, because probably we will, let's hope we will grow. So we would like to sit together and do something like a live broadcast from landing on a different planet. So that would be another important step in the development of our humanity, the whole humanity, because this is always cooperation, international cooperation, maybe not political, but international cooperation of engineers from all over the world who under one brand, this or that, they manufacture, design and construct new technologies. Do we have any questions from the audience to talk to you a bit? before we will move over to next elements of the program. We have some interesting things. Peter Warden, then Kamil Muzyka, and Pete Warden and his breakthrough initiative. We will talk a bit whether it's worth looking for signals of other civilization in the outer space and how to go to Proxima Centauri and e-competition. Now we have the third we will learn who was ranked as first. Ziggy ranked as the second. Congratulations. A lot of people joined in order to take part in this e-sport part of our ERC this year. Ishat Raihan, the first place, I don't know how to spell it correctly, but my congratulations on this first place. He proved to be the best one, the fastest engineer, so the golden wheel will be awarded to him. And this is the simulator where everything is taking place. All that thanks to Pyramid Games and ERC, and organize this virtual competition, and during next edition probably we'll have the same, and you will have opportunity to take part in it once again. We will have a talk with Kamil Muzyka about transhumanism. What is that and what are connotations with that? I have high hopes towards this conversation. We have another entry that will be Sun, a usual star, and that was prepared by Youth Astronomical Observatory. We will talk to Karol Wójcicki, who is active in the show zone, but probably he will visit us to tell a bit about his trips to Iceland. Maybe you would like to learn something about the Sun, which is our outstanding star, which David showed during one Astro shows. Why the Sun is a normal star on one hand, but on the other there is a lot of curiosities in it, and it's so interesting. So let's learn something about the Sun. Unfortunately, we couldn't join you, so let me invite you to the lecture about the Sun. We will start from a quotation. Far out in the uncharted backwaters of the unfashionable end of the western spiral arm of the galaxy lies a small, unregarded yellow sun. This is from the Hitchhiker's Guide to the Galaxy, and that reflects what is our Sun in comparison to other stars. It is an average star located in an average galaxy. It is a small star, a yellow dwarf. It is the fact that Earth is located close to it. It is why it is so outstanding. It has been represented on many pictures, and here Donato Creti's image observation of the Sun. A man has some sheet of paper and has a telescope, and the Sun is visible on this sheet. This is the projection method. The telescope is located and it's targeting the Sun. We are not observing the Sun with our own eyes, but we make a picture on it and we reflect it on the sheet of paper. You have to be highly careful during the observation of the Sun, because the whole Sun is concentrated, is focused on a small glass lens, and it may get melt. A more safe way to observe is to observe the Sun through a Miller filter or a specialist narrowband filter. Like there are many examples of them. For ages, the sun embodied the gods. Egypt has Amun-Ra, Greece, Helios, Rome, Sol, and we had our own Polish version, Svaruk. We always knew that he supervises us from dusk to dawn, but the truth is totally different, because the sun is a ball of fire, very highly hot. We have to add one important thing. We are in a galaxy called a Milky Way. The whole word galaxy, galacticos, means milky. The Greeks thought that this is a milk of one goddess. Now we know that this is just a ball made of dust and gases.
Well, its arms are in the form of a windmill, and the crossbar is what you can see in the picture. Recent studies show that our galaxy is not flat, instead it's curved. This is proof of a collision that took place a few billion years ago. Quite possibly there are two galaxies that crashed one against the other, causing our disk to be slightly curved. We are not in the center of the galaxy, not at the rim. We're somewhere in the middle between the center and the border, the rim of the galaxy, and we look at it from the very middle. The Milky Way, from our point of view, looks like this, like a line of stars. Unfortunately, you cannot see it in the city because of the artificial lights. Our planet, our sun is in the middle of our galaxy, and is the most important element of the galaxy because it keeps all the planets in its place. There's one star, the sun, 8 planets, which you know very well, 7 dwarf planets, at least this is how many we've found so far, including Pluto, that has been degraded from a planet to a dwarf planet. We have 209 moons, while this might increase because still new moons are being discovered from the more distant planets. We have over 3,000 planets catalogued. We keep waiting for them to be closer to the sun so we can find out about them, and over 950,000 planetoids. Our galaxy is 4.6 times 10 to the 9th years old, and the sun is the heaviest object in our galaxy. Is 33,000 times heavier than our planet. If you took a balanced scale, you put the sun on one side, you would have to put 33,000 Earths on the other one to balance the scale. The diameter is 1,400,000 kilometers, which is much more than Earth's diameter. You would need 109 balls the size of Earth to cover the diameter of the sun. The temperature is almost 6,000 kelvins at the surface, 15 million Kelvin at the core, and the external layer, that is the corona, is 2 million kelvins hot. We don't use the Celsius scale in astronomy because it's not very handy. The Kelvin scale is very similar to the Celsius, but 0 kelvins is 273 degrees Celsius. The distance from the Earth is 1,150 million kilometers from the Earth, which varies because our orbit is elliptic. So it varies depending on our location. Paradoxically, we're closer to the sun in the winter than in the sun. The sun is the brightest object in our sun, that is 4.8 magnitudo. If we wanted we would have to take 33 light years from the sun. That's the distance to which the Earth would have to be distant from the Earth, which would mean that then we could observe the Sun without any special filters and equipment, and the nebula type is GV2, that is a white dwarf. It was formed from a nebula of ash powder right after the Big Bang. Is the not directly after, because it's either the second or third generation of stars after the Big Bang. So after an explosion, the central object started forming, and from what was left, our planetary system, our solar system, was formed. So actually our planets are remains of what our sun was formed from. How do we know that? Using the Hubble telescope, we can look into places where new stars are born, and even whole planetary systems are formed on before our eyes. Nobody lives long enough to follow the creation, the formation of a sun, of a star, but looking at different stars, we can follow the whole process of formation at different stages. Picking up on the famous movie, onions and cakes have layers, and the sun has layers too. There is the convection zone, there's the core, the radiative zone, and the corona above the photosphere. And the chromosphere is the first layer of the atmosphere of the sun, and the most external one is the sun's corona. The core has as a task the creation of enough energy for the sun to function properly. The energy in the sun is created in the proton-to-proton process. We need four cores of hydrogen, and they crash, and helium is created. In this process, there are 4 million tons of hydrogen, and that, according to Einstein's EMC squared, is pure energy, light, and heat, which provides the energy for life on Earth. So 4 million tons per second is how much the sun is losing every second. This energy is trying to go from the core to the surface, but the energy is extreme, and the photon that tries to go outside is emitted in a random direction, and the exit of such a photon from the core to the surface could take even 1,000,000 years. These are the so-called Brown's movements, where the photon bangs against different particles before it reaches the convection zone. The convection zone is where cool and hot gases mix and the photons are moved to the surface. The hot gas cools down and goes back towards the lower layers, and what's visible as a result of this process is granulation on the sun's surface, and what we see is the photosphere. Remember that there is no stable ground on the sun, it's just a great ball of fire. The photosphere is usually very peaceful and calm, but sometimes there are spots, which we will go back to in a minute. If we look at the sun's surface from close up, you'll see granulation. It's not smooth as you might think, it's a boiling soup. It's like a Napoli sauce, as I like to say. Something is boiling at all times. These are 2 hours of observation from an observatory on the Earth. You can see that there's something going on at any given moment. Such single ball, you can see a single bubble is millions of kilometers wide, so this is humongous compared to the Earth. Now the sunspots are the black dots on the sun's surface. They are cooler, by 1.5 degrees Kelvin compared with their surroundings, so they are black because they're much cooler. Still, they are 4.5 thousand kelvins of heat. So if you put it on a clear air in the clear sky, it would be brighter than the moon. And you, in this picture, you have a comparison of size with such a sunspot with the Earth's size. They appear in an 11-year-long cycle. They appear every 11 years more or less, and they go back to normal, and the sun is again smooth. We are currently at the minimum activity, and for a dozen years years we have not had any activity. This might go on for some time, and in a few 5-6 years the maximum peak of activity will be reached again, and the sun will be very active, like like in this picture that you can see in this picture, where there are a lot of sunspots on its surface. And imagine that every single black spot is much bigger than the whole Earth's surface. Imagine that the sun is much bigger than the Earth, but still it's a small star compared to other stars. There's a magnetic field in the sun's surface, so you can imagine these black spots as places where this magnetic field goes outside, and since they have to be balanced, there are always two spots, one of which is the south and the other the north pole. So these sunspots are always paired, coupled. There's a north and the south one. The sunspots have such a strong magnetic field that it's capable of stopping the flow of energy from the core of the sun, and this is why the sunspot is cooler and slightly lower than the external diameter of the sun, so it's a hole, so to say, in the surface. When they appear, very often there are flares on the sun, and when they come close together, they are different poles, so the reconnection takes place and huge amounts of energy are released. And this 11-year-long cycle is reflected in the number of spots, but also in ultraviolet or H alpha. You can see that the sun changes if you look at 1996 up to 2001, when there was a maximum of activity on the sun, and then step by step it calmed down until 2006. If we looked at the sun for many years, we would notice that every 11 years there's a peak of activity where there are a lot of sunspots on its surface. You can see that in the graph. Interestingly, between 1650 and 1715, there were practically no sunspots observed. That's the so-called Maunder minimum, correlated to the small ice age. Winters in the North Hemisphere were strong enough for the Baltic Sea to freeze. You could go to Sweden. On the surface of the iced Baltic Sea and on the River Thames there was a bazaar organized because it froze. That's a result of these changes in sun's activity. This is a piece of the sun's activity from the start of the 20th century, and you can see that they vary. Some are longer, some shorter, and some there is a higher activity, and some there's a lower one. But we can see a tendency since the 80s showing that every next cycle is weaker. This might be as a result of the fact that alongside this 11-year-long cycle, there might be cycles counted in hundreds of thousands of years, so this might be a result of different cycles overlapping, but we have been observing the sun for too short a time to definitely conclude whether that's true. Where do these cycles come from? Well, there's this plasma, very hot gas, and these lines on the surface are stretched and curved, and when that happens, there's the maximum of activity on the sun's surface. Above the photosphere, there's the atmosphere of the sun, that is the chromosphere. It's cooler, around 4,500 degrees Kelvin. And to look at the chromosphere, you need a filter, for example, a H-alpha filter, and that's when you can notice the other interesting side of our sun, not a yellow ball anymore, but interesting structures on the surface. The bush that you can see, they are called they're called solar prominence, and for a number of days such a solar prominence can stay in place. And these pictures have been taken by the users, the participants of the observatory in Niepołomice, youth observatory, and you can see the solar prominence on the sun's dish. And the most external layer of the sun is the corona, even up to 150 million kilometers above the sun. And until recently, only eclipses, complete total eclipses, allowed for its observation. Now we have coronagraphs that allow for looking at this corona layer. This is a typical corona observation, a photo, and what we call CME, coronal mass ejections. The corona, the biggest eruptions can be observed. That is huge flare-ups of plasma, billions of charged particles blown in different directions, ejected in different directions. Let me show you what we see here on in this picture. This disk cuts out the certain amount of sun that reaches the telescope. The internal ring is the size of the sun itself, and this CME is what you see here, is the humongous explosion of millions of tons of plasma that later on travels through the space. Sometimes it reaches the Earth, which is when we get a beautiful northern light, or we might have problems with satellite connections, and it's a danger for the crew of the International Space Station. Now what you can see here is an observation on your right hand side from 2003 from the SOHO satellite, and the sun is bursting huge amounts of plasma in all directions, and we get to this October 26th, you will see a huge amount of plasma going towards the camera, and you'll see a snowing effect, and we lose the pictures. That's when you see it. That's the first explosion, and the second one in a minute. And on the 1st of November there was a northern light visible from Poland. Even with very huge explosions, the northern lights are even visible in Mexico or Greece. The color of the sun depends on the temperature. Our sun is around 6,000 degrees, so the maximum of radiation is around the yellowish color. If it were cooler, then the maximum radiation would be somewhere around red or even infrared, so we would see the sun as a red star. And if it were hotter, then the maximum radiation would be around the ultraviolet range, so the sun would be seen as blue. And depending on the sun, the color of the sun, the plants and animals would react. The sky would not be blue, the grass would not be green, they would take on different colors. And you can see on a night's weather night, you can see that different stars are of different colors. Some are orange, for example Lyra is blue. Exceptional phenomena connected with the sun's activity are the northern lights. For example, there are beautiful curtains hundreds of kilometers long. They have beautiful colors and shapes. The color of the northern light depends on what element was activated, and depending whether it was oxygen or nitrogen. And it's not true that they're only visible at the poles. Sometimes even in Poland or closer to the equator, with big flares on the sun, they can be observed. Other significant phenomena are annular or total sun eclipses. The moon is 400 closer to the Earth than the sun, although it's 400 times smaller, but because of the distance difference, sometimes it can cover the sun completely. But remember that the moon's orbit is also elliptic, so sometimes it's closer or further from the Earth. When it's further, it won't cover the whole sun, and it will leave a ring, which is called an annular eclipse. But the partial eclipse is the most commonly observed phenomenon, where only part of the sun's disk is covered. This is a video from Chile from the last total eclipse. You will see in a minute that the moon will cover the sun completely. It's going to get darker. There will be lighter objects visible in the sky. The temperature might even drop by 15 degrees Celsius within a few minutes. Animals think it's night and they go to sleep, and after a few minutes everything goes back to normal. Poland's location on the map is quite strange, and the next total eclipse will be visible in Poland in 2135, so a long wait, but earlier in 2026 a total eclipse will be visible from Spain. Another phenomenon is the rainbow, so the spectrum. The white light is a mixture of colors. It can be dispersed by a drop of water, creating a rainbow. With good conditions, even two rainbows could be created with reverse order of colors. And this, the spectrum, is, so to say, a footprint of the sun. If you take the spectrum and represent it as this rainbow, so to say, you will see these black spots, and these black spots are particular elements. So if you can disperse the light and you can get this rainbow representation, spectrum representation, you can look into the composition in terms of elements of the sun or a different star. So you don't have to go to the planet or star to pick up the elements that are there to see what it's built from. You can do it this way. One of such elements was discovered in this way, that is helium, called in honor of Helios, the god. Such equipment has been applied as a way to look at planets that brush the sun. This is the ISO. It was called the comet of the century, and everybody thought it would be visible even at daytime after brushing the sun. But unfortunately, after a few days, it disappeared completely, and even the Hubble telescope couldn't see it. Our sun is currently in the midst of its cycle. It is going to grow bigger and bigger until it becomes a red giant. It will then devour the Earth, Mercury, Venus. Oceans will evaporate, rocks will melt down, and we will have to look for a different place to live in the space. The first one might be Mars, and then we'll have to look in different places, or even in different galaxies possibly, but that will happen in some 5 billion years. The sun will grow significantly, but the core will step by step be crushed to becoming ever smaller until it becomes a ball called white dwarf, the size of the Earth more or less. It will cool down, become darker and cooler. But if you went to a white dwarf and spoon up some matter from the white dwarf, that spoonful would weigh around a ton. That's how dense that structure is. This is the future that awaits our sun. I hope that this short presentation has explained to you the most basic phenomena concerning our sun. I encourage you to safely observe the sun, that is using special filters. That's very important, and you are kindly encouraged to join us in Niepołomice at the Youth Observatory, and maybe next year we can meet again at European Rover Challenge 2021 at the 7th edition. Thank you very much for your attention. Well, I used this Mindstorms, the very well-known set of blocks. I used it to build this small robot with caterpillars. First I did it virtually, and now I did a real one. I hope this is visible. I prepared interface, velocity, stop, start, forward, backward, and other readouts for velocity, speed. Let me start it now. It has 2-3 seconds of time lag because I haven't had time to perfect it. There we go, there it is, and the blue field. Let's speed up. There's a slight time lag. There we go. Now it's going to go forever. That's what he talked about, exactly. No, yes, we managed to turn it around. Now what I'm going to do is attach a robotic arm to it in the future, so it can carry out different tasks. And I can tell her, okay, pour some tea to Piglet, I know, being inspired by Winnie the Pooh, and then it can first recognize where the piglet is, and then pour tea if I have the arm installed. And remember that hardware is hardware, but the software is something you can't do anything without. Space education for children. Is it possible? Let's talk about it. Hi, Piotr Słodowiec. We've started this global project for space education since March. And both online and live. We prepared Martian rovers built by children and by teenagers. They're controlled with a very simple pilot, remote control. But also it's an opportunity to teach coding, programming, because the next series of blogs is Lego education with the logic icons. So we are to decide what the icon means and how that impacts the rover's behavior. Where's forward? Where's the back? Are we trying to go backwards? Where's the rear? That's a small fan of space, robotics. Oh, this is forward, right? I'll go backward. This rover is a bit shy, it tries to hide. The grass is rather tall, so it's difficult to move around. Oh, it's blocked. Oh no, there it comes. Woo! There you go. Oh, it can even jump. Now we're upside down. What do I do now? I have to change. Oh, there you go. Normal control again. Did it program those flips? No, I'm blocked in the grass. But maybe we can build a mower from Lego blocks. What is the reach of such a remote control? Well, a few meters without visual... when you lose sight of the rover. But there are even better solutions with higher reach. This one is radio based. Let's go to the studio. As you can see, space education for children is a fact. If you're interested, where do you go? Probably to the website. Kraina Twórczości is what we are called, and there's a number of courses where you can have a look at them, find something that interests you. I'm sure that we'll stay here till the end of the event. Let's move on. I found a printing house. Is this the famous printer that prints money? Seriously, what is this about? Is this 3D printing?
You can put off your masks, you're safe. We have signed all papers, everything is fine. So what are you printing? What do you want to show to the people? Mainly we show to the people what is how it works, such a 3D printer. And we also inform them they are quite affordable. People think that they cost 1,000 zlotys, and we say, and that costs 700, and they can't believe it can be so cheap. Many people get interested in the purchase of such a printer. This 3D printer is higher. Do you know that company? This is a delta shape. But it has one advantage. Here I can see you have rectangular square tables, and we have diameter, and we have problem with all rims of the object. Here is about 25 centimeters precisely, so then it's in the second one it's only 15, so that counts. Yes, the precision is also something which is really important, because okay, but do you have any other communication rather than this stand? The members of our circle we are just forming as a circle, so we start the communication of this 3D printing possibilities. Okay, you've printed Yoda Master, the Easter's islands, some movable element. What is that? Yes, the material got expanded, but it's more than just demonstration. Yes, we are prototyping new device. We create shields and covers for electronic equipment. Do you think that we will have 3D printers at home, so we will just pay for projects, for designs, and we will print things? That's already our reality, to be honest, because 3D printers become more and more popular. There are many manuals available in the internet. Quite recently I've seen some hanger for clothes shaped as parrot's beam, and it appeared that it cost $2. This file she sent it to me, and she has this hanger of her dreams. So now we are printing the elements of our scenography. That Czarek is preparing that for us. But once again, you can see how it looks like with your own eyes.
Może wszystkie. Naturally.
And back to studio, Kamil Muzyka with me. Once again, we will tackle this space-related topics today, maybe less about space, more about the future. Transhumanism. I won't say what is that, you will explain it as an expert, but we are expecting the premiere of Cyberpunk, so everything, this cyberpunk, I'm not talking about the game itself, but about this genre in science fiction. It is strictly linked to transhumanism. So I encourage you to comment on our discussion and we'll try to respond to all questions. You have a lot to do with transhumanism. You are very active in the Association of Transhumanism, and whenever I can see anything, any post about transhumanism, you are there. So what is that? This is an idea which is as a tree. It has many trunks, many roots, because there's no one root. This is you have the trunk of the tree, which has many roots: mythology, science, philosophy, and many arms of the tree, and people differently react to different things. Generally, we treat it as the idea of resolving human problems, cognitive, scientific, or problems of humanity, including the whole ecosystem, by means of technology, of science, and some technologies, genetic engineering, nanotechnology, and great issue of AI and IT. So in the public discourse, we deal a lot with robots, AI, and the interface robots and person. Do you think that transhumanism was in the public awareness as a mainstream idea? Because I think that it is something that people cannot express. If they were to refer to transhumanism, they don't know the concept, they don't know the word. Yeah, many people don't know this concept, this term, and they don't know how to tackle the issue. That used to be a domain of quite complex philosophical discussions. What is a living organism? Or where is the boundary between living creature and robot? So well, I confused that, but you know what I mean. I was talking about this boundary. So these discussions very often omitted people until you will watch Years and Years series. I'm not talking about Black Mirror yet. Is it something? I think it was created about 2 years ago. This is a mini series that shows a history from 2021 to the not distant future, and you have a hero, a girl, Elizabeth or something like that, and she decided to be a transhumanist, and she didn't like her body, and her drama was the pursuit of becoming a cyborg, not from the perspective of science fiction as we see it in movies or in literature, but that was from the perspective of a family drama. He gets into trouble because they say, okay, we will make a cyborg out of you, and they replace her eye with something, some waste, some rubbish. We know it from the literature, from the science fiction, that this is a gray zone activity. People offer replacements of low quality which may do harm to your body functions. Some technologies, for example exoskeletons, some wheelchairs, some drugs or some kinds of therapies. Sometimes when I was attending my meeting with a doctor, of course it's an anecdote, but they said, and now you can heal your knee with stem cells, for example. It's not like it's stupid, it is not, but people are not interested generally. They can go to Zakopane, to the capital of mountains, you know, could see all these billboards advertising. I think that this is the center of transhumanism, because you have all these medical procedures which are advertised on these billboards. You have all kinds of clinics. I will go there for sure to convince myself to see it with my own eyes. Yes, you have a series of large billboards about aesthetic medicine, but also about some stem cells therapies. It's like a green zone. Maybe they are there, but I don't know if they will. Okay, I will not say that. Maybe that's great and highly efficient, we don't know, so we will not comment on that. But the fact is that, yeah, it is like that. It seems rather funny because it's a reality that we know from science fiction. And if somebody wants to do something like your hero, so shape the reality when it's too early, it is funny for us, it seems funny. But we have people who are active in the association of transhumanism, who have different chips implanted, for example, how it looks like. Usually in Poland, these are air-fit implants, and they use as if you had payment method or business card or keys to your car. This is some kind of improvement, some facility that you can use. But for example, if you have your chip here, you cannot fight with a sword, for example, because you can destroy your chip if you push too hard in that very place. The same with exercising at the gym. So, and it has to be here? No, here it's good because you have the skin which is quite thin and it's quite easy. Of course, there are biohackers who involve in hacking such devices, not only from genetic side or medicine side. And we have Herbison, who has the so-called device implanted. This is a special sensor processing colors into sounds, because he is suffering from a hard form of color blindness. So he listens to colors rather than watching them and distinguishing them. So this is something that helps him orientate himself in the world of art. As far as I know, at the beginning he could hear the colors, but then he stopped thinking about it, because his mind is transmitting that signal in a totally different way. So his brain has adapted and reads these colors through sounds. It's like you can train person to different things. For example, for medical rescue, for robotics, software development, programming. This is something which was not known by our ancestors. They were not sitting and typing on the rocks, or they didn't assemble any kind of weapon from pieces of wood And it's the same with us. We function in a totally different manner, other than in the previous generations. We have to adapt to totally different conditions. So this function of the brain gives us hope for the future, when we will have to deal with all these technologies with which we will connect as human beings. But where we are now, because I'm under the impression that these are more philosophical discussions, some starting point, because it is not there yet, the technology. I've been watching the conferences with Elon Musk. Everything is fine. His vision is great, but I'm under impression that I can see some implant which is advanced, but we have implanted chips for many years to people from epilepsy, for example, to stop their attacks. Yes, of course, it's in place. This is the rule of being human. If we were granted human rights once, we will be treated as a human being forever, no matter of all the changes and transformation. And there's also the rule of absorption. Maybe it's not 100% correct. My colleague, sociologist, he explained it to me. Anthropologically, we absorb certain concepts. As you can remember, a person with an artificial arm a few years ago would be called a cyborg machine, and now there is a girl with artificial arm. She has to plug it in order to charge it. She has some sets of artificial arms, so she had to do some washing of it to prepare it. These people live among us. We don't call them transhumanist or transhuman. We call them people. Generally, it's the same with people suffering from depression. Their level of awareness is adjusted with a set of drugs, or for example ADD people or people with pacemaker. There are plans to have a special VCI or implant. These are some ways how to adjust a person, how to correct him. We had an old science fiction writer from the communist era, and he was wondering who is more of a cyborg, the one who operates the society, or the one who has some artificial parts inside. Definition of a cyborg is a man with some mechanical parts supporting his living functions. Yes, we have these elements, this mechanism, helonic mechanisms. What does it mean? It means that this is an inorganic materia, not living materia. So this is a technology, a mechanism which is rigid, which is stiff. These are some frameworks, metal frameworks. And quite recently, National Geographic showed this soft robotics. There are two dimensions of robots rather than the stiff robots, and the more and more of this soft manner of robotics, soft version of robotics is applied. People are thinking maybe it would be better to use some soft robotics for servicing satellites, because that would be more efficient than, for example, an arm which has its joints. So each part of our body will become a part of the sun, so we will be in the space. Yes, we are limited by materia, and we will turn to dust at the end. So you said you will you are born from the dust and you will end up on the sun. Okay, my another question would be, we had a lot of different cyberpunk, especially in cyberpunk, whatever it was, Matrix or some Johnny Mnemonic or other Keanu Reeves series cyberpunk, which we are looking forward to get, Blade Runners. In the 80s especially, I think the cyberpunk was a popular trend which was supposed to show this dirty future. Now we have Wi-Fi instead of cables. It's not so bad, but people were a bit afraid of this future, of the fact that we will become lost in robots, that we will stop being human. But do we know what is human, in fact? Because there are many approaches, and on the borderlines there is some kind of friction. Putting aside if somebody is a woman or man, or feels a woman or man, now we have full possibilities to change sex. I can become a woman tomorrow, even if from psychological point of view I'm a man. I just have to find a doctor. So the technology allows us to change the paradigm, to change the definition of humanity. And what are we going to do about it? Yes, you are right. There used to be a discussion about the modified carbon before Netflix was founded. When I was reading that book, I thought, okay, what's an interesting concept, that I can change bodies, that I can use bodies which are not humanoid. And yes, we will do a lot of things with that concept. Question is, are we going to use our free will, and everyone will use its free will to the extent of their choice, or maybe we will give him some instructions that something is moral or immoral, something is an object and somebody is a person. But on the other hand, we can always, and it was in Charles Sheffield's books, in the only novel published in Kielce, which is very sad to me, that is the only novel of him. The side of proteins, they have a form control bureau, and they could use specific chambers to heal their wounds, to get younger, or to change their form. They could grow wings. So there was the form control bureau, and only stable forms were available to prevent people from doing harm to themselves, not to become a pulp or not to stop breathing. So there were some protective measures. The question is, are we willing to offer such competence to any office, to any official body? Of course, there might be an office which will be very efficient. You may do anything, but you cannot experiment with viruses and pandemic, because my body, my right, and so on. But how to redesign the society if such possibilities will be available? I think that these possibilities that we are going to have and that we have will lead to conflicts. Even now we have this clash between sexes and related to LGBT. There was an article which responded to a Transhumanist Party member that in the future we will repair people more than we repair pavements. And the answer was that repair your discriminative attitudes and pavements, and do not repair people. And this is so we have to remember that there are some people who want to go in a totally different direction, so they feel good in some kind of disability. There is Munchausen effect, that you can want to cut a limb, for example. BED, it was a unit, and we know it that if we would cut a limb of somebody, they have no phantom pains. So something which is normal after amputation. So brain is a mystery for all of us, and despite the fact that we take a lot of drugs, we have some chips implanted, we are a mystery and a question for ourselves. That's why we want to create robots which are as we are, in order to understand us. We want to simulate human brain in order to understand human beings. Okay, and in your opinion, how do you think, what will be our nearest future? What is more sensible? Isn't dead ends bionic improvements or genetic therapies that will improve what our broken parts? Because there are two legs, two pillars of this transhumanism. Yes, probably everything will depend on who you want to be, because we have Longevity Alliance, people who want to live as long as possible, who want to be immortal. They don't like implants and chips and uploads. They say that we need to find some epigenetic and other ways supporting us in overcoming death and a biological clock causing that our cells are reproducing and they are altering. But of course, there will be another fraction who would like to explore the mechanical part. I have to say that we cannot limit these people. We cannot limit and say, no, from now on we don't use any helicopters, because vertical takeoff is not needed anymore. Because we have fixed wing aircraft. Helicopter has a rotor on the top part and creates this movement of air, and this is the same. It's like you would say that motorbikers you cannot ride, because it's impossible to limit people. Or maybe if something is really harmful, but you have to prove it's harmful, because very often we take random decisions which are not well thought, which are based on some data without any confirmation. And what kind of what do you mean? I don't want to touch upon politics, but for example, in the environmental protection industry, we like new concepts too fast. If somebody meets some set of requirements, we market the product, but nobody takes into account that only one company meets the requirements, for example, and then new research is made, and it appears that all these factors didn't have as important effect as we thought before. It's like with freons. Now we are talking about planes more than freons. Of course, there are some mistakes and intentional mistakes made in research. Sometimes they lie. For example, popular car producers which tempered with their engine expertise. We will not talk about engine that exploded during some accident. For long we didn't know whether we can expect another ice age or global warming, because there were some scientific publishing houses publishing books about coming ice age, and but everything changes. For nuts fields until 2005 and 2006 we didn't know as much about astrofilters and cells. He knows his approach, his scientific approach, are from before these publications, so he jumped to some conclusions based to data which was not accurate. It is related to transhumanism, because the theory on life on asteroids was based on the fact that man is just an element, but the habitat, which has its artificial intelligence and other forms of life, and organisms from bacteria through plants to other, let's say, animals, they are supposed to create one single ecosystems with a human being. And when we observe how he described these habitats, he didn't take into account something important, that that the fact that asteroids get heated, that causes them to turn, and in the science fiction people stop mentioning this rotating asteroid as a habitat because of that. And even in the futurologists and in the space sciences, another important thing, until we discovered nanotechnology, the orbital transmitters that we know, which we have on these were space stations like ISS, but manned and with an astronaut changing switches and plugging in different wires, because that was the technology that was known to them. And then they thought, and maybe we would create nanotechnology. Before we had some Santa Claus's machines and other, and now we have 3D printers, and we print 3D items, so it's our reality. To respond to your questions, I'm more into convergence. In some point, in my opinion, robotics will be as advanced that it will imitate biology, and we will add up to that, because the behavior of organic materials and biological organisms will be reflected in materials that we hero technology now. So this will be intelligent materials, small robots like bacteria, like cyborg. It's like blood plates, and it's possible to heal a wound in a second. So we will use the mother nature and its richness.
Is humanity not a flexible notion with no specific meaning? Well, to a certain extent that's true. That is, we don't like defining humanity through what our cognitive capabilities are, or physically what that means, because we know what that led to in the past. Of course, we have mapped the human genome, we have certain assumptions, but we try and not to stress them so much. Do you remember gender intersexuality? Now things have changed. We respect those people. Of course, it's a per male of the population, but we need to bear them in mind. Remember that they are not strange creatures. It's just what happens from time to time in biology. You cannot tell them, say that they are not human, not a woman, not a man. So there's this cultural aspect. We want to take away someone's humanity from them, sometimes by saying you're a dog, you're like cattle, etc. On the other hand, we don't want to define humanity so well. People tend to say, okay, at least, at the worst case scenario, the elderly will die. No, that's not okay. This is why we have social distancing and all these restrictions. So a lot depends on the situation and the cultural context. Picking up on this, can we say that transhumanism is left-wing or right-wing, or does it have no application? Sometimes I hear people say, transhumanists or leftists, or they are fascists. So is there any room for this kind of approach, or is it such a complex issue that can we really find an extremely right-wing transhumanist? Or this Analog's a Polish skinhead punk band about the independent ghetto imploding. Like in that song, it's, there's no single point of view. There's this Iranian transhumanist philosopher who talked about upwingers instead of left or right wingers. So the upwingers, as he called them, those that look to the sky, upwards, into the future, and all the rest as a relative. Let me pick up on Ken MacLeod, who wrote this anarchist fantasy that made fun of transhumanism, making them, picturing them as this kind of Greenpeace-like organization, this kind of eco-terrorism. He said, my goal, my aim are the stars. I don't care about communism and capitalism. Of course, you can apply different kinds of approach. Libertarianism, where freedom from the state, freedom from anybody telling you what you should be doing with your body, your energy, your home, what you can do. This cult of mobile homes is part of that. On the other hand, there's the socialist approach, saying, okay, libertarianism is one thing, but on the other hand, you can't have these social disparities with everything being owned by the rich and others just eating garbage. Do we want to go towards a utopia, or is where we were headed a new dystopia with a huge, the following the model of a huge corporation bringing fruits to the society and provided by robots who do not have to think? We have this AI with them, the AI being a partner, and lower level, less developed robots being those that carry out the difficult work. Humanity is something that changes. The commentary says we are not the final stage of evolution, we are just one of the steps on its way. Yes, that's true, we're going to see some branching out. This is one of my favorite strands in sci-fi, where on different paths where evolution forks out, you get different races, different cultures, and the motive of transhuman aliens, as it's called, this motive in some novels where these aliens are not aliens at all, they have integrated with the humanity, and they have go through, like in the Hyperion, in order to walk on the surface of the Earth, they would require exoskeletons because there is too much gravity. I'm wondering how far we can go away from the hominids. Well, depending on what time frame you adopt. It's not overnight, because that's not how biology works. We're not insects. But adding to that, you know, we are ever more advanced in bypassing biology. So at one point we might reach a stage at which technology and biology will allow for transforming the whole race, like in Sheffield's box. But remember that our form, our shape is a result of so many mutations that were bad for us in the past. There were mutations that were positive, gave us an edge, and others were bad, and they were eliminated. And some were bad, but not bad enough to be eliminated. If the brain is a machine and it's based on nervous connections, could we stimulate it to learn it like in the Matrix, teach it like in the Matrix, for example, like Neo learns martial arts? Well, saying that the brain is a machine is Cartesian on the one hand, but not only that, that's also a motive from science fiction literature, like Neumann. A machine that passes on genetic information to the next generation. There was a lot of talk about the brain being a machine, but as far as we know, it's not so easy when it comes to the brain, because neurons are there, right, but they're not the only transmitter, because cells can communicate directly with one another, as said by Douglas Phillips. We have to map everything to be able to upload data into the brain. I'm sure that the first experiments will be failures, and they'll include errors, and only when we understand where these errors come from is when we can use that as a man's backup. All that is fine, but it's still the continuation of Transcendence, a film with Johnny Depp. If we can download and record what our brain contains, is it like me waking up somewhere else, like, you know, like going from one room to another? Well, that depends, because if you're cut off from your senses and somebody did not think everything through, then suddenly you might feel bad. You might have problems with keeping balance. You will have hormonal problems, because that's based on gathering signals from the whole body. So this is a question about what we are. There's no answer to this question yet as of today. How do I know that that guy in the other body is me? A copy that has just memories. It's not me anymore, maybe. Right, it's like, you know, if you had a cyborg that you piece by piece put things into, and it becomes a machine finally, then you can say, okay, it's a human being, but it went through a certain transformation. You might say that there is no memory, it doesn't feel a human being anymore, it's a robot, it's a machine, but this is not a one-to-one transfer, it's not exact mapping, it's not a one-to-one copy. It's not like copying an MP3 file. I'm sure that there's going to be a lot of open source, Pirate Base. You can copy Johnny Depp, There was one book about this. I'm loved by Julia Roberts. I don't remember the name of the author, a Russian author, if I'm not mistaken. So that's not me anymore. That's my copy. So it's like saying, okay, there's a continuum of my plans, concepts, my thoughts, but I won't see them. It's not me anymore. That's the question. Is that still you? If the emulation wakes up. Like, you remember your memories, but you're an emulation. That's a question. Artificial memories, that's another topic. The question is, if you go to sleep and you wake up then the next day, are you still you, or do you just have the memories of your version from the previous day? Right, that's a good question. That's looked into by philosophers and cognitivists. You know, mind is an abstract term. Brain is biological, while mind is rather philosophic. If you looked at most debates about AI, is not about whether the robot has the right to do this or that. Rather, it's a discussion about who's responsible if a robot kills you. Or does the robot have the right to run over you because it has an important parcel to deliver? Like in the case of an accident where, you know, witnesses are asked why somebody was run over. I remember guys, hooligans from my youth, who were throwing stones at cars. So why don't they, you know, run in front of a car that is driven by a machine to see what it does, whether it'll turn over and whether it will crash, you know, because this is the same type of mentality. What would stop those hooligans from doing that, you know? So it works both ways. Right, so the discussion is about who's more important, the passengers inside the car or the person who might be run over. So if you sit in the car, you have to factor in the possibility that you might have an accident, and the person that's walker by does not factor that in. That's why it's important for machines to have, you know, automatic drivers, to have an image from above the car, because if there's a truck going in front of the car driven by a robot with some heavy material and it falls off the truck, then that's very dangerous, and the robot must have the possibility to notice that. I've had this kind of situation on the road, you know. At the end of the day, it did not fall out, but I was really afraid, I was really scared. It's a question of the point of view about what humanity is. I wouldn't have a problem with accepting synthetic forms of life if provided they were intelligent and they could adapt to a social life. The question is what that society is. Some would like to uplift the development of some species like chimpanzees, elephants and others so that they can communicate with humans. But then the problem is that they have to adapt to the society, and society has to adapt to them. I remember one of my articles that was not published. They didn't want to publish. It was about the rights of dolphins. It was after India deciding that they should not be kept in zoos, because it was about, you know, the term was non-human persons. I said, okay, dolphins, everybody knows dolphins. You know, I don't know if children are watching us. I think we can talk about the nature, but dolphins are very well known to hunt, you know, apply persistent hunting to other animals. They are sexually aggressive. They play with different weaker species. I've seen dogs, you know, having fun with other smaller animals, you know, torturing them to death. Yes, right. That's it. That's what I'm talking about. And the question is whether we are free to intervene in their social activity. Do we really want to make them another, you know, synthetically create another intelligent species? And then wonder about their social adaptation? Why to create this kind of problems? Well, yes, there's this school of transhumanism that is not taken seriously anymore, but it talks about non-human personal rights. It's about protecting their rights instead of having them, you know, starting bank accounts or taking out loans. That's absurd. Yes, well then you could trick such a dolphin into, you know, some tricky business to get their money from their bank account because they don't know many social behaviors in humans, right? That's what happens with people who have limited capacities of, you know, making their own decisions, financial decisions, and they're sometimes abused by others. So this might happen in such situations. So that's like, you know, a robot being, you know, have legal capacities, financial capacities. You know, can you imagine a payday loans representative, you know, going to a dolphin every week? Humanity is defined differently depending on which direction our technology and knowledge growth goes, you know, and it changes as we evolve in terms of our knowledge. Right, that's very true. Even as a result of some huge disaster, we would not go back to the stone era, even if there's some apocalyptic event, because it's really difficult to eradicate completely human knowledge, especially since we have so many copies of all that. Sure, at the same time, we should have other media like stone tablets, for example, or glass, to encrypt many layers of information, and it's very durable. I once talked about why Egypt's knowledge has not survived. Well, that's because all the media that information was written on was biological and biodegradable and ecological. Right, the discussion about transhumanism is a very long one. What do you think? Might there be a war between those that are proponents of transhumanism, those that want to perfect their bodies? Are there going to be these temples of human body purity? Well, there might be conflicts, you know, but it might be those progressives fighting against, you know, like it's the Spanish War, the fascists approaching. We have to defend, and there is somebody who wrote something, and we are these. Let's denounce those. So you think that it's more of an internal war, a conflict, rather than a big war internationally. Right, yes, there are different approaches to all kinds of issues, and these different approaches radicalize with time, and the more different environments have of common ground, the more they're going to compete for the same niche. Sure, definitely there will be a competition in churches and religions, but also new religions will be formed because there are already many Protestant groups, and the Catholic Church is changing and evolving. Definitely there will be Orthodox fractions like Cyber Pope, like in Trinity Blood with vampires and cyborgs. Anime, let's not talk about that, but that's an interesting source of transhumanist solutions. If there's anything, if you're looking for ideas for humanist ideas, I recommend anime because that's a very strong topic in anime. Tomek says that people will control the evolution as long as they control it, and then attention will be paid that the systems that not change too much. It's like in Orwell's novel where there's the top of the party, keep control of the group, of the system. Like there's this in Figem, the medicine, the longevity substance is limited to the most the top of the elite, and others rebel against that because they're convinced that it should be owned by the whole of humanity. This is an interesting vision by this Polish author. It's worth reading really because it's really well thought through, and it presents all kinds of down-to-earth human issues, and it shows all kinds of complex issues and problems. If we live in homes that are not mobile, we have to live in mobile homes, then what kind of contact do we have with each other? You don't have to talk to your aunt who has a bad day. You don't have to talk to your grandpa and grandma.
You have everything. You don't have to do this. Yeah, but that is how this human relationship will be less complex. We are social organisms, so it will be really difficult. Let's see the problem of loneliness, for example. I thought everyone went in their own direction. Okay. I had a question at the back of my head, but let's read the comments from the public. I wouldn't be so sure if it's the religion of the future, because we are they tell we'll be in heaven, and who would like to resign from such a great thing? And what if this class of governors could decide that somebody cannot die, somebody can choose if they want to die or not? That would require the revolution of the whole society. Our society, no matter how bad it sounds, it is designed for 50, 40 years. And now we have the problem with aldering generation, of aldering society. There is problem of loneliness of the elderly, other challenges because we live longer. But law, all aspects of life, economy, everything is designed taking into account replacement of generations. So would it be possible to form such a society if we had an access to such a therapy or drug that would offer us immortality? Well, yes, we have possibilities, we have different models. The only thing is to implement them. But if we start to quarrel, some people say, oh, no, 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 we don't agree, we will not resign from the power, and it's a gerontocration, that okay boomer phrase, all generations used it. It was okay boomer. There will be the eternal boomer. Kamil, thank you very much for your presence and for this interview. We cast some light on this transhumanism, because I think this is a very interesting subject, and we will go back to that on our Astrophaza channel. And now let me invite you to the talk with Pete Warden. We will talk about a breakthrough initiative which is going outside of our solar system. It's my favorite thing of the light tale. Yes, this is something we're going to talk about with a legend of engineering, of projects. He supervised the greatest projects that you ever heard of. We will have this interview in a minute.
Świętokrzyskie. Naturally.
Okay, so right now we will talk with the chairman of Breakthrough Prize Foundation. I have a couple of questions for you, and a couple of them are about the breakthrough initiatives, because you are the chairman of Breakthrough Prize, which is the prize alongside this project. And what is breakthrough initiatives? If you could just spotlight us the topic.
Well, in about 2013, I was the director of NASA's Ames Research Center. One of the local high net worth people, Yuri Milner, a physicist by background, came to see me, and we had already worked with him because they do the breakthrough prizes on the campus of NASA Ames, but he was very interested in starting a set of initiatives to look for life in the universe. And it turns out that's been my longest term dream, is to really study life. So in early 2015, he said he was willing to put quite a little bit of money into it. As it turns out, several $100 million US so far. And so I left NASA to run the Breakthrough Prize Foundation, specifically the Breakthrough Initiatives. We currently have 3 initiatives, and we're thinking of a 4th one. We announced the first one on July 20th, 2015. It was a effort to revitalize our search for extraterrestrial intelligence. We're looking for what are called techno-signatures. If there's evidence of somebody trying to communicate either directly or indirectly, or even seeing remnants of an alien civilization. We announced that initiative on the 20th of July 2015. It was the anniversary of Apollo. We did it in London, UK. Stephen Hawking was there. It was our principal science advisor until he died about a year and a half ago. A year later, we announced our second major initiative, which was, we called that first one Breakthrough Listen, because we're trying to listen for signals. The second one we called Breakthrough Starshot. And to me, it's very exciting because it's something I've always wanted to do. Is we think the technology might be maturing that we could actually send probes at some significant fraction of the speed of light, like 20%. And with that speed, we could fly by some of the nearby star systems, and we hope to find a life-bearing planet. The third one, of course, is to figure out where we go. And we started that one also in 2016. It was called Breakthrough Watch. And the idea was to find hopefully a life-bearing exoplanet, a planet orbiting a nearby star, that we could send these probes to. The fourth one we are considering right now, and I think we'll probably do something. We haven't named it yet, but we're thinking of doing a private probe somewhere in our solar system, and we've looked at two places in particular to look for life. The first one is one of the moons of Jupiter, Europa, which has an ocean. It's covered by ice, but the ice cracks and there's water plumes that are ejected into space, and we'd like to go sample those. The second one, surprisingly, is Earth's evil twin, Venus. Venus has always been thought to be not a good place for life because it's so hot. The surface of it is like 500 degrees centigrade. However, there's a layer in the atmosphere at about 50 kilometers above the surface that is very interesting. It's about the same temperature and pressure the Earth is, although it's in the middle of almost pure sulfuric acid clouds. But there's evidence. In fact, in a couple weeks, stay tuned, you'll hear an announcement of some very good, interesting evidence that there could be life in those locations. So we're starting to look at a potential mission. So those are the major initiatives that we've begun, and again, they're all about the search for life. I think the fundamental question, is there life elsewhere? Is it in our solar system or a nearby solar system? Can we find evidence of it? And, is there evidence of an intelligent species anywhere other than the Earth? And then finally, can we send probes to these nearby stars? And we're hoping to find a planet orbiting the nearest star system, Alpha Centauri. There's actually 3 stars there. We do know there's an Earth-sized planet in what we call the habitable zone, which means there's the temperature is right on the surface to have liquid water, orbiting the small star. The small star is about 1/10 the size of the sun, called Proxima Centauri. But we also have a result coming out pretty soon, which suggests there could be some planets orbiting. There's 2 stars like the sun that orbit each other, Alpha Centauri A and B, that one of them may have a planet as well. So lots of exciting results. We're quite excited about our work.
Okay, so let's stop a little bit at Breakthrough Listen. How does it differ from SETI program that we have a couple of decades right now?
We're continuing the SETI effort, and there have been a couple programs that were, again, they used to be funded by the U.S. government until the 1990s, but they've been privately funded. The 2 major efforts are the University of California at Berkeley. The astronomy department has had a program for a long time, including SETI at Home, which is an ability to kind of download a kind of a search algorithm on your own computer. The other one is the SETI Institute. Both of them are here in Silicon Valley. Both privately funded, but we've been working more closely with Berkeley, but we've also been working closely with the SETI Institute. Indeed, the researcher at Berkeley that Professor Andrew Sibian now leads both our effort, Breakthrough Listen, and the SETI Institute's search for extraterrestrial intelligence. We're seeing a lot of new efforts coming, some publicly funded, some privately funded. We're working, among others, with the Chinese. The Chinese have just finished the world's largest radio telescope. It's the 500-meter array FAST, it's called, in China. In fact, we have some time on it here in a couple months that do our first SETI searches. Interestingly enough, it's the first radio telescope big enough that if there was a planet like Earth orbiting the nearest star system, we might be able to see what is called leakage. This is a signal like your television. And, it turns out that we just now have the technology to see that. So that's a very exciting effort. We have time on most of the world's large radio telescopes. We intend to look at the million nearest stars to see if anybody's deliberately trying to signal us, and particularly focus on the nearest ones to see if we can find an accidental signal. That maybe it's called a technosignature. We're also starting to look at different, not just radio spectrum, but also the optical spectrum. Increasingly, as we all know, we're using lasers to communicate, and so we're looking for laser signals, and that's an exciting effort. We just started that one, but we're also looking for other kinds of things that are called artifacts, and the idea is maybe there was a civilization millions of years ago around a nearby star system, but it's no longer there. It's they've left or done something else or failed, but they may have ended up building some giant noticeable change to that star system. A few years ago, there was one that they got very exciting. That there was a star system discovered by the Kepler mission. This is a mission that I actually oversaw at NASA Ames to look for planets. And it looked for planets by watching if you saw the shadow of a planet pass in front of a star. And it found, over 5,000 planets. But one of them had a very interesting, it showed that about every 2 years there was a deep decrease in the light of the star that was not the kind of thing you would have seen from a planet. And so one of the ideas was that it was the remnants of a really old civilization that had built what are called megastructures. They'd actually built structures all the way around the star, and we were seeing sort of as that went in front of the star. The star was designated Tabby star after Tabitha Boyajian, a scientist at Yale, who discovered it. And we now are pretty sure that wasn't aliens, but it's dust or something. But that's an artifact. There are others that think that there may even be alien probes that are sent to our solar system. About 2 years ago, the first interstellar visitor was detected. It was an asteroid that was called Oumuamua, which is ancient Hawaiian for distant visitor, and it was our first confirmed interstellar visitor. But it behaved very strangely. As it left the solar system, it started to accelerate slightly. And now we see asteroids do that every so often, but that's usually due to their comets, that they eject gas and it causes them to speed up slightly. And but we didn't see any evidence of any gas or dust around this one. The chairman of our Breakthrough Starshot group was Professor Avi Loeb at Harvard, suggested that this behaved more like the kind of laser-driven probes that we are interested in. This is how we're intending to go interstellar, is that we would use a very powerful laser beam to push a light sail. And so the idea was maybe this was a light sail. And he published that. Now, most people think not, but we still haven't proven. So there are also people that think there could be, probes that are lurking near the Earth, and we should start looking at. There are small rocks and things that you see that for a few years they actually act like a moon of the Earth. And some people think these are alien probes. So we're this is a very interesting question of life in the universe. But I need to underscore: so far we haven't found anything.
Yeah, but the search goes on, and we have something like Each month we have an article in our internet, in Polish internet, that Oumuamua is a comet, is a asteroid, is a starship of aliens. So it changes each month, if you look at the articles.
Well, I think it's very unlikely that that's an alien probe, but it's not completely impossible. And but we're now seeing a number of these interstellar objects. Most of them actually behave pretty normally. In fact, a couple of them have turned out to be comets. But it's an exciting area. Of course, we think if we actually saw evidence of an alien intelligence, that may be the most significant science discovery of all time.
Okay, so let's move to Breakthrough Prize, because you are chairman of this foundation. What is the goal of Breakthrough Prize? What do you do?
Well, our founder was, as I said, Yuri Milner, a high net worth Silicon Valley investor. And as I noted, he was a physicist by background. He was studying for his PhD in physics, but then decided to go into finance. Did quite successfully at it. He was concerned that he looked at list of the that you find on the internet of who are the most admired people on the planet. There are movie stars, there are politicians, there are entrepreneurs, sports heroes, and so forth. But very few of these lists have any scientist on them. Maybe Einstein is on the list, or Stephen Hawking. But he said, look, what made he and his colleagues in both Silicon Valley and around the world wealthy was new technology, new science. And a lot of those discoveries that we base the internet on and sort of medical technology are a century old. And he was concerned that how do we inspire young people to study sciences, to study life sciences, to study physics, to study mathematics, the basis of all science. And he said, well, what he and some of his colleagues could do was to sort of make movie stars out of scientists. And so he teamed up with a couple other high net worth people, including Mark Zuckerberg and Sergey Brin, the co-founder of Google, and Jack Ma, and now Pony Ma, the founder of Alibaba and Tencent in China. And we decided to give the world's largest prizes. And but they're $3 million a prize, so it's about 3 times the size of that Swedish prize I'm not supposed to mention. And but it's the one thing we do differently than that prize is that we have an annual event, which we call the Oscars of Science, actually. And we have a lot of movie stars and other well-known people there, but we make stars of the scientist, and it's broadcast every fall. Although this year we're postponing it because of the COVID. Mm-hmm. It'll be, I think, held in March now. But there are 5 prizes in life sciences. There's 1 in physics and 1 in mathematics, and they're $3 million each. In addition, we give early career prizes in physics and mathematics. They're called the New Horizons Prize. But maybe the one that's most exciting to me is the Breakthrough Junior Challenge. And this is aimed specifically at the young people we want to inspire. We ask young people to do a 15 or a 3-minute video of a basic principle in science or math, and I think this year we had almost 6,000 entries globally, and we then select the best one, and the winner is brought to the Breakthrough Prize ceremony. Plus, they end up getting a $250,000 scholarship to go any place on the planet they want to go for college. As for young people between the ages of 13 and 18. The school gets a major laboratory that we supply that goes to. And one of the things I find most exciting is the teacher that inspired the student gets a $50,000 check. And it's the only prize I know that actually rewards the person that might have been responsible for inspiring the student. A very exciting program. I think this will be our 6th year of doing that.
And do you recall some especially breakthrough, project that get the prize?
Well, there's quite a few. One of the key ones, we gave a prize, a special physics prize to the gravitational wave detection a few years ago. We also gave, I think it was last year, we gave the prize or a year and a half ago. We gave the prize to the team that discovered the or made the image of the first direct image of a black hole, or at least the material around a black hole. You can't see the black hole itself. As a physicist, I found those very, very exciting. I have to say the mathematics prizes are pretty significant. They're kind of hard to understand, but as an astrophysicist, I know math, but not in that much depth. But we gave some prizes to people that develop special new mathematics tools that can really revolutionize our ability to model systems, complicated systems, for example. The life sciences have been a lot of major discoveries, including treatments for among other things, brain tumors, discovering the sort of origin and cures for genetic diseases that affect a lot of people. I suspect that out of the COVID, when there's successful treatments, that maybe some of those people will get those prizes too.
So this is a real Oscars, as I think, because these are the things that make our lives better and move us on, in fact.
Yes, absolutely. And we broadcast the ceremony live. It's been broadcast by the National Geographic Channel the last few years. A very exciting ceremony. And how I got involved with Breakthrough was in 2011, Yuri Milner came to see us, and they were looking for a venue to do the ceremony. And they wanted to do it in Silicon Valley. And of course, NASA Ames is right in the center of Silicon Valley. And we have these 1930s airship hangars. They were airships the U.S. built then. And they thought that was a perfect place in one of those airship hangars to have the ceremony. So ever since then, we've had it. I was the head of NASA Ames, and so I got invited to the ceremony. You always invite the landlord if you're going to have a big party. And so I got to know Yuri and his colleagues really well. A very exciting ceremony. And I really, are going to miss it here in a couple months, but we'll restart them again in a few months later.
Mm-hmm. Okay, so let's change the subject a little bit. You were also a person that was involved in beginnings of CubeSats, as I know. The little satellites that do their work, and what do you think about this kind of technologies? Will they spread among the businesses, among the sciences and so on, and will produce our future better one, or what do you think about this kind of technology?
Well, CubeSats are already very mature, but when I arrived at NASA, now about 15 years ago, CubeSats were being done at a couple places. In fact, they had been developed by two professors, one at Stanford University right near Ames, and the other one at the California Polytechnic Institute on the central coast of California. And they were used as devices to train students. And but people were starting to look at them at NASA Ames and other places that maybe we could do real science with them. And so we had a program we started that actually is now launched about 15 or 20 science CubeSats. But in addition, we got very excited about it. It became a center of expertise. And a number of my employees, some of the younger ones, frankly, decided to do a startup. And there were several startups that came out of here, but one that's been particularly successful is the company called Planet. And these folks, the founders, were all working at NASA Ames. We allowed them to do a little bit of extra work on their own. And actually, in true Silicon Valley fashion, they built the first CubeSat in their garage. But their idea was to launch hundreds of these things that would have a small camera on board, but they could get an image of every place on the planet at least once a day, assuming it was clear. And they now are a big company, valued at well over $1 billion US. They have about 600-800 employees. They're based in both Europe and in the United States. And you can go online from Planet and buy an image from any place on the planet. So it's been a very valuable effort. So that's one really big success that came out of here. Another one that that the founder wasn't an employee of NASA, but was a good friend and moved to Silicon Valley to do that, was Spire. Spire is a company that now has launched several hundred small satellites that orbit the Earth, but they don't do imaging. They basically look at the global positioning system signal, and as the satellites orbit, the signal as it goes through the Earth's atmosphere changes depending on the temperature and pressure and water vapor. So they can take this data and figure out what the detailed weather is everywhere. And so they've got a global system where they got the world's best weather information and even prediction algorithms. They are also based. They're based here in Silicon Valley, but they've opened a major operation in Luxembourg, a country that I spend a lot of time in. And this is just two companies that have done really well. So we're seeing a huge increase. Now we see NASA beginning to look at CubeSats that we could send deeper into space. And there's going to be some going to the moon pretty soon. The key thing about a CubeSat is they're cheap. And, you know, one of the problems with space is that it took governments to do it. Well, now, you know, you and I and a couple friends could probably bring enough money together and build our own CubeSat and get it launched. Of course, the other major breakthrough is the ability to have a lot of launch vehicles that also done commercially. I mean, people like SpaceX and pretty soon Blue Origin and a few others can put CubeSats in space really, really cheaply. One of the things we did at Ames is we worked with a company called NanoRacks that set an arrangement with NASA that we could actually, you know, launch CubeSats from the International Space Station. And a lot of our first science missions were launched that way. The other exciting thing, of course, is I think the trend will continue. Our project Breakthrough Starshot to send an interstellar probe is we need to have a satellite that doesn't weigh kilograms, it weighs grams. And so we're beginning to build what are called chipsats. And a few grams, we launched the first ones the last couple of years. And, you know, initially they don't do very much. They're just, you know, communicate. But we think ultimately that we're going to see a revolution again. That, you know, when I was a young guy a long time ago, satellites weighed thousands of kilograms, and now they weigh a few kilograms, and we think we can get them down another factor of 1,000 to a few grams. Very exciting trend, and it's going to enable lots of exciting things in space.
Okay, so you're also an enthusiast of near-Earth objects research, and why so, and what do we get from researching the asteroids that fly near the Earth?
Well, I got very excited about asteroids probably 30 years ago or so. I mean, I'm an old guy, so that maybe even 40 years ago. And, you know, when I was a graduate student at the University of Arizona in the 1970s, there was some papers that suggested that you know, the extinction of the dinosaurs was due to asteroids. There was an asteroid impact. And so I got very excited about asteroids. We actually had developed a new technique to image things through the atmosphere, so we looked at some asteroids. And so I had an abiding interest in asteroids. And there's really three things that got me excited about them. First, that asteroids are basically the leftover stuff that created the planets. So, you know, if you go study them, you can find out, you know, something about the formation of our solar system and the origin of life. Some of them have materials in them that we think were the basic building blocks of life. Second is that asteroids are actually dangerous. As I noted, that we think that the event that destroyed the dinosaurs happened 65 million years ago was caused by a major asteroid strike. And in fact, I like to quote Carl Sagan, who said that had the dinosaurs had a space program, they might still be with us because they could have, you know, perhaps seen this coming and done something about it. The third one, and this is got very exciting, is and it was again, some 20, 30 years ago, I got excited about this, is that asteroids are very accessible. I mean, there's some of them come closer than the moon does, and they're made of very interesting stuff. Some of them are pure metal. Others have ice and other volatiles. That these are the building blocks of a space industry, of our ability to expand into the solar system. So space resources got very exciting to me. When I was at NASA Ames, we started some programs on space resources. And at one point we had a postdoctoral fellow from the Grand Duchy of Luxembourg, and he liked to drink wine, and so did I. So he came to my office, and we had a glass of wine, and he suggested I come and visit Luxembourg, and said that they're interested in starting a space program. Of course, I said, Luxembourg, I think that's a small country that has low-cost gas and low-cost booze. And so he said, you're right, but it also, in the 1980s, got very interested in space. They founded the SES, which is one of the world's largest communications satellite companies. But anyhow, I visited and came back a couple times, and ended up meeting the Minister of Economy, who he and I became good friends, and he said, look, we want to start a space program. So we did 3 workshops, and he later became the Deputy Prime Minister, Etienne Schneider, and Luxembourg decided to start a space program around space resources. They put several hundred million euros into the initiative. And then a year after I retired, as they set up their program, they asked me to be on their advisory panel. So I've been helping Luxembourg since then. In fact, I spend half my time there. I've got an apartment in Luxembourg. But they have maybe 20 or 30 startups, about a third of them related to space resources. And we've gotten very excited about how space resources will enable us to not only travel in space. Indeed, one of the first products will be fuel for rockets and other things, but that ultimately we can build things in space. Indeed, Jeff Bezos, the founder of Blue Origin and the head of Amazon, and I think still the world's richest man, has been putting a lot of money into the idea that we want to build giant space settlements in orbit, and we'd have to use resources from the moon and from asteroids. So very exciting effort. I think it's the first $1 trillion industry that will come from space. Indeed, as Jeff says, he wants to move heavy industry off our planet so we can preserve the U.S. to keep it pristine, or the Earth to keep it pristine.
That's a good vision and a beautiful one. And speaking of private sector and that kind of companies like SpaceX, like Jeff Bezos' Blue Origin and NASA's Space Launch System, I would like to ask you about your opinion on this rocket, because there are voices that it's a little bit of waste of money if we have that kind of projects like a Starship of Elon Musk, if of course the Starship will be done and will fly. What is your opinion on SLS and the whole missions that involve using these rockets?
Well, one of the interesting challenges, of course, with a government is obviously governments encourage private industry, and so in the United States, both Blue Origin and SpaceX and other companies have been funded by the government to develop commercial launch capabilities, and indeed a robust industry there is very important. On the other hand, the government is always worried that if you depend 100% on private industry, then when you really need something, it might not be there. And companies can go out of business, or they can be sold to somebody else. So the U.S. government is always, as we started private launch industry, wants to preserve something that's more government-oriented. Now, to be sure, the people that do it are still, private industry, but they're under a government contract. So, somebody once said, look, we don't depend on private industry to operate to make aircraft carriers. We fund them and manage them and write contracts to do that. So one of the key things the U.S. seeks to do is, while we rely on the private launch vehicles, maybe for almost everything, we want to preserve the ability, if we need to, we have a government backup. And I think that's a very sensible approach, and we're seeing good progress there. And at the same time, by funding the government one, we develop new technology that can be transitioned to the private sector. I remember when I was at NASA Ames, we had developed a new thermal protection material for the government that enables probes to come back into the atmosphere and human missions as well. It turned out that was the ideal material, so we transitioned that to Elon Musk and SpaceX, and that's what they use now for their Dragon capsules. So this was one of the key things, I think, that people don't understand how much these things help one another and how they're really necessary to have both, government systems and private systems.
Do you think in SLS there are still some breakthrough technologies that private sector can take in and use in their projects?
Yes, I mean, one of the good examples is they developed a special way to weld the tanks called friction stir welding. It's just beginning now to be transitioned to private companies that are beginning to use it for other kinds of rockets. I know of a couple that are using some of the technologies that they developed for that to build very low-cost, cheap, small launch vehicles. So that it's really an important effort, I think, to continue the government doing that.
Mm-hmm. Okay, so let's hope the space ride will go on and we'll all benefit from it. And just keep finger crossed for all Artemis program, because we all want to see people on the moon again. Thank you very much, Pete, and see you soon, I think.
Thank you so much. Thank you.
And ahead of us, the closing ceremony. Thank you, Pete Warden, that you've been with us. Thank you for this inspiring conversation. Ladies and gentlemen, great people whom you can meet thanks to European Rover Challenge 2020. Okay, this year it was a little bit more difficult because this remote version of the event was challenging, but we can see all the sponsors and partners, co-organizers and patrons of this event who contributed in order to make this idea live. So we used their know-how and their resources, and now we are waiting for the launch of the closing ceremony and prize award. Okay, let's start.
Lots of fun in our science and technological show zone, and lots of emotion with our Rover tournament. So first of all, I would like to welcome and thank you very much for all the co-organizers, partners, patrons, media patrons, and of course organizational team, tech team, judge team, volunteer team, and promotional team, without whom this edition won't be here. It was a harsh time to do it, but we did it, and it's fantastic. So we have today not only champions, the second place, third place, but also special award. So now let's find out which teams gained special awards from our judges. Okay, so the Best Planetary Map Award will be presented by the ERC judge Katarzyna Gajewska from Mars Society Poland.
Okay, so the award is going to Robocall from Colombia.
Colombia! Congratulations! Okay, so we've been in South America now. So let's go to the Best Science Planning Award, and that one will be presented by ERC judge, Dr. Krzysztof Walas from Poznań University of Technology.
And the Best Science Planning Award goes to DJS Antariksh, India. Congratulations.
Oh. Okay, so now we jump to Asia. Oh, so now the Best Scientist. The Best Scientist Award will be presented by a member of ERC Science Council, Professor Wiesław Trąbczyński from Kielce University of Technology.
METU Rover, Turkey.
Turkey. It's amazing. Thank you very much, Professor. Now the Best Analysis Team, and this award will be presented by the ERC judge and founder as well, Robert Lubański, the president of Mars Society Poland.
Rover over Czech Republic.
Czech Republic. That was very close. Okay, so we came to Europe right now. Okay, so let's see if we stay with Europe right now. The Best Dexterity Award will be presented by the ERC judge, Wojciech Głażewski from Mars Society Poland as well. Welcome, Wojciech.
And the Best Dexterity Award goes to Robotics, Scotland.
Scotland, United
UK.
Kingdom. Amazing. Amazing. Okay, so let's see where we go now. So which continent? Okay, so the Best Autonomy Navigation Award is a special award. We presented by founder of Leo Rover, Szymon Dzwończyk from Leo Rover, who also founded a special prize for that task.
Okay, so the Best Autonomy Award, wait a second, comes to Roverowa, Czech Republic.
Czech Republic.
Yeah, there you have it. And we as partners of ERC founded additional award for Roverova now, which is a Stereovision camera and Jetson Xavier NX mini computer, which will be shipped to you right after the competition and will help you in the next year autonomy, hopefully.
Congratulations, guys. Okay, so it's not only task on the field, it's not only autonomy and maintenance, etc., but it's also a presentation. It's a very hard task. So the Best Presentation Award will be presented by the ERC judge, Marcin Zgachiewicz, the president of Polish Space Professional Association.
And it is my pleasure to announce that the Best Presentation Award goes to AGH Space Systems.
Poland! Poland! Okay, so we came to Poland. Okay, so we also have a special award founded by our partner, long-term partner, MathWorks, for the best usage of MathWorks toolboxes. It will be presented by Mr. Konrad Kolski, a representative of ONT company, the official distributor of MathWorks in Poland. Okay. The most important thing.
Let's see who's the lucky winner. And the reward goes to SK Robotics.
Poland!
And the reward is Arduino engineering kit.
Okay, now the moment we all be waiting for the last couple of days, months, a year. These shiny things are waiting for the lucky winners, and yeah, let's see the third place. The third place of 6th edition of ERC will be presented by the president of Polish Space Agency, Mr. Michał Szaniawski, and the rector of Kielce University of Technology, Mr. Professor Zbigniew Koruba.
I think it's first time in the history. Third place award goes to ex aequo DJS Antarctic India
and Robocall Colombia.
Oh, that's amazing. Thank you. Well, wow, this is the first time 2 teams find out in the same place in the history of ERC. Congratulations, guys. Congratulations, India. Are you here? It's 4 p.m. You probably sleep, no? And I can see Colombia. Colombia from Bogota. Okay, congratulations, guys. So, okay, we will ship you this one, of course, by post. Yeah? Okay, so the second place of 6th edition of ERC will be presented by the Member of Parliament, Mr. Krzysztof Lipiec, the Marshal of Świętokrzyskie Region, Andrzej Będkowski, and Deputy President of Kielce, Ms. Bożena Szczypior.
The second place for ERC 2020 goes to
Czech Republic.
Rowerowa Czech Republic.
Czech Republic. Thank you very much. I can see smiling guys from Bogota. There will be a fiesta. No, it won't be if I have a quarantine still. Okay, so congratulations to vice champions. And now the moment we've been waiting for the whole ceremony. Let's find out who the winner is. The honor to announce the winners of 6 editions of ERC will be both mine and the long-time co-organizer and friend of ERC project, the president of Special Economic Zone Starachowice, Mr. Martian Pesz. Okay. I don't know this. Okay, it's Eric from Germany. They still cannot believe it. Guys, congratulations. Yeah, it's you, yeah. Okay, thank you very much. It's amazing. It's amazing, absolutely. Of course, I would like to congratulate all the winners, all the teams. Now, okay? Now? Yeah, that's the winner face. That's the winner face. Okay. Congratulations to all the teams, really. You were fantastic. You were fantastic. It was a pleasure to host you, though remotely here in Kielce on ERC 2020. But I have to close this. I have to say goodbye to ERC. But I would like to invite all of you to the 7th edition and see you next year. Zeszliśmy z anteny.
Dear all, I can hear that Germany has won. Congratulations. Congratulations to all the participants of this year's edition of ERC. It's absolutely amazing that in spite of all these restrictions, challenges, and the obstacles, we managed to have this organized, to have it all pinned together, and that we made it possible for the teams to join us here, at least virtually, and that they partook in the challenge and the competition. Let's once again see who the partners are and the sponsors, those without whom this event would not have been possible, because they are owed a big thank you. For me, ERC 2020 was an opportunity to talk to an astounding number of amazing people. Lewis Hamlin of JPL. We've had the opportunity to talk about Europa Clipper, That is the mission that is going to Europa, the moon of Jupiter, to see whether there might be some life on that celestial body, whether there's any life possible in that moon's oceans. Amazing people about whom we read and hear in the news. You can hear me talk about them in Astrofaza. And this time it was an opportunity to talk to them, face to face. Usually at ERC, when this hybrid form is not imposed, in which everything is online, it's also an opportunity to meet them in person. This is what ERC is about. We talked to Peter Worden today, who talked to us about breakthrough initiatives. You've had the opportunity to listen to that conversation right before the prize awarding gala. It was a great opportunity for me because I read about Peter, or Pete as he likes to be called. He was my hero of that generation that were the pioneers of space for us. And I had a real conversation with him face to face. I talked to him about his plans, breakthrough initiatives, and their perspectives on the future. And before that, at noon, there was this conversation with Artemis, who told us all we wanted about possible space missions, Martian missions, what we have to do to achieve that, what the challenges are, and where we are on that road towards Mars, towards sending people to Mars on this timeline if we want to get to Mars. Anna Waszak, PhD. Anna, kindest regards to you. Thank you very much for being with me in the studio. We talked twice during this event. Many thanks for being with us. We learned so much. We learned so much about geology. Unfortunately, we didn't have the opportunity to talk to geologists, but I'm sure we'll find time in Astrofaza to talk to them about how they prepared the Mars Yard, because the Mars Yard is an absolute gem. I hope that next year we can be all here in person and that you will have the opportunity to almost touch the surface of the moon here in Kielce. Beautiful. Absolutely beautiful. Dear all, we have not finished watching the whole video about the sun that we started today. Let's have it finished, because I know that some of you have been waiting for the other remaining part of that video. So let's play it now, and afterwards we'll say our goodbyes. Once again, many thanks and congratulations to all the winners and to all of you, to all the participants. It's amazing that you were here and you managed to be here virtually, and congratulations to all the finalists. I'm sure that we'll hear about you, or even I might have the opportunity, hopefully, to talk to you on Astrofaza about your projects and the future conquest of the space.
if it causes any problems, as not every operator will check the installation in the very same manner. Here, in turn, we can see a heating system. These are usually two large pipes in which we can place a robot. As we can see, there are many obstacles there and high temperature. Another risk is that the robot will get stuck in this environment. These are inspection robots of today. Here you can see some pictures of two models. They are operated by some well-known companies. eBac on the right, which we could see in the previous photo. These are construction on wheels, but also there are also Caterpillar versions. But they have similar disadvantages. In case of driving robots, every obstacle encountered stops a robot, and it has its long and stiff wire which limits its movement. That's that for the conventional inspection robots, and now let me move over to walking robots. In terms of walking robots, they have limbs. That means that if they encounter a high obstacle, they may jump over them. On the picture, you can see one prototype of a walking inspection robot designed by us, MAP Robotics. It is a typical construction that we tested last year in the installations, as you can see it on this picture. Walking robots in the world. In terms of walking robots, there are some important players of that industry implementing that technology. Here you can see some examples. On the left, it's a robot designed by Animal Sea from Australia and from Boston Dynamics, and Atlas, which represents humanoid robot. These companies are pioneers in the industry of walking robots. However, there are some competitors from Asia and Europe and from the US, which always want to meet that challenge. The inspection objectives are addressed by Boston Dynamics and Antibiotics. These two companies try to provide a robot for construction inspection and on drilling platforms, oil platforms. Modern walking robots. They are very much alike robots like Spot or Animal. They give vast opportunities in terms of their mobility. They can overcome high obstacles, turns, and this is their advantage over Caterpillar and wheeled robots. They have high flexibility and dynamics of movement. They can jump or run. In the modern walking robots, the dynamics count. in the films from the past, we could see that they lumbered, they were too heavy and not very flexible. This generation is totally different. You will easily find films on the internet and see how the robots jump or run. We owe it to a totally different approach to propellants and to engines. Before, engines with high gear ratio were used, and they didn't allow for dynamic movements because of the construction of gearboxes. Now, they use large engines with low gear ratio, and thanks to that we can benefit from a totally different dynamics. On top of that, such an approach to engine limits the overload and result in a little resistance between force and drive. Without any visual interface, they can detect that they have two legs on the ground. Thanks to that, their sensors used are very integrated and integrate many techniques aiming at successful control. These robots can see and feel what they have under their feet. It is important, especially for walking robots, because depending on the floor surface, they can adjust its stiffness and pace. So they act totally intuitively. They go through a muddy terrain in a totally different manner than on a hard surface. What is implemented in new robots, these are manipulation possibilities. Some units are equipped with manipulators. Thanks to that, they have higher capacities, but we have some certain also only limbs where you can press buttons, you can move things, and these are tasks which are out of possibilities of traditional robots. So they adapt to various conditions. In the modern robots, control algorithms and engine make it possible that walking robots adapt to very differentiated conditions. You can control the force exerted on the ground, and it's combined with the vision systems. That's why you can plan the route. Robots know exactly its destination, and it knows what to expect from the surface. It can operate on a hard surface and on a sandy path. Now, they use machine intelligence, the development in deep learning and machine learning, as well as stronger computers processing parallelly, make it possible for us to implement even in small structures of deep neuronal structures and networks. Robots know how to think and generalize. So we can construct robots which improve their walking algorithms on their own. It gives a lot of opportunities. We may use them for many different new tasks. We meet robots everywhere. all in all, when it comes to the modern inspection systems, robots which are now being constructed. Okay, so the Germans, the winners of ERC 2020, my congratulations. Łukasz Wilczyński is with us. Łukasz, please tell us what happened. I could see they were very happy, as his face was just frozen. It was incredible. We were so excited. I can't remember the finals like that. We can say that for the first time ever we had this ex aequo tie result. They did a lot of effort. I can remember them participating in the first editions. They had a yellow Rover with yellow tires, so they were very visible, great team, great people. I observed them working last year. They were very professional. They were great. And so they worked hard. I can see that we have the Czech Republic as well. They ranked us third last year, so that's also a great team. They are present at ERC, but also on many other competitions, even in the Arabic countries. The first team which debuted during such Rover challenge was ranked as the third one. So I don't know how to read it. Roverowa, maybe we should read it as in Polish, Czechia or the Czech Republic, because they use a new name. We did it as the Czech Republic because probably they got accustomed to this name. The Germans were highly professional. We could see it from their preparation in many, they were performed well in many different tasks. Of course, we will announce the full scoring with split into given categories. So we will have an access to that. For it came as a surprise because we didn't have such distinctions, such special awards, but we came to thinking that, oh man, sometimes they work so hard, they don't win, but they did something really well, and it is worth to distinguish them. Can you remember there was one team, they won 3 tasks in a row, and they were distinguished for that. I would like to say that they will leave Kielce with the prizes. We will send them by mail, but I think that they are happy despite this remote edition. It's so sad they are not with us. It's a real pity they couldn't join us, but that gave us valuable feedback. They could eliminate some problems, for example, in terms of money, financing, because many projects were closed until the end of the year. So this shot of energy, sometimes it's the only chance this year to say, well, we did it. We did it really well. So that's great, and I would like to congratulate to all the teams on their achievements, because we just named the best, but all of them qualified for finals. So if you are running, if you complete the marathon, you are a winner already. So the fact that you are not first, second, and third place, it means nothing. So we are living in weird times. I think that ERC 2053 will be held on Mars. Oh, have I said that? I will have to find money for that in my budget. So start today, yes, but interplanetary challenge would look interesting, but who knows? maybe it would be possible. We need a small Elon Musk startup, but he will take people, and I need somebody who will bring water to Mars. We need a lot of water to run, and there will be more running on Mars for sure. Yes, it was a lot of. Do you have any summary, any facts and figures about ERC, the numbers which I may quote? This is the one global system for operating robots with so many continents at the same time. Nobody did something like that, and we added something from ourselves to that software. So we are really proud of that achievement. I think that it was a great promotional campaign for the Leo platform. It did well. It was so successful. This setup ERC edition is available on the website. Yes, and there is a commercial version available on the producer's website. So check. There are some open source version, but the one which was made especially for this ERC. It is one of sets available. You are a double streaming, Polish and English, free because we have Facebook streaming, and we broadcast in 2 languages. So we have 3 streamings, 3 yours. We had a streaming from the conference, a separate one. And it was English streaming. We had show zone streaming, Carol. One that was for our competitors, for the teams, and a separate streaming to connect with the presentation and Mars Rover Challenge and Pyramid. Please don't show me that finger, please don't do that. Oh, nice. Okay, so many live broadcasts. I'm sorry for all technical problems. We're sorry for any inconvenience, but it was the first time for us, and we had only 2 months to prepare all that. And I think that despite the fact that sometimes we had to struggle, but people say that was incredible to take part in such a complex event. About 70 volunteers. Not all of them here, some of them available online, working remotely, GRE members, most of them here with us, some online. What else? The co-organizer was European Space Agency, so we will measure the outreach a lot. For sure, we will not count people in the show zone because we had to limit the traffic there. What was another curiosity? For the first time ever, you could control rovers and operate them because 2 of them were available, some of them were available to the visitors, and our visitors, people who visited us for the first one, or could control them and steer. Part of teams stayed at home, and some of them came for the demonstration zone. And from me, I have to say that was a great challenge to organize it. Also from the technical part, the Kielce is a beautiful town. Welcome everybody, please visit us. I was born in Kielce. Oh, I didn't know that. Yes, I come from this city. So I highly recommend visiting here. That beautiful city. Yes, that was a technical challenge for sure, as we describe it, because the connection, the communication between the teams. I understand why Apollo mission was a challenge, because they have to combine many teams and meet in this hub. But I think that we made it. Yes, it was good. Of course, we will try to learn from this edition and make it even better next year, but we did it. Some things were done for the first time by us. Nobody did so before. There were some DARPS models because we got inspired by them in a sense, but they didn't give us a ready-made formula how to do it, the instruction, please this and that, do this and that, and you will have a DARPA-like challenge. No, it wasn't so simple. Some elements had to be designed by us. We had great teams, two universities of technology, Leo and Szymon, and a lot of things you didn't. So you participated in our long Zoom session. We started at 7 p.m. We ended at 10 p.m. 20 people sometimes, and we had it since July. So we a lot of effort and energy, and that group was managed remotely as well. So of course we visited Kielce, but many things were done in a hybrid version. Yes, a hybrid edition of the European Rover Challenge. May I say something to one person? There should be one person here. Piotr Wieslawski. Piotr is sitting comfortably in a pub. Piotr Wędlewski, head of jury, he got stuck in the UK. He was with us remotely. Piotr, thank you. We made it. We owe it to you. We changed the regulations. I know how difficult it was. Warm regards to Anna Łosiak, responsible for science. It was great. It was miraculous what you did with science task, and we have a lot of new ideas, but please give us some time to rest. We'll be back for sure, I think tomorrow. Okay, so today you can relax, and tomorrow you start with ERC2021. No, I have to settle that. I have piles of invoices, reports and settlements. No, it's not like in NASA, rovers and exciting words. I'm drowning in papers. It's like in a corporation that when you deal with it, you get new ones. I talked to my colleague, you cannot drink a wine in Georgia and leave your glass because they fill it in all the time. I'm very happy. But this is my never-ending story with all this paperwork, but I love this work. And I would like to say thank you to one person, my dear wife. I love you, honey. I know that I was absent. Even I was there, I wasn't there, in fact, because I was on Zoom. So thank you for your support. That is great that we have this outstanding opportunity to meet at such events like ERC, that we can see all these young people involved, engaged and getting inspired and motivated. We will surely hear about them in relation to some space mission, to some technical solution, or maybe some facility that we are going to use. It's not only about technology. When I talk, you know, Kamil, there are people involved in law, in other sectors. You didn't see the one of editors, Katarzyna Malinowska, Professor Katarzyna Malinowska, head of space studies on Koźmiński University, a lawyer, in fact. So they organize this space industry, so they do something which we need. Space is for everyone, and during this ERC event we had many opportunities to meet different people. There is space art as well. We were talking about books. So remember, space is for everyone. Thank you very much. So let's me invite you to next edition, 7th edition next year. I have to, if my team, my dear team, if you would like to give me a gift, you have to replace my calendar and I have to rearrange it. The seasons are not important. My most important season is the ERC season. So that's the end of our live broadcast, 3 days that we spent together. Thank you very much, and let's meet in a year. And now time to relax and time to some time for yourself, for the organizers, and round of applause to all of you. Thank you very much. Łukasz, my congratulations. Thank you very much on behalf of I want to thank to volunteers. That wouldn't be possible without you. Thank you very much and see you. Bye bye.